Hello everyone and welcome to this session on cloud computing full course. There are various reasons for which cloud computing has become a buzzword and is increasingly gaining importance. In fact, it has seen the fastest adoption into mainstream life than any other technology in this domain. Cloud computing is the on demand delivery of IT resources over the internet with pay as you go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as needed basis from a cloud provider, just like Amazon Web Services. In this session, you will learn all about cloud computing. So let's see the agenda for this session. First, we'll be talking about introduction to cloud computing. Then we'll be talking about cloud computing use cases. After that, we'll be covering how cloud computing works. Then we'll be talking about overview of cloud security. After that, we'll be talking about identity and access management in cloud. Furthermore, we'll be talking about AWS services. We'll be also speaking about load balancing. And then we'll be talking about virtual private network. After that, we'll be talking about AWS DynamoDB. And then we'll be covering AWS interview questions as well. So that's all with the agenda. Now let's start the session. But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
Now, what is the cloud computing? We all know cloud computing is when you use a computer server, which is being hosted on a different premises. This server needs to be accessed over the internet by using some web-based tools for personal and business use cases. So in cloud computing, the concept is that the storage, the application, the networking components, the infrastructure that we access or that we manage is not locally there. It's there in a different data center, which you may or may not own, but you access those resources over the internet. Virtualization. Now, what is virtualization, by the way? Virtualization is a concept that empowers cloud computing. Now, I came across a virtualization in 2010. I was working in Cisco and I was for Cisco support and Cisco networking infrastructure management. I was there. So we were working on Cisco UC servers and we came across this virtualization where upon the hypervisor, we used to deploy different virtual machines, the CUCMs and Cisco Unified Call Managers. So virtualization is a concept where on a same physical server, you can deploy multiple virtual machines. Fine. So it's a concept, it's a creation of virtual version of something, whether it's an OS, server, storage device, or networking resources. So basically, virtualization means that on a single physical machine, you can deploy multiple applications that are supported by multiple operating systems. Fine. Now, what is cloud computing? Cloud computing means that it is a cocktail of virtualization plus internet or intranet. So you virtualize your entire environment and you offer that environment. So for example, Amazon Web Services, it's a cloud computing service provider. It has virtualized the entire environment and offered to you over the internet or intranet. You can have your private network going to the AWS, or you can use internet. So everything that you see on AWS, it is virtual in nature. What do you mean by virtual in nature? If I deploy anything through this page, I can see that what's going on, but I cannot see the exactly physical hardware behind the scenes. If I today, for example, go to the EC2 and start deploying my EC2 instances, I cannot see that on which physical server it's running. So it's virtual in nature. At the back end, of course, physical servers are running. It is the rack of servers are mounted. So I can access those resources over the internet or intranet. And also, this entire thing is virtual in nature. Fine. So that's about the cloud computing. Now, what are the advantages? Now, today, the stage is that even the big corporations like General Electric or maybe NASA or big companies that are going towards the cloud computing platform, because when I started 8 or 9 years ago on this cloud computing platform, small to medium-sized enterprises, they preferred cloud computing domain because it was cheap in nature. It was cheaper option. But now the big corporations are going towards cloud computing. The very first advantage is that there's no upfront investment. You don't have to invest heavily into setting up your data centers. It is scalable in nature. You can get as much as you want, or you can shrink down the number of resources. So you can get a new server. It is just, you just do some few simple clicks and you get a complete server deployed. And it gives you very high availability solutions without any extra effort. So without even paying a single penny upfront, you start deploying the resources on the fly. Fine. So this is the advantage that you get over the on-premises. Now, these are different models that we have in cloud computing. Infrastructure as a service. For example, the networking components we use it as a part of the infrastructure is given to you as a service. PaaS, platform as a service, which is used by developers to get a platform on the fly, like Elastic Beanstalk. Software as a service, which means that you get a software as you sign up for that software as an end user, like Google Drive or Google Docs. So it is software as a service. For example, today you subscribe to Ola app on your cell phone. It is software as a service. You sign up for Ola and you start using that software on the fly. It is a software as a service, right? All right, so these are some of the models you can just go through. I'll not go in detail because it's just a very basic thing. Now, there are multiple cloud providers in this market. It's a very tight competition nowadays. Amazon Web Services on the top right now. It's been top since 2006. It's still on the top. It's a leader in the industry, followed by Microsoft Azure, Google Cloud Platform. We have Salesforce, DigitalOcean, and so on. There's so many cloud providers in the market, but these are the top in the entire list. Now, the company can go with any one of these three. Now, people ask me this very common question: which one should I go for? So I give the answer. Today, you want to buy BMW or Mercedes or Audi. It's your preference. All these are luxurious brands. So what I'm saying is that all these three providers are one of the best in the industry. Whichever suits you the best, you go for that. But as now in the competition, AWS is leading ahead. Now, why it is leading ahead? Because it started it was the very first cloud service provider that started. Microsoft Azure started, I think 6 or 7 years after it was started, and then GCP started. So AWS got the first move advantage. So in the industry, whichever competitor starts the service the first gets an extra edge. Fine. Also, AWS is very innovative in releasing new versions of the services very frequently. Fine. So AWS is one of the biggest cloud service provider, followed by Microsoft Azure, and then we have the GCP, that stand for Google Cloud Platform. Fine. Now, what is AWS? AWS is the on-demand cloud computing services to businesses and individuals. It's on-demand. Now, what do you mean by on-demand? The thing is that there's no upfront commitment you have with any provider. You sign up and start using it. It's a subsidiary company of Amazon.com. We all know what is that. This is the biggest e-commerce platform on this planet, which specializes. It also specializes the Amazon Web Services in providing the infrastructure as a service. Now you can use this platform to help the business scale and grow. And you can use different services like compute, content delivery, database storage, and other functionalities. Okay. Now, okay. So the thing is, AWS has rich of different on-demand services to provide, and there are different categories of services. Like we have compute, networking, storage, database, analytics, machine learning, and so on. Even the access management. So AWS has created different containers of services, that multiple services under compute, networking, storage, and databases. Fine. Now, the thing is, let's do one thing. Let's go back to the AWS. And I don't like going through the slides very often. Let's look on this page. See, the thing is that as a solutions architect in the future, you'll be using this page a lot, the most, to deploy, manage your infrastructure on the Amazon Web Services platform. Now, the thing is, If you go to all the services, you can see that these are different categories of services that you can access, and that's okay. You can leverage these services on the fly. But at the right hand corner, you will see that it shows you the display name of the account. I'm just okay for, let me just change my account information. I can do it afterwards. So the thing is, if I go to my account, basically the thing is that this account that I'm using right now, this is a root account, right? This is a business account as right now. And I can, if I set the account name, I can put that, for example, let me just sign in real quick. Now you will see this is a root account. Now root account is the one that you sign up using a credit card or debit card. A root account is the account that you sign up using a payment information. So payment information is included at the time when you sign up. That's called the root user. Root user gives access to multiple IAM users. Fine. So root user is a parent, IAM user is a child. We'll discuss that afterwards. So whenever a company or an individual signs up with AWS using a payment method, whether it's a credit or debit card, that account becomes the root account. Okay. Now mine is a root account and it's a business account. It's not a free account that I'm using right now. It's a business account. And let me sign in real quick in front of you. All right. So I just signed in front of you, and I can change, for example, my account name. For example, I can just type in, for example, Intellipaat, something like that, and click on Save Changes. So the thing is that the account name is not that much important. The main thing that every root account has a unique account ID. So when, for example, you contact the support team at the backend. So you have AWS contact team behind the scenes. You want to open a ticket with them. They will recognize you using account ID, because account names can be same, but the account ID is unique. Fine. Now the thing is, if I show you if I go to support and go to support center, I can see my account information over here, and also what are the support options that I have. So for example, in a business account, you also need to open tickets with AWS, just in case if you have some issues out there. Now you can see that I have a business plan. Because sometimes I use this account to deploy huge infrastructures. So this is my business account, and I can get some support from them. In a free account, the support is very limited in nature, but that's fine. You don't have to get support in a free account. So the thing is, you can see your account information, you can sign out from here, but the main thing I want to show you is this one. On the right-hand side, these are regions. Can you see that? We have US East North Virginia, US East Ohio, West California, West Oregon, Africa, Cape Town, Hong Kong, Mumbai, Osaka, Seoul, Singapore, Sydney, Tokyo, Canada Central, Frankfurt, Ireland, London, Milan, Paris, Stockholm, Bahrain. So in South America, we also have a region. What are these? These are the point of presence. This is where AWS has its own infrastructure running. Fine. This is where the infrastructure, AWS owns its own data centers over there. Fine. See, the thing is that you might be seeing this web page, but at the back end, a huge infrastructure is running across the globe. And they have set up this infrastructure in the form of regions. Now, see, as of now, they have 24 launched regions. What is a region? It's a geographical location. It's a piece of land on the globe where AWS is running its data centers in the form of availability zones. Okay, I'll get into the technical information afterwards. But if you see the map, the blue dots represent the existing regions. For example, this is on the west coast of US. These regions are on the east coast in India. So the one that is India, Mumbai. So the one that is showing you as the blue dots, the blue circles are the existing. Orange ones are the upcoming, which are planned, which you will see soon, maybe in a few months or maybe in a year. So as of now, they have 24 geographic regions. So that they're planning to set up in more in Australia, India, Indonesia, Israel, New Zealand, Spain, Switzerland, and UAE. So you will see that they'll expand to other regions. So the thing is, if you just go at the top right hand corner, let me just go back one more time. Each region, so as a solutions architect, you have to understand that each region is a separate piece of infrastructure. For example, right now, the dashboard that I'm signed in is in Mumbai. You can see that the URL is different, AP South 1. If I change to, for example, let's go to Virginia, you will see the link will change, US East 1. But why? Well, let's go to Stockholm. You will see that at the top, the link will change. See, one thing that you have to understand is that each region is a separate entity. It's a separate entity. It is a separate set of infrastructure which is being managed as a whole. I would say that if anything that I deploy in the Stockholm will be completely isolated if I deploy anything in Singapore. If I deploy anything in Stockholm, the resources will be contained in Stockholm, and the resources that I deploy in Singapore will be contained in Singapore. Every region is unique. It is separate and isolated from other regions. Yes, there can be internal dialogue, or the data can be synced. The data can be copied over. That's absolutely possible. The thing you have to understand is that each region is a separate entity. Now let's do one thing. Let's go to Mumbai, and if you want to access Mumbai resources, you have to switch back and forth. Or maybe for example, I want to access Stockholm. I have to switch back and forth between different regions so that I can access the resources in that specific region. Fine. So each region is a separate infrastructure. It has a unique identity. And if you deploy anything in one region, then or different regions, then you have to switch back and forth between different pages to access the resources relevant to that region itself. Okay. Now, so what is a region? Again, I'm saying one more time, it's a piece of land on the globe. It's a geographical location. It is a particular location where Amazon Web Services is running its data centers or cluster of data centers in the form of availability zones. Fine. For example, right now, the region I am in is in Mumbai. Fine. So I go to so guys, I'll take all the questions at one single lot once I'm through with the concept. So let's go to the EC2. Now, EC2 is a service through which we can deploy some virtual machines. Fine. Let's go to the EC2. Let's do one thing. Let's understand exactly that how this functions, how exactly you can access the resources or data centers. So I go to EC2 dashboard. Why I'm going to EC2 dashboard is that, okay, let me just go back to Mumbai one more time. Okay, let's go to Stockholm. So let's suppose we are in Stockholm. I'm going to deploy my virtual machines in Stockholm, the instances. Now you will see that in Stockholm, these are the 3 availability zones. And they have been termed very differently. Now, how this functions? See, the thing is, let me do one thing. Let me just bring down my iPad screen. Just allow me a few seconds over here, and let me just try to explain the concepts using the whiteboard. Because what I find is that explain the concepts using whiteboard is a bit more easier. Fine. Let me discuss the concepts with you right now. So right now, the things that we are going to discuss is the AWS global infrastructure. So just in case if you have some visibility issues, if not able to view the screen, just let me know. So the thing is, right now, we're going to discuss the AWS in the global infrastructure. Let's imagine one thing. So this is what we're going to discuss right now. This is the global infrastructure. Now, let's imagine that this circle that I've just created in front of you, this circle, yeah, this circle represents Stockholm region. So for example, this is Stockholm So this is the region of Stockholm. So I'm saying, okay, this is my region of Stockholm. Now, the thing is that AWS has denoted a special name to each region. For example, Stockholm is represented as EU North 1. Let me see that. Yeah. So they say that EU North 1 is our Stockholm region. This is what we have, EU North 1. This is the region of Stockholm. This is the region of Stockholm. Now, in this region of Stockholm, which is represented by a special term, EU North 1, we have 3 availability zones. So what are these availability zones? These are the data centers. Fine. So these are 3 availability zones that we have. Fine. So let's label them as, for example, so this is, for example, this is EU North 1A, EU North 1B, EU North 1C. So what are these? These are your availability zones. So what are the availability zones? These are the data centers or a cluster of data centers. In the short form, we label them as AZs. Fine. Now, these are the 3 availability zones in the region of Stockholm. So if you go back to this thing, EU North 1A, which is this one, the top one, EU North 1B, and EU North 1C. So EU North 1 is the region. So EU North 1A, EU North 1B, and EU North 1C are the 3 availability zones. And these availability zones are connected together with high-speed fiber optic cables so that you can synchronize your application and your workloads across these different availability zones located in the confinement of a region. So Stockholm is represented by EU North 1. So EU North 1A, EU North 1B, EU North 1C are the 3 different availability zones located in the region of Stockholm. Fine. So what is availability zone? It's a data center. Basically, we call one AZ as a one data center, but sometimes an availability zone can consist of multiple data centers. But generally, we assume that a single availability zone represents a single data center. Now, each region will have at least 2 different data centers for the redundancy purposes. For example, I'm just giving you one example. What if this availability zone goes down? You can use this one. What if this goes down? You can use this one. What if this goes down? In that case, you can also use a different region. As an architect, you have to understand that what are the processes and strategies you can incorporate, or you can use those processes and strategies to make your application more redundant, highly available, so that if a data center goes down, I would say availability zone goes down, or the entire region goes down, then how you can make sure that there's a continuity of your application. Your application never goes down. It's up and running. Maybe it is served from one region or a different region. Right? So this is how an infrastructure looks like. Okay, let's take 2 more examples so that we can have better clarity of this concept. Let's take another example. Let me just go back let's go to Mumbai. Now, Mumbai is in Asia Pacific. It's in India region. Now, Mumbai is denoted by, if you see at the top right hand corner, it is denoted by the AP South 1. AP South 1 is the Mumbai region, which consists of 3 availability zones: AP South 1A, AP South 1B, and AP South 1C. So AP South 1A, 1B, 1C are located in which region? AP South 1, which is the Mumbai region. Let's take one more example. Let's go to, for example, Virginia. Now, Virginia is the very first region they started with. This is the oldest and the first region. And if you see Virginia, it is denoted by US East 1. And if you start looking into its availability zones, it's US East 1A, 1B, 1C, D, E, F. Fine. So that's how you can choose from the region and the availability zones from the list. So what is an availability zone? See, availability zone, one availability zone generally we assume as a one data center. So this is the first availability zone, second availability zone, third availability zone, fourth availability zone, fifth and sixth. Sometimes one availability zone can also have one or two different data centers. But just for the ease of understanding, we assume that an availability zone is a single in-house facility. It's a data center which consists of a rack of servers, and each region consists of at least two different data centers or availability zones to give you high amount of redundancy and availability, so that if few of them they go down for any reason. See, the thing is that the natural disaster is not in the hands of a human being, whether it's a calamity, it's a heavy rainfalls, fires and floods. So if one data center goes down or two data centers go down, at least you can leverage your data and services from other data centers. There's an average distance of 60 kilometers between different data centers. Between two data centers, there's an average distance of 50 to 60 kilometers between two different availability zones or data centers on an average. Fine. So that's how you can leverage the regions and availability zones on this page. Fine. Now, again, I'm saying you have to treat each region as a separate infrastructure. If you deploy anything in North Virginia, it will not show up in Hong Kong. If you deploy anything in Hong Kong, it will not show up in Canada. Fine. Each region is a separate infrastructure. You have to switch back and forth between different pages to access the services and resources in that specific region of your choice. And you deploy your databases, your web applications in different availability zones. Fine. Or data centers. You pick the data center. You have the option to pick the data center of your choice, the availability zone of your choice, and you can start deploying your applications on the fly in that specific availability zone or the data center. Fine. Now, these are the two main pieces of the infrastructure. We have multiple pieces which are optional. For example, if you go to the infrastructure, you also have local zones. Now, what are the local zones? Local zone is a fair new concept, still not being used too much. Basically, local zone is nothing but it's the extension of a region. For example, if I just go to Virginia, let me just go back to Virginia. It's not available anywhere. I can click on enable additional zones. And these are the local zones for Virginia. Local zones means that I can scatter my resources, for example, in Boston, Chicago, Dallas, Houston, Kansas City 2, Miami, Minneapolis, Philadelphia, right? So this is the extension of the region. For example, today you want to deploy your resources in North Virginia, but your main user base is in Chicago. You will say, okay, let me deploy my services in Chicago, because for example, you want to deploy an in-house customer management service application, a CMS application. Your office base is in Chicago. So you're saying, okay, let me pick Chicago, because if I deploy the services in Chicago, then the people who sit in Chicago will be able to access the services much faster, because the data center is in Chicago. The data centers are in Chicago. So in that case, I can deploy my services in Chicago. Maybe you have your in-house application to be deployed for people in Boston. You can use Boston as a local zone and start deploying the services. Local zone, as I said before, it's a fair new concept, still not used that much because it's not available in every region. But it's the extension of the region so that you can scatter your resources in different parts of that specific geographical location. Fine. So don't put too much stress upon that. It's a fair new concept. The main thing that you have to understand is the region and the availability zone. Wavelength zones are used for 5G applications, 5G compatible applications. You will not use that. Fine. We also have edge locations that we'll discuss afterwards. But the main thing that you have to focus on is the regions and availability zones. Fine. Now, one thing that you have to keep in mind is that not every service is available in every region. Fine. Most of the services are available, and also the pricing is different. The things, for example, today I deploy, I consume 1 GB of data, or for example, I deploy a web server in Virginia. The cost per hour will be different compared to the server that I deploy in Singapore. The web server that I deploy in Singapore will be different from the one that I deploy in Paris or Stockholm. Now, why the cost is different? Because the cost of infrastructure is different in different parts of globe. The cost of the electricity, labor, because they have to lease out the entire space. So electricity, labor, backup. So the cost of infrastructure is different in different region. So in that case, you have to pay different prices for the same resource based on the region that you have chosen. For example, Singapore is a costly region from what I understand, because Singapore it is one of the costliest of the based on geographical location. The cost of the land is very high. Even the labor is very high. Like London is very costly. The thing is that the cost of land, infrastructure, labor, electricity. So the cost of the infrastructure, the input that AWS is putting in as a monetary input. So based on that, the cost of the region would be higher for some region. For some region, it would be moderate. For some region, it would be lesser. But that would be very minimal if you see if you go by a single resource. But yes, so this thing you have to understand, the cost of the infrastructure will change based on the region of your choice. So once you start deploying your entire infrastructure as an architect, you have to pick that which region is under your budget. Because, for example, you want to deploy 1,000 servers in London. And if you deploy the same 1,000 servers in Mumbai, Mumbai will be cheaper as compared to London. I'm just giving you one example. Fine. So the cost of infrastructure will change based on the region that you have chosen and you have deployed your resources into. It will make a huge difference in that case. Fine. That's about the regions and the availability zones. All right. Yeah, that's it. It all depends upon company to company. Or what they can say is that they can pick the cheaper. They can go with weighted routing. They can say, okay, 50% of the traffic is sent to Singapore, 50% of the traffic is sent to Mumbai. So they can scatter the resources half between a costly region and the cheaper region. They load balance the traffic. So they will say 70% of the traffic will be sent to cheaper region, 20% will be sent, 30% will be sent to the costly region. So there can be different strategies out there based on each choice, preference, and priority. Kaushik is asking, one service available in zone A, is it available in zone B? Yes. I'm talking about the data center. See, the services are available based on the regions, not the availability zones. So in every availability zone, so if you go with the region, if you have 3 availability zones, all the services are available in all the zones. Local zone will have high priority for that region compared to other zones. Let's not, okay, whenever you go with the local region, whenever you go with the local zones, for example, let me just go back to this AWS page. Let me just go back to the EC2 page real quick so that we can discuss that concept. See, the thing is that it's not about the fight between availability zones and local zones. Don't confuse these two things. One thing that you have to understand, a local zone is the extension of the region. Fine. Data availability zone is the part of the region. Local zone is the extension of the region. It's not about the priority or what's the importance that be given to us. It's all about the requirement. Fine. See, the thing is, if I deploy my services in North Virginia region, then my as per the geographical location, these 6 data centers are in North Virginia. If I go with geographical location and I choose all the 6 availability zones in North Virginia, then my services will be restricted in that specific geographical space. What if I want to go further and deploy the services in Boston, maybe in Chicago, maybe in Houston? Fine. So I want to scale out. I want to outreach to other location. So there's no competition between that or priority that availability zone will get more preference or which local zone will get the preference. It all depends upon it how you have architected your application. Fine. So if you architect your application to be deployed in North Virginia, it will use any of the 6 availability zones. If you architect your applications to be deployed in Miami, it would use the data center or data centers in Miami. So a local zone is nothing but it's the extension of the region. Karthik is asking, redundancy for regions or only for AZ? You can achieve you can make the things redundant across AZs, across regions. All but local will be a bit faster compared to other location. Geographical space, for example, fine. And you have 250 users in Minneapolis, and you want to make sure that they can get a faster access to your application and services. For example, you want to deploy a customer management software for 250 employees in Minneapolis. Now, you specifically choose this local zone so that the people in Minneapolis can get a faster access to your application, your customer management software that you have deployed in this region. Yeah, of course, it will be faster. That's why we have used that. It has done it. See, the thing is that even though you're using one of the best infrastructures out there, things will go down. Fine. For example, I was using Frankfurt 2 weeks back. It was down for some reason. So things can go down, and it is inevitable. It is inevitable. For example, I can tell you the example of Mumbai. In Mumbai, we have so many heavy rainfalls, right? And there are floods coming in. Even today in Delhi, there was I was coming back from in North India. There was so much of rain, there were floods out there. So the natural calamity is not in the hands of a human being. So even if you have the best infrastructure out there, the things will go down. So I've seen availability zone going down many times in my career with it on AWS, or I've seen the entire region going down. I think 2 years back, the entire AWS went down. So the thing is that availability zone will go down, and that's why we are here. We have to architect the application in such a way that if the availability zone goes down for any reason, it will go down because it is inevitable. It can be a technical glitch, it can be a human error, it can be a natural calamity, anything. So yes, I've seen that it has gone down many times. It will go down for you as well. So as an architect, you have to cleverly plan the infrastructure so that if something goes down, you have the backup plan. If I give you the brief overview of this question, basically what we do is that we, as a basic plan, we go with horizontal scaling. So we have multiple instances, multiple virtual machines running the same application. For example, I deploy 10 virtual machines with the same application running upon them, and I bind them with a single domain. I scatter those 10 different application servers across 2 different availability zones, or maybe I scatter them across 2 different regions. Now for that, we have to use some services like auto scaling, elastic beanstalk, load balancer, Route 53, global accelerator, right? So the answer is that we have to use some services and some tools, some strategies and processes to make it happen. And that's why we are here, to understand that concept. Can we create a virtual data center for backup? See, these are the virtual data centers only. They're already there. You can't create anything special over here. See, these are all the virtual data centers only, right? There's nothing new you can create. You can use the one that already exists. Okay, fine. So what is this identity and access management all about? Let's discuss this concept. See, in your organization where you work right now, maybe in ISRO, maybe in NASA, Accenture, Wipro, HCL, wherever you're working right now, you have an identity over there. As an employee of that organization, you are given an ID card. You have a job profile. You have the roles and responsibilities being linked to you. And based on your job profile, you are being given some types of access. Fine. So similarly in AWS, when you start working for any company and start leveraging their services on AWS, for example, you work for Wipro. Wipro has its infrastructure or its client infrastructure on AWS. So use their account to manage infrastructure. Now you as an employee, for example, so you're from IT, you are from IT team or software team or testing team. So you're from IT software background. You as a professional from IT software background, you'll be working Wipro or its client to deploy and manage their infrastructure on AWS. Now, these companies will create IAM accounts. They will create some accounts for you, and based on your identity, whether you're a developer, a testing professional, a system administrator, a database administrator, whosoever you are, you'll get some access. And that's what it's called, the identity and access management. You're given an identity based upon which you're giving some access. And the management of these two things is called the identity and access management. So IAM is a web service that helps you to securely control access to the resources. So the identity and access management is kind of a web service that will help you to get access to the resources. Use IAM to control who is authenticated, which means that who is signed in, and what type of permissions you get. So for example, you are a developer and you develop and deploy the applications on AWS platform. For example, you develop Node.js applications and you deploy it on AWS. Now you as a developer, you are authenticated. So I'm saying I'm a Wipro owner or a CEO or I would say the manager of a business unit. I say, you are my developer. I give you the authentication to sign into my account. And you are given some rights. You'll be given access to some developer tools. For example, code commit, code deploy, code pipeline, code build, Elastic Beanstalk, CloudFormation. These are some other developer tools that are used on AWS. You use Wipro's account. You sign in using your own ID and password. And then based on your job profile, your roles and responsibilities, and also business unit and team you're in right now, you'll be given some access to some services. Fine. So we control using IAM that who signs in and what type of access he or she gets. Okay. So whether you're an administrator, a web developer, a data scientist, based on your job profile, your team, your business unit, you get access to a few different services and resources. Okay. We'll discuss these Amazon resource name afterwards, but let's discuss I'll discuss the components first. So this, for example, this is the root account owned by Intellipaat. Intellipaat wants to deploy its LMS, the LMS you're accessing, right? Intellipaat will have its software developers, its testing professionals, system administrators, who will help Intellipaat to deploy its LMS and manage it on AWS. Now, Intellipaat will say, okay, let me hire developers and I create the user ID and password so that these people can access my account. It's like I have a house, I lock that house, and I create duplicate keys for that, and I distribute to you. So Intellipaat is saying, okay, it's my infrastructure, it's locked, so I'll give you different keys to different people so that you can barge in and use my account. So I will create different accounts, I'll create accounts for different people in my IT and software team so that they can help Intellipaat deploy and manage its learning management system on this cloud platform. Okay, so how to use our services? You just go to all services under the management and governance, or I would say under security, identity, and compliance, you can see IAM. Else, because there's so many services out there, you can click on, just go to search for services, just type in IAM, and it will easily populate that specific service for you. I go to IAM, and this will just land me to the IAM page. This will land me to the IAM dashboard. Now, for the IAM, you don't have to switch between different regions because this is a global service, which means that if you create any user, then he can use the services in any of the regions. So IAM does not need you to select the regions. Now, let me do one thing. Let me just remove the previous configuration because it will confuse right now. So this was created a few days back for one of my batches. Okay, so this is the digit. Let me delete the rules. So you will see that this thing, this is deleted. Now, the thing is, this is called the IAM dashboard. As of now, this is completely blank. This is the dashboard. I don't have any users, groups, roles. I have some roles and policies. We'll discuss that afterwards. But the main thing that you will see that I don't have any user. Now, who is this user? A user is any person in my IT and software team. It can be a solutions architect. It can be a developer. He can be a DevOps professional. He can be sysops administrator. It can be database administrator. It can be a Linux professional. Any person in my software and IT team who will be logging into my account through his credentials and performing day-to-day operations, whether it's deployment, implementation, provisioning, management, testing, modifying the resources, and so on. Okay, so let's go to the users right now, and let me just start creating some users on the fly. Now, what's an IAM user? You can see that the definition, it is an identity with long-term credentials that is used to interact with AWS in an account. It's the identity. It's a user. It's an actual user. Okay, so what we do is that we need to click on Add Users at the top right-hand corner, and this will automatically just open the username stuff in this case. Now, the thing is, I can start adding the usernames. Fine. So now different companies, they go with different formats. For example, some companies go with the initial of the first name. For example, my name is Rohan and last name Arora, R Arora, or Steve Jobs, S Jobs.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Something like that. Or just for the simplicity, I'll just type in for example, the first name, right? So the first name is a username for the people to log in. Kavita, Suresh, type in Steve, type in, for example, Chris. So these are the actual people, the first name of the people who will be logging into the account to perform day-to-day operations. And that's it. So as of now, I have 6 different users that I've created: Kavita, Suresh, Steve, Chris, Mahesh, Kunal. I can add multiple users on the fly, but that's fine. I think 6 users are more than sufficient for us to test and try the things out. Now, the thing is that you will see that it says select the AWS access type. See, there are 2 types of access you can give to the people. One is access to the AWS management console, which means that they will be signing in to the AWS account, to my account, but using their own credentials. I will check it out. The second one is the access key. Now, this gives the programmatic access, which means that if I check this option, I will show you these people will get a key pair. They will get access key and secret access key so that they can programmatically access my account using an API, CLI, SDK, or any third-party tool. Yeah, I can integrate a third-party tool with AWS, but these people can authenticate using access key and secret access key. I'll show you that later on. Don't put too much stress on this information. And so I choose the type of access these people should have. Now, should I go with the auto-generated password or a custom password? Let me choose a custom password, and I will check. Okay, 1 second over here. I'll define the custom password over here. Now it says required password reset, which means that this is the common password for all the people. Now you must users this is checked by default. So once these people sign in using the custom password that you set, they get the option to change it on the go. I'll just uncheck it for simplicity. Now, so just to recapitulate that what I've just mentioned on this page: 6 users: Kavita, Suresh, Steve, Chris, Mahesh, Kunal. 2 types of access: programmatic access, so that these people can integrate, they can access AWS account using a third-party software, CLI, command interface, or any external tool. And also they get the password to access my AWS management page. I set the custom password. And now the next important thing that I have to do is that I have to assign them permissions, because what I'm doing right now on this page, I'm creating the identities for them. Kavita is one, maybe she's a developer. Suresh and Steve are my database administrators. Chris is my Linux administrator. Mahesh and Kunal are my solutions architect. But as of now, I have created some identities for them. Okay, so username and passwords. Next comes the permissions. Now permissions I'll assign afterwards, but let me show you. If I just go to the very last option, attach existing policies directly, basically we assign the permissions using the JSON policies. JSON stands for JavaScript Object Notation. I will not attach any policy. I will show you how that policy looks like. I simply click on next, add tags. Now tag is just you assign a kind of a tag to it. It's optional. Click on next, review. Now the thing is that right now, this is the review. I can review my choices. Of course, I can manipulate these things afterwards. 6 users created with 2 types of access, a custom password set for them, but these users have no permissions as of now, right? Which means that these users can log in, but they won't be able to perform anything. That's okay. We can add the permissions later on. I simply click on create users, and voila, my 6 users are being manufactured. And these are the secret access keys, access key for each of the users so that they can programmatically access AWS account using CLI, API, or other development tools. I'll show you that. I can send email. It will open email client on my Mac, and I can send them the login instructions. Now, one thing that you have to keep in mind is that you could click on download CSV. If you download a small CSV file with all this data encapsulated, because once you hit close, then the secret access key of these users will not show up later on. Okay. Again, I'm saying you download a small CSV file. Let me show you that CSV file, how it looks like. Now, CSV file takes longer time on Macintosh to open up, right? So in the meantime, what I'm saying is that download the CSV file for the future reference, because once I exit from this window, then the secret access key of these users will not be visible to me, but I can regenerate if needed. So this is what it shows up. I can see the access key and the secret access key of these people. I can regenerate this thing, but the thing is that if I exit, then the secret access key will not be visible on this page again. But that's fine. I hit close, and here we have 6 different users being manufactured. Now the thing is that these are 6 users. I've created the user ID and password for them. Let's do one thing. Let's pick Chris as an example, and let me just log in on behalf of Chris. Now, one thing I want to again emphasize: the account that I'm creating is not a special account. It is just that I've given identities to these people so that they can log into my account only. They will log into my account, but using their own credentials. Okay, so let's log on behalf of Chris. Now, this begs this question: how Chris will log in? The answer is that if I just go to the dashboard, on the right hand side, you can see that it says sign in URL for the IAM users. This URL, this link will be used by the IAM users to sign in. They can. There's also another method out there, but generally this link will be used. I can customize this link. I can click on create account alias. Now this is my root account ID. I click on account create. I can create an account alias for my root account. For example, Intellipaat AWS. Yeah, that's it. Now, the thing is that no 2 accounts can have the same account IDs, the same alias ID. If this is acceptable, click on Save Changes. Okay, it already exists. It says this account alias already exists. So some person might have taken this before. So let me make it as, for example, okay, let's increase the font size. Intellipaat AWS demo v2. Let me just give a random name. Click on Save Changes, and this is created. Now, can you see that this has changed the display format of the link? Okay, I can copy this link and use some other browser, because right now I'm using Safari. So let me just open Chrome browser so that I can use Chrome to sign in. So let me just open Chrome and just paste this link. Now, I will try to sign in on behalf of Chris. So immediately it picks the account ID or the account alias. So I've set the account alias. I'll define the username. I just type the username and type in the custom password that I've set in. Now you will see that Chris is able to sign in without any trouble, without any issues, and he is able to sign in. And if you see the format at the top right hand corner, Chris, the user ID at the rate, account ID or the account alias shows up. Chris at the rate, account ID or the account alias shows up. That's how you can differentiate between the root account. This is my root account. This one. Root account is a simple name with no @ symbol, unless you deliberately put that in this thing. But this is the root account. From this root account, I've generated this IAM account. Now, Chris is using my account only, but what he's doing is that he's using his own credentials to access the root account of Intellipaat. It's not a separate account. It is just that I've built a home, and I'm saying, Chris, here's the key, duplicate key of, and you can just come in whenever you want. Now, even though Chris is able to sign in, he will not be able to perform. He will not be able to perform any operation whatsoever. Why? Because I haven't assigned any permission for him. For example, if you just go to any of these predefined services over here, let's go to the EC2 right now. And for example, Chris says, okay, let me just try to deploy one instance. You will see that immediately he gets an API error because he has no access whatsoever. Okay, if he's trying to access any random service on the fly, for example, he wants to go to S3 storage, he'll be kicked out because as a root owner of Intellipaat, I haven't given him any access. It says you don't have any permissions to list the buckets. So he'll be kicked out from the services because even though I have given him the user ID and password to get in, but he'll not be able to perform any action because there's no policy, no permission added to him. I've given him the identity, but I haven't given him the access. Simple. He has the identity, but he has no access. Okay, so how can you give the access? Having said that, I go back to the root account, go back to the users, and I pick Chris. I'm saying, Chris, let me just assign you some permissions. Now I go to Chris. In the summary, this is the Chris account that I'm working on right now. I have permissions tab. It says get started with the permissions. This user, Chris, doesn't have any permissions yet. I click on add permissions. Now there are 3 options out there. The first one is the most effective method. We'll discuss that later on. You can copy the permissions from the existing user, but right now we'll attach the policy permission. So the policy is added in terms of permission. I'm sorry, the permission is added in the form of policy. What is a policy? These are more than 700 policies you can start using on the fly. These are default policies. The one that you can see AWS managed, these are default policies. These policies define permissions, right? Each policy will give certain type of permission to certain set of services. Now the administrator access gives you the highest level of access. What is AWS administrator access? It provides a full access to the services and resources. Now, even in your organization, you have seen that if you get some admin access, you get the full access. On your computers, if you get the admin access, you can install any software and service. Fine. Now, the administrator access, if I link this policy with Chris account, I say, Chris, I want to add on the permission to you. I give you the administrator access, then Chris will be able to access any service on the go. He will get the full access. So now the thing is that I can see the policy summary. He gets full access to all the resources in the list, all the resources. But if I show you the JSON version of it, now JSON stands for JavaScript Object Notation. Basically, these policies are formulated in JSON. Now, if you pay close attention to this JSON policy, it may look complicated, but I just try to just make it simple for you. This is the version of this policy. Then this is the statement. A statement defines a single permission. A statement is okay. Let me do one thing, which is Open the iPad screen. So right now, what we're discussing is the IAM. So over here, let's understand this thing. What is a statement, by the way? A statement is equal to a permission. So if I say statement, a statement is equal to a permission. Fine. One statement defines one permission. Fine. So one statement defines one permission. Now over here, you have to understand this thing, that in the statement, there are two types of effects. Fine. One is allow and the other one is deny. One is allow and the other one is deny. So there are two types of effects in a statement. Either you allow something or you deny something. Fine. Now in this policy, if you see something like asterisk, if you see a star on asterisk, it denotes everything or anything or all. Fine. So asterisk means if you see asterisk in a policy. So what I'm talking about is this is a part of an IAM policy. So a statement is a permission. Effects, there are two effects. Either you allow something, you deny something. Asterisk, if you see anywhere, it is everything, anything, or all. Fine. Now, the thing is, if I go back to the AWS page, what is effect? Allow. Either you allow something or you deny something. So what is effect? Either you allow something or deny something. Action, every action, any action. Read, write, change, delete, modify. Resource means service, any service. So resource means, if I say resource, I'm talking about every single resource over here, every single service. So I'm saying, if I go with this policy, action, any action, every action, all actions, read, write, change, delete, modify, anything. Resource, every resource. So I'm saying that if I allow this administrator access or I allocate this type of access to Chris, he gets every single, he can perform any action, read, write, change, delete, modify any action to any of these resources. It gives the highest access. Okay, so it is quite obvious you will not give the administrator access to every person. Maybe a team lead, maybe a manager, maybe a owner of the business unit will get the business administrator access. Okay, so if I grant the administrator access policy to Chris based on the JSON policy, I can see I allow him to perform any action to any resource, or all the actions to all the resources. We'll discuss a few more examples over here. So having said that, I click on Next Review. So I can say, okay, I want to review what I'm doing right now. 1 second over here. Now the thing is that this policy is attached to Chris username. Click on Add Permissions, and now Chris is added on. So this policy, the administrator access, I've shown in the JSON format of it, is attached to Chris account. Having said that, I go back to Chrome browser. Right now, this is where we signed in to the Chris account. If I now, you can see that he was not able to perform or list the buckets in S3. If I just make a refresh, you will see now the things were visible to him. Now able to see the buckets in my list. Previously, he was unable to access EC2 as a service. Now, previously he was getting an API error. Now he will not get that. He can delete the things, he can change the things, he can deploy the things, because I've rendered him the full access. So that's about the Chris username and his credentials. Now, the prototype that I've shown you is not the most healthy way of access management. Why? Why it is not a healthy way? Because let's imagine in Intellipaat, to start with, let's imagine that in Intellipaat root account, or in Intellipaat's IT and software team, there are only 6 users in the IT and software department. What if Intellipaat grows further and it has to recruit more developers and system administrators, maybe up to 200 or 500, let's suppose. So I grow from 6 users to 500. Now, If I start assigning permissions to every person or manage the permissions for 500 people, I'll go insane. Because the thing is that managing permissions for so many users, it is a big headache. I want to go with a neat and clean method to ensure that the access management is done properly. It is process oriented. Now, you guys might have heard about this thing in your own organization. We have Microsoft Active Directory groups. The same concept applies over here. We group the people together based upon their roles or responsibilities, their job profiles, or maybe their teams or business units. And then we assign the permissions to the groups and then add the users to them. I think, let me just discuss with you one example. Okay. Now, for example, what is a group? It's a logical collection of multiple IAM users. It's a logical collection of multiple identity access management users. For example, I create 3 groups: admins, developers, and operations. Now what I do is that in the orange rectangle, the orange rectangular things you can see on the slide, these are the groups. I create 3 groups. Left one in the orange is admin. In the middle, it's a developer. And the third one is the operations. 3 groups. Now in the blue, you can see these are the users. For example, in the admin, I have admin 1, admin 2, admin 3. So we can have names: Chris, Kavita, Suresh. Now what I do is that instead of adding the permissions for individual admins, I simply add the permission to admin group to the orange block. And then all the admins underneath will get the same permissions. Let me give you one more example. I have a group called developer. Under developer, I have 5 developers. Under developer group, I've grouped 5 developers: dev 1, dev 2, dev 3, dev 4, dev 5. So these can be names: Steve, Chris, Kunal, Rohan, Davik, Mishu, whatever the names are. Now, I group them in the form of a developer group. I assign the permission or the policies to the group itself. And if any policy or permission assigned to the group will be applied to all the underneath developers. Same scope with operations. So I assign some permissions to the operations group. All the ops guy will get ops 1, ops 2, ops 3 will get the same permissions. Right? This is the most process-oriented, neat and clean method of access management. The one that I showed you before, it is a very bad example. But what I showed you, because I want to start with a simple thing. In a big business unit, in a big business environment, that's the best move that you can take. You ensure that you group the people together based on their roles and responsibilities, and you start with the permissions management. Let me show you an example. Let me do one thing. Let's do one thing. I create user groups. You can see on the top, a user group is a collection of IAM users. Groups specify the permissions for a collection of users. So group the people together based on the job profile, business units, teams, and then you send the permissions to them. Now I click on create group at the top right hand corner, and the very first thing is that it says enter a meaningful name to identify the group. Any meaningful name. I can just type in, for example, developers. Fine. Okay. Then it will ask you, okay, this is a group, developers, add the people in this group. I'd say, let me add Kavita, Kunal in the group. Fine. So group name, developers. I group these 2 people with initial K, Kavita and Kunal. Now it will ask you, okay, then what policies you want to assign to them. Now I can attach up to 10 policies. Now it automatically, because I've typed in developers, it automatically shows me some of the services that these people can use. But the thing is that I'll attach the policies, permission policies. So for example, I search for code commit. Now this is a service that these developers will be using. A code commit is a service which is used as a repository, as a Git repository. So I choose code commit. Okay. What about code pipeline? Okay, so code pipeline, I choose code pipeline. Code pipeline, approve access, read-only access. Let me choose full access. Code pipeline, full access. Okay. Then what's the next service that we need to select? Let's choose Lambda. So I'm just giving you one example. So for example, I want to give them, do we have Lambda full access? I think we'll have that. Lambda full access. Okay, I'll choose Lambda read-only access. Let's choose that. Let me choose code build, code deploy. Code deploy full access. Let me choose ECS, Elastic Container Service, or just type in container. So Elastic Container Service, full access, container distributed full access, fine. So I've attached multiple policies. I've attached 5 policies as of now, and click on create group. Now it creates a group called developers. This group has 2 people, Kunal and Kavita. And what are the permissions? Based on these 5 policies attached to the group. What's the group? Developers. What's the permission add to the group? Code commit full access, container registry full access, code deploy full access, code pipeline. You don't have to learn these services. I'm just giving you one example. These are developer tools. Lambda read-only access. Now, based on the access permissions I've assigned to developers, these users will get the same permissions. I can add more users. I can say add user. Okay, let me add Mahesh, add the user. So I've added Mahesh under this list. So Mahesh is a user just added on to the group called developers, and he will get the same permissions because these are the policies that are linked with this group. Fine. So that's how you do that. Basically, this is the most process-oriented and neat and clean method of access management. In a business environment, you go with the process. That's how we go about doing that. Now, also, there will be less chances of you doing some errors, because if you have 500 users to manage, and if you manage the permissions of 500 different people, then you'll make some errors or some mistakes. So to bring down those mistakes, okay, that's how you do that. So the group permissions or adding the groups is one of the most effective way of permission management. Fine. Let me take one more example of groups. So I just go to user groups and I create a second group, I'm sorry. So second group is for my new hires or graduate trainees. So these are my people who I've just recruited afresh in the organization. And these people will be, I just want to give them the read-only access, because they're just doing some hands-on, just learning the process. So I just want to give them the read-only access. So for example, I choose Steve and Suresh. Yeah, Steve and Suresh as a part of my graduate trainees group. And I search for view only. I think it is a policy over here. If I can search for that. Okay, let me see that. View only access. Now, view only access is a policy that, if you see the view only access policy, it gives the read only access to all the services. So Steve and Suresh are just going through some training programs, learning the skills, they're building up the skills. So I don't want them to mess up with my infrastructure. So they should get only the read only access. So I'm saying Steve and Suresh, view only access. Okay, create group. Now these people, so the group is graduate trainees, and who are the 2 people being added to this group? Steve and Suresh. Let me hit refresh. Steve and Suresh are there. The permissions, view only access. So if they try to deploy something, they will be kicked out. Fine, right? So let me do one thing. Let me just log in on behalf of Suresh. So I sign out from the previous Chris account. Let me sign out from Chris, and let me log in on behalf of Steve. So let me just go back to the dashboard and choose the link that I've set in. Go back. I think this is Chrome. Yeah. So I paste the link one more time, and I just log in on behalf of Steve real quick and put his password. Now the thing is, once Steve is able to is trying to sign in, he just, because you can see that Steve has signed in. This is the Steve's account, because he's get the view only access. If he tries to, for example, launch a virtual server, for example, he goes to EC2 and he tries to launch a virtual machine. So for example, he clicks, so he can read the things, he can view the things, but if he try to launch the things or deploy the things or delete the things, he will be kicked out. For example, he tries to launch a virtual machine real quick. I'm not going through the process because I just want to show you. He'll be say launch failed. You are not authorized to perform this operation. You are being kicked out because you don't have the deployment access. You just view the things. You cannot change the things. You cannot create the things. So it is a powerful tool to ensure that a group of users have certain common permissions. Fine. So this is the best strategy for the access management or the permissions management, that instead of adding the permissions to the group directly, you add on to the group and all the people in that group will get the same permissions. Fine. That's about the this thing. The next thing that I'm going to discuss with you is the policy. Now, the thing is, if I show you right now, let's go to the policies one more time. Most of these policies that you can see, these are the AWS managed. When you start afresh, you will see that it is the AWS managed policy. AWS managed is the one that is default. That's there by default. Okay, we haven't discussed the S3 as of now, but what is it? See, the thing is, for example, I go to the services right now and open S3. What is S3? S3 is a service, is a storage service, and basically you store your data in the buckets. These are buckets, right? In this buckets, these are containers in which I store the data, right? Now, in any account, I can have up to 100 buckets. As of now, I have 33 buckets. I have 33 buckets right now. Each bucket can contain some data or unlimited quantities of data. So if I show you, for example, this bucket, let me just pick this bucket. This bucket will have some data. I can put in a lot of data into the bucket. We'll discuss buckets later on. But the things I want to convey is that if you go with the permissions, for example, I want a group of people to just have the read-only access to one bucket out of 30. These are 33 buckets. Out of these 33 buckets, I just want to have my users, a group of users, to only have the read-only access to only one bucket. Okay, so I have 33 buckets right now, but a certain group of users should have read-only access to only one bucket out of 33. Okay, so now you may say that, okay, you can do that using the policy. Yes, I can do that. But the challenge is, pay attention. The challenge is, if I go with the default AWS managed policies, let me show you. If I go with the default policies, for example, let's type in S3 read only access. This is the default policy, S3 read only access. If I assign this policy to any user, then this will give the read only access to all the buckets. Okay. Now, what are the read only access? Get, list. These are the read only policies we use, but we'll discuss that. But so the main thing is that if I go with this policy, it will give read only access to all the buckets. Now, this is not suitable in my case because I have 33 buckets right now, out of which I want to grant the permission to only this first bucket, not all the buckets. I want to give the read-only access to only one bucket out of 33. So the problem with this custom policy is that it doesn't suit my need. It will give the read-only access to all the buckets. But in my case, I just want to give the read-only access to only one bucket. Okay. So what's the solution? The solution is that I shall be creating a custom policy. It's called a customer managed, which I can customize based on your need. For example, let's imagine you go to a restaurant. You order some chicken curry, right? Now the restaurant will have a certain menu. They have a certain recipe, and they will serve you that dish based on how they prepare it. But if you prepare the same meal at your home, you can customize. You can put the spices, you can put the salt, ingredients based on your taste and preference. The same thing over here. It's a bad example, but same thing. Instead of going with the AWS default policy, we're saying, let's customize it. Let's create our own policy. Now, the example that I'm giving to you, that example is that I want to create a policy that will give the read-only access to only one bucket to my user out of all 33. So only this bucket will be accessed, not all the buckets. So I'm showing you the example. It's a bit complicated. That's absolutely fine. Just see the process. Just understand that what step I'm doing and why I'm doing that. Right? In 5 days ahead of you, you can practice on your own. Just see that exactly what's the process that we need to follow along. So I go back to the IAM page, okay? And just at the top right-hand corner, I click on Create Policy. Yeah? Now, the thing is that you have this visual editor, a wonderful tool to create a JSON policy by yourself. So I'll show you that how you generate a new custom policy. The very first thing it will ask you, can you please choose a service? For which service you're creating this policy? So service I'm choosing is S3. Okay, fine. Now, what actions you want to allow in this policy? Basically, the thing is that list and read are the two actions that we choose. It also has certain sub actions. List means, for example, if I go to the bucket, I can see the list of buckets. I can see the list of buckets. If I go to the bucket, I can see the list of data. This data is called objects. Fine. I can see the list of data or files over there. List and read are the two read actions that pertain to the buckets. So these are the read actions: listing the items and reading the items. Okay. Tagging, writing, permission management, I'll skip as if now. So I'm saying for S3, I want to include list. People can list the buckets, read the things, read the items in the bucket. Okay. Now, to go specific, I'll choose the resources. Now pay attention. You have to define the permissions for the bucket and the data into that. See, in the bucket, we put an object. Okay, let me do one thing. Let's imagine this is the S3 bucket. So this is my S3 bucket. What is a bucket? It's a container. It's a container which can contain your data. Fine, which can contain your data. Now, the thing is that any data, any piece of file, it is a file over here. It can be of any format, AVI, MP3, for example. It can be a JPEG, a PNG, an AVI. It can be any format. Now, the thing is, this piece of data that you put in the bucket is called an object. Fine. That anything that you put in the bucket is called an object. It's a container, and the data that you put in the bucket is called an object. Fine. Now, the thing is, bucket is a container, and anything that you put in the bucket is called an object. Now, the thing is that when you create the custom policy, you define the permissions at two levels: at the object level, the data level, and at the container level. So you define the permissions at 2 levels: bucket level and object level. Fine. That's how you define the permissions: bucket level and the object level when you create a custom policy. Now, let's go back to the page. I go back to IAM. So this is where we were to create a policy. Yeah. So I'm saying S3 list and read. These are two permissions. I can list the items and read the items. Now I need to go to the resources. Now the thing is that I need to go to the second option, specify bucket resource. I have to specify the bucket over here. So what is this? It says bucket, specify bucket ARN. ARN stands for Amazon resource name. It's a format to identify the bucket. I click on add ARN. You don't have to do anything, just type in the bucket name. So I have the bucket in this list. This is the bucket name. Copy it. I paste it over here. Now, again, I'm saying this seems to be a bit complicated. That's absolutely fine. If I choose any, it's choose asterisk. What is asterisk? Every bucket. But in my case, I'm saying this is the bucket. This is the ARN of the bucket, which means that this is the special identifier that identifies, okay, this is the bucket. Okay, ARN stands for Amazon resource name. It uniquely identifies resources. For every bucket, we have an ARN. If I have to show you that over on the bucket itself, I choose a bucket, fine, and I choose a bucket in the list, and at the top right corner, you can see that it says copy ARN. I can copy the ARN, and I can go back and paste it over here. Same thing, fine. So it's a special name assigned to the bucket, every bucket, Amazon resource name. So I'm saying this policy applies to this bucket. Click on add the bucket. So we have applied the permission at the bucket level. Now, what about the object level? We discussed the object is the data that we put in the bucket. So we scroll down, then we choose object. Object, it's a data that we put in the bucket. Add ARN. Now it says, what's the bucket name? I mentioned the bucket name. This is the bucket name. Okay. Now, what's the object? To which data you want to apply this policy to? I would choose any. It says asterisk, which means that I want to apply this policy, this permission to all the objects in this bucket. If I have a specific object name, I can specify the name of it. Any, for example, a PPT document, for example, it is rohan.pptx. It's a PPT document saved in my S3 bucket. Or if it's a folder, I can type a forward slash, rohan /. Okay, so I think it's not. So the thing is that, for example, rohan.xlsx. What I want to say is that, or rohan.avi. Do you want to apply to a specific object, or if I choose any, it includes asterisk. I'm saying this is the bucket. Just apply the bucket name over here one more time. This is the bucket, and I want to apply this policy to all the objects in this bucket. If I choose any, okay, click on add, and this completes the configuration. Now, once I apply the service, which is S3, the permissions, click on add tags. Fine. Now this is you can skip it. Click on next review. Now it says review the policy for the S3 this summary. S3 list and read access is given. Fine. And that's it. I can just make it, for example, assign this policy name. This is let's suppose demo. Oh, okay. Read only S3 policy. Now this, I can find a description. This gives read only access to which bucket? I can mention the bucket name to this bucket. Fine. This gives a read only access to this bucket. So I can define the policy name. I can also define the bucket name over here. Fine. This is the policy name. This is the description. This policy gives a read only access to only one bucket. And then I go ahead and click on create policy. This creates a policy for my only one bucket. If I just go to this policy right now, then in that case, this will give the read only access to only one bucket. That's how you define a customized policy. You can see the resource bucket and all its objects. So for example, if I create another user on IAM, let me just go to the user and attach a policy to that user. Let me do that. I add the user. I name this user as Davik, and fine. Let me just add this user one more time, and I define a password for this user, and then I'm saying I attach this policy, which is, I think, if I filter the policy with the customer managed, So this is the policy that I just created. Read only S3 policy, the bucket name. Fine. Click on Extract tags. I can skip it. Next review. So for this user called Davik, this is the policy assigned to him so that he gets the read only access to only one bucket. Create user. And if it is try to log in on behalf of this user, let me just do that real quick. I copy this link one more time, shoot back to Chrome browser or sign out on behalf of Steve and just sign in on behalf of Davik, this new user who has got the read only access to only one bucket. So let's type in done. He has just signed in. Now, if he try to access any of the service, he'll be kicked out because I haven't given him access to EC2. Okay, I've given him access to S3, but limited access. If he goes to S3, then he can list all the buckets. He can see the buckets. But if he randomly goes to any bucket and tries to access it, he'll be kicked out because it says insufficient permissions to list the objects. Okay, so he goes on the track and search for the bucket that I've given him access to. I think it's Rohan AWS S3, this one. Fine. So he picks that bucket and now he'll able to read the objects. But if he tries to choose anything and tries to delete any of the object in this bucket, he'll be denied. You can see that it says access denied, fail to delete. So the customized policy will empower you with some custom-based permissions that you can formulate by yourself. So in a business environment, you'll be creating and managing these customer managed policies because the default one that you get, it may not suit your need. Fine.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
The 5 essential characteristics are like, first one is the on-demand self-service, then broad network access, resource pooling, which is also, we can say that multi-tenancy, or which leads to multi-tenancy, the rapid elasticity, and major service. Now, depending on these characteristics, each one lead to some of the security issues we will discuss one by one. First one is on-demand self-service. So any person can access the cloud resources directly without any human intervention. See, for example, there is an infrastructure as service cloud provided by an organization. There is some developer, there are some employees of the organization, and there are some IT operations people from the organization. Everyone can access that particular cloud environment. Now the question comes is, do you think if there is a cloud services offered by an organization, is it available for everyone, or is it available for only a small group of people? So here in this case, the access to this particular cloud provider, which is provided by a specific organization, is limited to only for their employees and IT operations people, which may or may not belong to the company. But if there is any independent developer who is not part of this workflow or organization, may not be able to access the cloud. So one of the, depending on the basic characteristics of on-demand self-service, if we are offering the services of this organization cloud to everyone, then that particular developer can also access the cloud, but we don't want that. So we have to apply some methods, we have to apply some techniques so that any developer who is not a part of that particular organization or workflow may not be able to access the cloud services or offerings provided by that particular organization. Similarly, second one is broad network access. So it says that we can access the services provided by cloud using any particular means. We just have to follow some regular initial protocols such as HTTP or XML. But it does not depend on from which device we are accessing that particular cloud environment. What about private cloud? Because if there is any research organization which is handling some very strict data or some private data, and we don't want that data to be accessed, but if the organization can be accessed from anywhere, then their private data can also be available or can be accessible from somewhere else. So how can we handle this particular scenario, which is created by the broad network access? Next one is like any device with right credentials, say for example login ID and password, should be able to access the account. But this creates an issue. What if the device is compromised? Say for example, you have your university or company login from your mobile phone, but you lose your mobile phone. And if someone and if your mobile is kind of found by someone else, then that particular person, if he is able to unlock your screen or unlock your mobile phone, is able to access your email and all the information about that particular organization. So what happens, or how can we handle if the device becomes compromised? So that is another issue which is created by the broad network access. Next one is resource pooling. Resource pooling says that sharing is caring. So just share the resources. That increases the utilization of services provided. Also, reduce the resource wastage. We can share the resources between unrelated organization or people in the public cloud environment, within an organization in the private cloud environment, and with an umbrella organization in terms of community cloud environment. But in this scenario, who owns the resources? Who kind of manages the resources? Who is, or where which place all these resources are running? Who is able to access or consumes the resources? What are the security parameters provided in these particular environments? So these are the questions related to resource pooling. Let's see how we can, or what are the environment or available for public cloud environment. Say for example, if there is any public cloud environment, is it owned by an organization or a third party? Similarly, for manage, is it managed by an organization or third party? What about location? Is it located on-premise, or is it located somewhere we don't know? What about the access? Is it trusted or is it untrusted? Can someone tell me about owning, like in public cloud environment, who owns the resources? So two is correct. Like it's owned by the organization. That's sorry, it's owned by the third party, but it is also managed by the third party. Say for example, if you are an organization, you are using the services provided by Amazon. So Amazon is and I'm a client of this any particular company, then that particular, like my data or my services, is not managed by your organization, because that particular organization is using the services which is provided by Amazon. So that is third party, that is not the organization. Other thing is, in terms of access, it's not trusted at all, because client or any particular employee, any particular user, that trust that trust the organization, and organization kind of trust the cloud service provider. But this is a kind of chain of trust. We can't directly say that it is fully trusted. There are many issues or many factors in terms of trust, which we will discuss later. Similarly, what about the private cloud environment? Is it organization, third party? What about management? That particular organization may own the cloud environment, or it may lease from a third party. But all those services are strictly owned by that particular organization, or strictly in complete control by that particular organization. Also, it may be managed by the organization, or if the organization is not very big, they may kind of lease the third party organization, third party management option. In terms of location, it is again either off premise if it is completely organized or completely owned and managed by the organization, or it may be off premise. In terms of access, it is considered to be trusted. I put a question mark. Usually people think that if it is a private cloud, it is trusted. In normal case, it is trusted, but there are so many scenarios where there is a question mark. We are not very sure whether it is trusted or not trusted. you kind of own a server, and you are managing the server, like how to handle, how to do the partitioning, creating the virtual machine and containers, giving the access to all your users and all. But what about the security policies? So like sometimes what happens that you have to apply so many security policies to the server. Now if any of like lacking of any of the policy may lead to some vulnerability. uh, it may happen that your password may be leaked, or the admin password may be leaked, so third party or someone else like intruder may access uh, your server. uh, if it is a medium sized organization, then you need a separate location for a server, like data center, sorry. You need a separate location for the data center where you have all the servers located. Now in that particular scenario, what happens that how are you like which person you are allowing to get inside that particular server or data center, uh, who are accessing, which persons are going and patching the network, how are they accessing, whether it is like normal fence, normal building, or whether it is like card access, whether it is like simple access control, or whether it is like two level access control. All these factors can lead to some security issues and again trust issues as well. So similarly, in terms of community cloud, it is owned by the either umbrella organization or third party. It is managed by, again, management is also by either umbrella organization or third party, or sometimes both. Location, again, it depends on it may be either on premise or off premise. It is also considered to be trusted because it is accessed only by the employee or people of the umbrella organization. Next property is the rapid elasticity. uh, Again, there is, I think you guys already studied about scalability and elasticity, and what is the difference between scalability and elasticity. So in terms of elasticity, it's good that cloud computing provides very fast elasticity. So you can increase or decrease the amount of resources required at runtime. Possibly not efficient for all applications. If the requirement is very high, or if the network bandwidth is very low or not that adequate, it may take some time. Now question comes is, how do you allocate more VM? There's more resources. How do you move or terminate competing VM on same hardware? And is there any other solution available? In terms of security implication, it says that since network is very dynamic, so it's hard to guarantee that rapid elasticity is provided. Second is, how do the cloud provider check whether all the requests, even for increasing or like scaling or unscaling or descaling the resources, is authentic or genuine or not? So that may lead to kind of denial of service or distributed denial of service attack, which we discuss a little bit later. Finally, we have this measured service. It is required that, I think you already know, that cloud provider is a business model. It is made to make money. Then question come is, how do they make profit? So cloud provider are making profit, but how are they making profit? Second is, to provide better services, cloud provider need to know that what is the total amount of resources uh, the VM is using, for how long the resources is utilized by the VM, and how many customers are served by that particular data center or that particular uh, server. This may require some private information, and if the cloud provider know the private information, there is a chance that this information may got leaked. So all these basic characteristics of cloud computing leads to some of the vulnerability which need to be handled properly. Now the question come is, why we move to cloud? Previously we don't have cloud, we have less resource, like less security concerns, although we have some security concerns, but not as compared to when we plan to move to cloud. So say for example, if you are an organization and you kind of want that you want to move to cloud, so then you have to analyze whether is it a good choice to move to cloud. You have a meeting and then you decided, no, we want to move to cloud. Now if you want to move to cloud, what are the steps that you need to do before going or moving to the cloud? So these are the information which is required before you plan to move to the cloud. First one is identify and classify what are the information assets you have. So I will discuss all of these one by one. Next is what are the risks and how are you managing the risk, or what are the strategy that you are managing the risk. Then you come that, okay, now we decided that we want to move to cloud. Now you have to plan how to design a secure cloud solution. So first one is information assets. So information assets is the main information asset any organization or company is the data or metadata. Now with each data, with each data and metadata, we have some information. Now this information is who may know this information, which people from our organization may know it, which information we need to send it to the cloud. Sometimes what happens, we can send all the information to the cloud, but sometimes we don't need to send all the information to the cloud provider. We can kind of distribute our information or data. We hold some of the information by our own, and then we send some of the information to the cloud. Now when we are sending some information, are we sending our information directly, or are we kind of encrypting the information and then sending the information to the cloud? Again, what are the privacy concerns? Nowadays we have a lot of security rules in India, in Europe, in China, and in United States. So we have to consider, are we kind of violating any of the privacy concern? If we are violating, then how do we manage those concerns, or how do we manage and kind of mitigate those concerns before sending our data to the cloud? Now talking about data, so we have different type of data. Say for example, if you're in an organization, you have files, you have user information, you have login ID, password, you have some logos, pictures, you have some papers, you have some code, you have a so variety of data. Now you can distribute the data in many ways, but here we are dividing the data type in just two types. One is structured data and other is unstructured data. In structured data, we can kind of save the data in a tuple format, like in a tabular format, so that we can have specific rows and columns. But in an unstructured data, we don't have any specific structure. Say for example, like image or tweet, or some of the pictures or video, audio. So those data, it's very hard to kind of define any structured format. So that's an unstructured data. Now structured data is easy to handle, because we already know, okay, this is the data, this is our data type, these are the, we may have number of rows and number of columns already defined. We can feed the data, and we can kind of save and act on that particular data. While if we have unstructured data, it's very hard to handle those data, because we don't know how much data we are getting, uh, what the processing we need to perform on that data, and how and where we are going to save that particular data. now now when we got the data, then each of the data, or all the data has some phases to pass before the data data is vanished or data is no longer required. Say for example, initially you don't have any data, now you are getting some data. So getting some data or generating some data is what, like creation of a data. So when we create the data, then we have to store the data. Then when we already have the data, then we have to process the data. We have to process the data. When after processing the data, again we have to store the data. After processing, we may have to, if we don't need the data, then we have to archive the data for later purposes. Finally, we have to delete the data. So these are the basic 6 steps. First one is to create the data. Now then, in this particular stage, an organization generate data either directly or it generate on cloud. Say for example, if you're running an application on cloud, then it will generate data directly in the cloud, and you have to kind of save your data in the cloud. While if you are if you have some if this is a already established organization, then you have a lot of user information. uh, some user is running or writing their code on their own machine or on the basic environment. So those data, so data can be either created directly on premise, or it can be created directly in the cloud environment. Saving or creating cloud data also include the VM information. So when we want to use the cloud, then we have to create a VM or container. So those particular data is also saved in the cloud, which is not normal data, which is a kind of metadata. Each VM, their logs. So when we are executing the VM, there is a background logs also created, what time we are accessing, what operations are performed on that particular virtual machine or container, what network access is performed, or how user is accessing that particular VM on the network. In addition to that, it also saves the CPU uses, memory uses, to runtime handle those particular virtual information. In addition to that, it also stores some of the monetary information, such as how much is your subscription, how many hours you have to run, how much money you need to put more, or using those information, it sometimes also create some further information which can be used for next month prediction, so that it will tell you some uh, smart information that, okay, last month you used this much information or this much resources, this month we are trying to provide you this much resources, to reduce your access time, especially in terms of elasticity and all. Second one is the storage. So when data is created, we have to store the data, otherwise data may got lost. We don't need to store all the data, because in many cases we are generating, like in the time series manner, we are generating data all the time. We don't need to store all the data. We have to kind of act or analyze which data we need to store and which data are not important to be stored. Yeah, so in terms of storage, there are many ways in cloud environment to store. So first one is raw storage. Raw storage is store the data directly in the way it is generated. Second one is ephemeral storage. So whenever we create a virtual machine, we kind of it automatically has a basic storage attached with that particular virtual machine or container, which stores the state information or the uh, default data which is created with the virtual machine. Whenever we stop the virtual machine, these data got deleted. We don't have to terminate the virtual machine. Just stopping the VM will kind of removes the data. Third one is we have to attach a volume sometimes. So for example, if you have some data that is required by the virtual machine, but you don't want the ephemeral storage, so then we have to create some separate volume, attach those volumes to the virtual instance, and make the cloud, or let the cloud instance use those particular data. So volume storage is very similar to the external hard disk, which can be attached to any particular virtual machine or any particular system. Next one is the object storage. In terms of object storage, so this is again when we are kind of archiving our data, when our data is no longer required, then we have to store it in some object storage, which can be like later used for the long term storage. Like long term storage is in terms of not only storing in that particular cloud environment, but also take out the data from that particular cloud environment and store in some low cost environment, where the access time may be a bit slow, but it will be very cheaper and very kind of efficient. Sorry, yeah, it will be very cheaper, and it can store a very large amount of data. Finally, the last one is I can say content delivery network. In many cases, especially when we are accessing the video on YouTube or Netflix or Amazon Prime, what cloud environment does is they kind of resave or saves the same amount of data at multiple locations, so that it can be accessed by many environment, or it can be accessed by based on the region wise. So each region can easily access those particular data. uh, this kind of reduces the access time for each of the user. Next one is use, how we are using the data. Now, how we are using the data can be used in multiple ways, uh, in terms of uh, in terms of performing an execution, in terms of creating some a payment slip, in terms of uh, using some AI technique, which accepts some data, or doing some mathematical calculation, high performance computing. Depending on which kind of application we are using, we are accessing our data, and we are manipulating it and creating some result. Next is after using and storing. Sometimes in some cases we need to share our data. So how are we sharing our data? So data is often shared with other employees or customers and some other partners. Again, sharing is important, but also it creates some more security concerns, which we will discuss further. Next is archive. Uh, so in terms of archive, when we don't longer use those particular data, we can save it in like long-term storage repository for later use, in long-term storage, or which can be accessed whenever required, but the access time is little bit high. And the uh, that particular storage will store very large amount of data. Finally, we need to destroy the data. This is also very interesting. Whenever we store any data in the cloud, it usually doesn't destroy. It kind of overrides, or it deletes the how can I say, it deletes the access point, so that with which someone is accessing, that is just deleted. Remaining the data is not deleted, which is not good. Recently there are a lot of research and talking happening that if the cloud say that they delete the data need to be deleted, which cannot be recovered after some time. Say for example, in mobile phone, if you are deleting a data, it says that your data is deleted, but there are some ways you can access your even deleted data after some time. uh, some of the phone allow it to store the deleted data for 6 months. Some of the phone uh, delete in 1 month. But again, that particular deletion is if your information is already stored in the cloud, they just kind of remove your access, but the data is still there. So there are some specific techniques required, uh, how to securely delete the data. So now we have to, so now we know, okay, this is our data. Now we need to know that what are the risks associated, or what are the threats associated with our data. So although there are a lot of risks and threats associated with our data and cloud environment, uh, I'm gonna discuss 12 of the main risks that that can be like those are like kind of one of the uh, most important risks associated. Since the cloud provider is not always uh, very spectacle about whether you want to delete or not. So sometimes what happens that they use your data, and they kind of create some apply some AI method, and then they kind of predict for your future requirement. So that's why, or they always not delete. Like most of the time they don't delete, because deletion is a very complicated process, especially for the cloud environment, because uh, as I told you, that there is no direct way that you can delete. You can override the data, which we don't have our own control over the cloud environment. So we can't say that uh, yeah, I agree that it should be good that someone, or there is a policy, there need to be a policy which can define that, okay, data should be deleted after 5 years or 10 years, or even if it like in 5 years it's too long. And if it's a big organization, then it creates like huge amount of data. So even like 6 months, sometimes what happens that especially in terms of video recording of some who is coming, or this biometric access attendance, that is hold for 6 months. If there is nothing happened in 6 months, then they just remove the video recording or biometric attendance. In terms of biometric attendance, they can have, but in terms of video recording, it is very heavy, especially if they have kind of in the whole office, if they have like 500 cameras, then they can't store all those data for very long time. So these are the 12 main threats or risks. These threats are specified by the International Organization of Standards and International Electrotechnical Commission. First one is unauthorized access. So in terms of unauthorized access, if you have a, so the example is, say for example, if someone else is using your ID card to enter into the building, so since you have the authorization to enter into the building, no one else has the access to the building. But if someone else is kind of either using your card or tailgating, like just following you when you are entering in the building, so that particular is considered to be unauthorized access. So in terms of definition, uh, user gains access to and are able to view the data that they shouldn't have. So sometimes what happens in office that if you are working on some very security critical application and someone else who is sitting next to you, they can kind of just look and see that okay, you are doing on this particular data, or you are using this particular application which you don't want them to see. So that is also considered to be kind of unauthorized access, although they don't have authorization, but they are kind of accessing mm, that particular information. Next is unauthorized uses. So unauthorized uses is so in terms of unauthorized uses is that user is able to modify. Say for example, if someone else take your password, like login ID and password, and start posting on your Facebook profile. So access is just accessing, like getting the information. But if someone, like after getting the information, after getting hold of your information, if they start using your particular information, like sending mails to, if someone else gets your login ID and password of your email, and if they start sending mail to someone else, so that's kind of unauthorized uses. You don't want anyone else to use your particular credentials or your particular authorization and start using it for some other purpose, but regardless whether it is good or bad, that is considered to be like security vulnerability, and that is very common in terms of cloud environment. If someone else uh, has your login ID and password for uh, any of your social media or cloud environment or some system, they can access and they can perform something. So unauthorized access and unauthorized use, especially unauthorized access, may be kind of left unnoticed for longer time if that particular person does not perform any unauthorized uses. So the time when the person start using the unauthorized uses, uh, you can easily visualize, or you can easily kind of analyze, okay, now your information is being like start being used for either like required or unnecessary purpose, or some threat kind of purpose. Next is like regulatory non-compliance. uh, so what happens is that several application has some boundary, regulation boundary, especially in terms of credit card. Like you have a specific uh, you have a specific kind of limit on each credit card, and sometimes uh, if someone like use some method to exceed their particular limit, which is not considered, especially for now, since the credit card companies are very strict, you can't use that. But there were some time that particular person using the credit card, they can access the credit card to use for some purchase or withdraw some cash, and then they don't kind of comply with any of the regulations which is specific to that particular card. So it is necessary that all those policies and requirements should be audited regularly, and any necessary means should be taken to any person or who is kind of using this non-compliance, or who is performing something which is not uh, compliant by the policies or the rules specified. Next one is network security. Again, cloud environment network plays a very important role, especially for cloud environment, because we can access the cloud via network only. So there are so many vulnerabilities possible in terms of network. We need to make the network as secure as possible in terms of HTTPS or using the very specific like TCP IP protocol with SMTP and all, in terms of messaging, in terms of accessing our email and everything. But even though there are some security issues, especially in terms of like distributed denial of service attack and denial of service attack, where either one user is creating a set of requests, or multiple users from different locations are kind of trying to overload the network or the virtual machine, so that the genuine or authentic requests may not be served, or it takes very long time to serve. 1 minute. Again, next is the man in middle attack. So since user is accessing via network, someone listening the traffic can use those information to gain access. There are multiple ways to do that. Like if someone is kind of accessing the network, they can easily hold those information and use the log to get the kind of what topic or what information is being passed. They can decrypt some of the information to know the login ID and password, or they can sometimes say that, okay, uh, my login ID is missed, I have the sorry, my password, I forgot my password, this is my login ID. And they can use those particular information to kind of gain access to the system. Not only that, they can also easily replay the previous information to say that, okay, this is the previous OTP, but I can't receive the OTP because my I lost my phone. So that can lead to some of the very important network security questions, which need to be handled very carefully. Next also is the corruption and destruction of data. So data in cloud is protected against unauthorized modification. So we don't want, if we are storing some data in cloud, we don't want it to be kind of updated either by cloud service provider or by any co-resident virtual machine user who is accessing the virtual machine, or a third party admin, because we kind of trust the cloud service provider that although we are using cloud, but we don't want our data to be corrupted or to be uh, destructed or removed without our own access. uh, Again, this also leads to kind of data breaches and leakages. So sometimes, regardless of all the precaution, uh, either by our own mistake in terms of the program that we are writing or the application we are using in cloud, there may be possibility that our data may got leaked, or there is some breach in our data, which allow some unauthorized user to copy some of the basic or important information, which can be further used to either corrupt the data or access our virtual machine, or unauthorized execution of our own virtual machine in terms of cloud environment. Next one is theft or accidental loss. So if we lost our mobile phone, or if we lost our tablet, which kind of saves all the information. So if someone get hold of our mobile phone and kind of accessed or get inside our mobile phone, they can access all our information. So how are we gonna tackle those, or how do we handle those kind of accidental and theft loss? Similarly, in terms of malware, when we are executing our application, and it may be possible that there are some malware attached to that particular application or program that we are executing. Especially malware is left undetected for a long time. again, because we don't know whether our system contains any malware or not. Sometimes it may lead to corruption of our data or resources. Just they delete the data which is running in or available in that particular folder where it is executing. Sometimes it can also like move from one virtual machine to other virtual machine which are co-resident on the same server. uh, so all those things need to be kind of checked very actively, and need to be acted upon uh, as it is like recognized. Next one is improper sanitization. So again, this leads to the deletion of the data. So when the data is delivered, we don't want it to be when we say that we delete the data, we don't want anyone to kind of recover our data or resources in any way. We just want that, okay, if we say that we are deleting our image, it means it get deleted. It may not leave any memory footprint, so that it can be accessed later on by third party or any other user or even cloud service provider. The one is also is very important is virtualization security. I think you already studied a lot about virtualization. So virtualization comes with its own set of security concerns, regardless of whether it is a hypervisor or a container. They all are executing on the host operating system. So if there is any flaws in terms of security, either at the host level or at the VM or container level, it affects the execution of users application or data in that particular virtual environment. I already discussed a little bit about the VM co-resident attacks. So sometimes what happens that if there is any corrupted VM available on the server, it can kind of corrupt the other virtual machines available on the same server. Uh, Also, in terms of worm, if there are some worms available in one of the virtual machine, that can easily affect the virtual machine, the other virtual machine executing on the same server. It also got affected by some of the denial of service attack in terms of network. If our virtual network uh, is affected, if someone know that, okay, this is the network bandwidth they are using, so why not to use the same network bandwidth? Not even they are accessing our own server, but even if they are accessing some other server, but if the network bandwidth is shared, so that can also kind of affect the virtualization security. How to tackle these, we will discuss this later. The one also is account and service hijacking. So in terms of phishing, like either phishing mail or fraud or exploitation are used to gain access to users' credential, and then it can be used to compromise the whole system or one particular application executing on the system. This is very again very important to be addressed, that okay, we don't like open or use any phishing email ID. Especially, it need to be kind of some monitoring or a tracing method, so that it will check, okay, this mail is authentic, or this mail is, or this application or mail is authentic, or just phishing email. There are some disasters also can be possible, either in terms of natural disaster. Say for example, the place where we have our data center, and there is some flood happened, or there is some landslide happened, or there is some fire happen. uh, Sometimes because of the networking issue as well, sometimes because of some electricity issue. The other is in terms of man-made. So sometimes if we are writing our own application and we create some bugs that kind of consumes a lot of memory, uh, like fork bomb application. If you're running the fork bomb application, it kind of forks indefinitely till your whole system got shut down. So if there is any such kind of application executing which is like not defined intentionally, but that happens when writing or executing the application, or sometimes using some high voltage short circuit or some water leakage, these all can affect the system, and also lead to some security issues, physical security issues that also need to be tackled properly. Any question till now? Okay, then we will move to the manage risks and threats. So now we know, okay, these are so now we know what are the threats and risks associated uh, with our cloud environment. So since we already know the risk, then we need to kind of assess that, okay, what are those risks, or how we are going to handle those risks. So there are three major variables for the risk assessment. First one is what is the risk or threat. Uh, Second is how likely the risk or threat will happen in terms of vulnerability. Third one is what is the impact of that particular risk. Uh, See, for example, if consider this example of natural disaster. So just natural disaster on premise. So our threat is that happening or occurrence of natural disaster. Now likelihood. In terms of likelihood, you need to see that um, what is the likely, what are the options, or how much percentage of chance of happening of, say for example, uh, some flooding in near to any data center location. So we need to analyze with the help of some previous environment data, some more weather data, and then we can come up with some likelihood that, okay, there is 5% chance that there is a flood happening near to the data center that can affect either electricity or the location of the servers which are executing on the data center. Using the threat and likelihood, we can create the impact that, okay, uh, although we have 5% chance, but it can hardly impact the execution of our server because our servers are executing on the first floor. uh, uh, we have some backup already available in terms of generators, so even if there is any uh, electricity outage, we will not go out of power, and so on. uh, Again, we don't only have to analyze in terms of quantitative, like in terms of number, we also have to check in terms of qualitative by talking to the people, or by getting some questionnaire with our customer that, okay, these are the likelihood, are you fine with these cases, yes or no, because uh, the main thing is that if there is any risk happen, then the risk not only affects the organization or company, that will also affect the customers. And uh, since customer and the organization are bound by the service level agreement, the organization does not want to like either overpay or pay for any risks which they can't control. So it's better to kind of compute it qualitatively and discuss with their customers or their employees. Analysis should not just occur once but repeat whenever the system or context change. So this need to be repeated with each of the context for each of the data center. Sometimes this need to be performed regularly, like once a year or once in 2 years, and so on, so that there is no risk associated with any of the execution in the cloud environment. So first one is mitigate. So add additional control to lower the impact or vulnerability. So say for example, if you know that, okay, there is any disaster happening or about to happen in this area, so there may happen electricity outage, so you can buy some additional generators. Or if you know that, okay, your organization is prone to uh, some theft or some security theft from some other organization, which want to try to access your resources, so you can implement some multi-factor authentication, so that like multi-factor in terms of either two-factor or sometimes even three-factor authentication, so that no one will access your organization. So in this way, although you can't control the risk, or you can't like say that, okay, this risk will never happen, but you kind of reduce the amount of risk that can happen in your environment. So what happens that any organization, or say for example yourself, uh, you how do you know that, okay, you are kind of getting like part of a theft, or what happens if your phone got lost? So losing a phone is a risk which has how much probability, like 2%, say for example. But if you lose your phone, that is a risk. So that in that way you need to take care that, okay, even if you lose your phone, how do you kind of handle anything which lead to or what are the event will happen when you lose your phone in terms of security. You don't want anyone else uh, to get a hold of your phone and access your data or perform something. So so that's how risk is associated with the security. So you have to kind of handle the risk to reduce the chance of any security implications which can occur because of that particular risk. So second one is risk transfer. Say for example, if you have any risk, say like for consider an example of mobile phone. So when you buy a mobile phone or a laptop, then if you buy an insurance, you don't know when your laptop got crashed, when your laptop will be crashed. So it's better to kind of outsource your risk. So even if there is any crashing happened in your laptop, you are kind of sure that, okay, I don't have to worry because I already bought an insurance. So they will give me a new laptop, they will format my laptop, they will like get my data out from my previous laptop, and I will have the similar kind of environment that I had in my previous laptop. So in this way we are kind of outsourcing our risk to someone else. So for this we have to pay some money. Third is risk acceptance. Okay, just accept the risk. Okay, if this is going to happen, this is going to happen, we can't control this. So if the risk will happen, then we have to accept. Okay, if unwanted, if you're writing a program, it may be possible that we can create a bug. So we have to kind of keep attentive that, okay, we may not create a bug which consumes our memory, but it may happen. So we have to kind of accept that, okay, if this will happen, then just I'm accepting, and whenever it happens, then I will try to see how I can handle this particular scenario. Next is avoidance. Okay, just try to avoid. So try not to use any, or try not to open any phishing email or any email which we don't recognize, or which ends with some other information that we don't know. In that way we can kind of avoid getting kind of any malware in our system. Say for example, if you get one mail, and if you're not opening the mail, you it may happen that it may be possible that there are some other ways you can get malware, but you're at least trying to avoid as much as you can by not opening the mail, so that your system is secured, at least for your sake, or at least for that particular mail that you have already received. Last one is risk difference. So the thing in this case is you can avoid, but you can't avoid like for all the time, until we can mitigate or transfer the risk. So in this case you can avoid till you can mitigate, or you can transfer the risk. So in this way, this requires a lot of work, so that you know already that, okay, how you can mitigate the risk, and you know how, like, whom you can transfer the risk. So this requires a lot of knowledge, especially in terms of current security operations. Sometimes we don't know in which form we are getting the phishing email, or uh, if there is any other way, so that someone else can access our system. Like, say for example, if we are opening some website online uh, that does not require any information, but just executing or just opening that particular website gives them the access, right, so that they can kind of access our system. So we don't like this may not be possible for all the scenarios. So next topic is our to design a secure cloud solution. So now we know, okay, these are the threats, we have to mitigate, these are the risks, we have to mitigate those risks, uh, and we already know that what are the data and we already know, you guys already know about cloud environment, that service model, deployment model, and what are the essential characteristics of the cloud environment. Now, if like even after knowing the risks and threats, now if user want to deploy or use the cloud environment, then they need to find a secure cloud solution. Now, to get or to design a secure cloud solution, how or what are the steps required? So to design a secure solution, we can we can divide this whole designing step in 5 steps. Stage in 5 steps. First one is design a secure data center. We need to design or define a data center which is secured. There are so many factors of making a data center secure. Then we have to consider the security controls for the data center. We have to consider the information rights management, how we can define and how we can implement this uh, for like on a per customer basis or per organization basis, or depending on uh, the operations that is performed by the user. Next one is design and apply data security technologies. So we have to apply something which is specific to the data only, and what are the strategies required. Finally, even after this, even after applying this, if there is anything happen, then how we can like recover, or what are the disaster recovery strategy if there is any risk actually happening in the system or in the cloud environment. So first one is design a secure data center. Again, so designing a secure data center can be divided into three separate phases. First one is uh, we need to consider, like, first one is the logical design. How we can logically think that, okay, this is the way we can define our system or our data center to be secured. uh, Second one is physical design. So in terms of physical design, what are the physical components that we need to consider? And next one is the environmental design. So in terms of what are the environmental factors that can affect the security, or that can affect the performance of a data center in terms of security specific operation. So first one is, when we talk about logical design, it allows us to separate users and manage them as well as resources assigned to them. So say for example, if we have an organization, the organization is using the cloud environment, or decided to use the cloud environment, and cloud environment give them an access. So they don't give a separate access, they give just one organization access. Now it is the responsibility of the organization or manager, or whoever is managing the cloud service or cloud access, to divide that particular access among different users. So they have to define, for each user can access their own, or each user has their own access rights, so they can access the cloud environment independently. They don't None of the employee want that what information they are accessing to be known to be by the other people. It is one of the key component of cloud security. Second one is access control. Now, even if that particular manager provides or gives each user an independent access, but if everyone has the same access, they can access the like collective information or common information, which we don't want. Say for example, in an organization, we have some employee, we have some developers, we have manager, we have some IT person, we also have some person like auditors. So auditors have access of all the employees work, in terms of they have some chart where they are kind of auditing and telling that, okay, which employee is working good, which employee is not working good. Auditor doesn't want that particular information to be visible by other employee at initial phase. Similarly, manager has kind of access of all the like basic information. They have all the employees uh, personal information. They also have kind of partial information about the auditor that okay, what auditor is doing, or whether auditor is doing correctly or not. But they don't have the very detailed description about each employee. Each of the employee, they have their own environment where they have their code, they have their personal information, and some of the information, like company specific information, like a fixed calendar invitation, or when some meeting is happening and something like that. So in terms of that, it is very important or necessary to divide the access in such a way so that each of the tenant or each of the component of the organization have their own access right. So that's why we need to consider the access control in such a way, so that manager has the kind of wholesome access of the whole organization, like almost whole organization. Auditor has, again, auditor has all the auditing information. They don't have the salary account access. They don't have the code access, what each employee is coding and all. Employees has their own environment where they have their personal information, their coding information, and some of the physical, some of the generic information. So that particular access control need to be defined very strictly. uh, Not following this particular scenario can lead to a lot of problems and issues in the organization. So next one is in terms of physical design. So in terms of physical design, we need to consider where we are kind of setting up our data, where we are setting up our data center, including the space, resources, location. We don't want the data center to be in location where it is prone to either earthquake or flood, or even heat. We also need to consider uh, where we are if we are not owning our own land, or if we are not owning the building, then what is the cost, what is the time, how are we maintaining our resources, uh, who else has the access of that particular building and all in terms of acquisition. So we need to consider this physical design when we are considering to create a secure data center. We also need to consider some environmental factor in terms of temperature, since heating is one of the most energy uh, consumptive like money related operations in a data center. So we need to kind of maintain our server's temperature. We also need to consider how we are managing the air management, we don't want the whole server room to be filled with hot, so that anyone who is coming for patching some of the network related operation, or someone who is kind of checking the uh, single server is just got hot. We have to consider the heating, ventilation, and air conditioning, as well as the network connectivity. Again, since all the servers are connected via network, so we need to consider the networking to be very strong, uh, soundproof, so that uh, even if we have any issue with the basic network, we need to have one supporting network, so that if, say for example, if our network cable got destroyed somehow because of heat or something, we have a supporting network associated attached to the system, so that uh, if one of our network got lost, we can access the system via some other network cable. uh, Also, it is not always in terms of wired. We also need to consider some wireless network, so that the system can be accessed not only from the organization, but also from inside the cloud data center. Also, it is very important that there is some mechanism in terms of connectivity, so that the performance of all the systems executing in the data center is known to some server, so that any fault can be localized, and some necessary actions can be taken on time. So our next one is design and plan secure data center. security controls. So how we are controlling and like how we are designing security control of a cloud infrastructure, we can divide into 5 categories. First one, as we discussed the previous challenges, we can again come here. Physical and environmental protection, how we can protect in terms of like just where our server is running, and what are the environmental effect that we need to set up. In terms of system and communication protection, how we can protect our network communication, how user can access. In terms of virtualization system, so here what you were asking previously, that even if our resources are virtualized, how we can protect our virtualization system. Also in terms of identification, authentication, and authorization. Finally, do we add some audit mechanisms, and if we are, then how we are controlling those, the result of the audit, and how we are incorporating them for performing the security related operation. So starting from the first one, physical and environmental protection. There are several ways which we can protect our system, such as data center includes its building surrounding. So for example, first one is in terms of security. If you are running your server or running your cloud in a building, then you need which people are accessing that particular building. Is there any way someone just kind of tailgate you or the employee who are getting in the server room? Is there any way that that can control the electricity, the heat, the network of that particular server? Also, there are some regulations in terms of like HAPAA, which is Health Insurance Portability and Accountability Act. There are this like CIP, which is Critical Infrastructure Protection. What are the protection mechanisms specified or defined for this particular environment or this particular cloud? This PCI DSS is payment card handling. Sorry, payment card handling data security standard. So is these regulations followed by that particular data center or not? Also, if someone is accessing, so say for example, if someone lose their card, using that particular card, can someone enter? uh, if that can enter, then the building is, although the building is secured with the card access, but it is not very secured. So sometimes they have to add like multi-factor authentication in terms of how they want them to access. Again, multi-factor authentication is in terms of like biometric, or is in terms of some app based or mobile based, taking the token or taking the code on their mobile phone, or email. Again, email, if that is email, then which email, like the general like Google Mail or Yahoo Mail, or their organization specific email ID, which requires another level of password, so that requires like 2 level or 3 level. So these physical and environmental protection need to be considered before designing any cloud data center. Again, I already talked about electricity feed, that we need to check whether the electricity feed are continuous, or can it be like interrupted by someone, because if the electricity is coming from the the electric pole, which is a little bit far, then is there any possibility someone is kind of, they can handle and they can cut the wire because of any other issue? Similarly, for cooling system, whether it is cooling, what is the substitute if the fan got interrupted or fan got damaged at any particular period of time? uh, so to monitor this, we also need kind of some cameras installed everywhere, or some other kind of IoT devices installed with like, say for example, fan. So we can monitor the fan. If the fan speed is going down for like 10%, then we can think that okay, this fan is like, in future it may go and get bad. Again, network cabling, I already talked previously that since network is one of the most important parameter for the cloud environment, so we need to have some way so that there are multiple network cable attached to the system, so that if one cable got fire or got cut or got damaged, then we don't interrupt our system execution. uh, Also, in terms of staff, we need to check the backgrounds, whether if they are hiring someone, whether that particular person is uh, has some criminal background, or that particular person can steal some of the hardware stuff which are very expensive in terms of server. Not only that, is there any special security awareness required for the employee who are executing or who are running those particular server or not? So if required, then we have to provide those special trainings later. Next one is system and communication protection. In terms of system and communication protection, we can define like three groups. First one is automation. Then automation define like how to automate the system, which in multiple cases kind of reduce the errors or problems which is generated by the user, especially in terms of security. Second is responsibility. Who will be responsible if something get bad, or how we can define the responsibility. Okay, if something is happening, then okay, this is the person who is responsible for everything. Next is data lifecycle. So we already studied about the 6 phase of data. Now all those 6 phase, how we consider, okay, our data is secured at all the time or not. So let's discuss with automation. So automation of configuration allows for a more granular control over changes. So if there is any changes happening, uh, and if user is like attached with that particular changes, it may be possible that there may be sometimes that user kind of misses to log some information, or misses to add some flag at some particular period of time. But if it is automated, then any of those event or operations can be logged properly, or any of the flag can be easily flagged if that particular operation happens. In terms of a time, if it is automated, it is very fast, so that any response can be instantly made whenever the that particular operation or that particular threat or whatever is happening in the system. So automation is considered to be one of the most important operations in terms of system and communication protection. Next one is responsibility. Again, I think we already had discussed a little bit about this, that what happens if the government change a rules in terms of governance. What happens, and who will take care of the risk? What happens, is this customer's risk? So again, this is one of the biggest kind of factor. So depending on the application, sometimes some of the responsibility is for the user, some of the responsibility is for the organization, and some of the responsibility is for the cloud service provider. Like when a user is accessing an organization data, then it's the responsibility of user to kind of enable multi-factor authentication. Not only that, store their password securely, try to have their like multi-factor authentication way. Say for example, if this is mobile phone, they want to have those mobile phone with them, or in their belongings, in their, they don't want to lose those multi-factor authentication based device. If it is an organization, then organization need to consider that they have multiple locations for their data, for their clients data, or for their users data or customers data. uh, if they are storing in the cloud, they need to consider whether they are sending all the data to the cloud, or they are considering the say for example this GDPR rule. They don't send all the data to the cloud, they are saving some of the personal information in their own local data center, and sending the remaining data to the cloud by anonymizing or masking, which we will discuss a little bit later. Uh, and in terms of cloud service provider, they need to provide as much security as possible, as defined in the SLA contract. They need to consider everything to be satisfied, or they also want to kind of provide as best service as possible. So there are some other third party monitoring environment or third party monitoring organizations available, like uh, ISA organizations, that like international standards, international security alliance. So they kind of provide some questionnaire that each cloud provider has to answer in terms of these factors, whether it is satisfied by each cloud service provider or not. So that's how we can kind of divide the responsibility. So it's not just the user's responsibility, or it's not just the cloud service provider's responsibility. It is the responsibility of each of the individual entity to take care of their particular belonging or their particular tasks which is assigned to them. Next one is data lifecycle. So we already know the data lifecycle. Data can be created from creation till their deletion. So from creation till deletion, data can also move in different ways. So sometimes if the data got created and then stored in a database, or in an ephemeral storage, uh, or any other like hard disk, so that time we consider data in a rest. So in that particular case, we can kind of encrypt our data, and if the encryption is strong enough, like SHA-256 or SHA-512, then we can consider our data is kind of secured. If uh, someone else doesn't know someone else doesn't have the password. Also, there are some trusted mechanism provided by the system in terms of like trusted platform module, where you can encrypt your data, but you don't have the it can be decrypted only on the system, that we are going to discuss in next lecture about the trusted platform module. So it's easy to kind of protect the data when the data is at rest. Second one is data is at motion. So data in motion is that data is transferring, data is like moving from one device to other device using the network. Also, it can consider like data can moving from one one service zone to other service zone. Say, for example, if you are accessing some data from Facebook, then you may have like your server uh, maybe in Silicon Valley or somewhere in US. It may not be possible always, but in some cases it may be possible. So we have to consider that if the data is in motion, then how you are controlling or how you are protecting your data. So data protection in this scenario is via.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
By different kind of network protocols. So you have to specify that, okay, which kind of network protocol we are using for our like communication scenario, and how our data is being handled in the network. Is someone kind of in the middle, like man in the middle attack, who is kind of listening to our data, or they want to do some replay attack later on. So we have to consider all these scenario. So even in the communication, we can kind of encrypt our data and send it or use the network. And again, if someone doesn't know the decryption password, then our data is kind of secured. Finally, third one is data is in process or data in use. So like manipulating the data to perform or to achieve some of the operations. So in this case, although there are some techniques which we can like process our data in the encrypted form, but that takes longer time. Also, in some of the scenarios, it may not be possible to perform all the operations when our data is kind of encrypted. So in this scenario, we have to kind of rely on the infrastructure, whether it is cloud. Especially in cloud environment, we have to rely on the infrastructure. We can consider some kind of like web service, or we can consider we can define some digital signatures for that particular server or services. Again, digital signatures are not always safe in terms of which kind of signature authority you are considering. If the signature authority is generally available, they can generate self-signed certificate, which is available in some scenario, but which is not good for or secured for all the scenarios. So we have to consider how we are processing our data when our data is in use. So this is the most important a factor for the data, how to protect our data when our data is in use. There are a lot of research still happening how to protect the data in use, as encryption or certification may not help all the time. Next one is virtualization system protection. So again, since in cloud environment, all the resources which we receive are in terms of virtualized. So it is one of the most important but most overlooked security aspect. All virtualization components such as compute, storage, and network are by the management plane, which is managed by the cloud service provider. Uh, if there is any issue happening at any of these, like compute, storage, or network, we need proper alerting and auditing of these actions. Uh, we also have to consider some specific security considerations, as like affecting the hypervisor or affecting the virtual machine which are executing on top of that particular hypervisor, can lead to the problems for not only one VM but all the virtual machine uh, which are running nearby on the nearby which are running on the same server. As sometimes attack may sometimes the security issues like such as worms or viruses may affect some other server, some other virtual machine or virtual environment executing on the same server. So for virtual, here we need to consider some virtual network security. Sorry, I got some question. In terms of virtualization system, we also have to consider some good image quality. If we are using some image, also we have to consider the most updated or most updated version of the virtual machine, which has good patched network, and which is kind of free of any network related or system related issues. We also can attach some of the extra like auditing mechanism that I'm going to discuss next, to kind of monitor what is happening with our virtual machine. So here, before discussing this identification, authentication, and authorization, so these three are the kind of main ways to access the resources, but it seems very linked but not the same. I'm giving another example. Say, for example, you want to travel to some country like abroad. So now you want to you want to travel. So what you are doing is you are going. You already purchased ticket. You have your passport. You have your visa and everything. Now you are going to the airport. So on airport, they will check your passport first. So passport is your kind of uh, all the information which is written on the passport, like your name, who are you, where you born, your address, and everything is your identification. So now you identify yourself as your name. All those information belongs to you. So that's how you identify yourself. Now authenticate. So your passport, since you are having or you are holding an Indian passport. So the passport, the thing is, how do someone know that, okay, you say that I'm saying that I'm Devki, but how do someone else know that I'm Devki? So they need some kind of authentication, that okay, someone they trust, or someone whose trust is already known to everyone. So what is done is that, since you are holding an Indian passport, and the stamp and everything on the passport kind of authenticate that, okay, you are who you are saying. So that's way your identification is kind of verified. And then you have a visa. So say, for example, you are traveling to Singapore. So you have a Singapore visa. So Singapore visa is the authorization which allows you to travel to the Singapore. So that's how, like, identification is all the information which is written in the passport. Or if you are in terms of cloud, so all the cloud like access information you have is your identification. Authentication is when you enter your information like email ID. If you have like organization email ID. So at a rate of organization.com is your authentication. They check that, okay, you are who you are saying, or whatever. Like if you're using Gmail, so they trust Gmail. So Gmail is kind of authentication. And then authorization is that if you are an employee, then you can access the employee database, or you can access the calendar, like shared calendar, but you can't access all other information. Or you don't, say for example, if someone has a visa for travel to Singapore, they can't travel to Malaysia, or they can't travel to Europe, any country like Spain. So that's how it is different, like identification and authentication and authorization. I think it's clear. Okay, so there are several aspects of, sorry, I got some message. There are several aspects of identification, authentication, and authorization in cloud infrastructure. Cloud, these are like, question is like, when you have the passport, how do you manage, like, uh, how do you manage the authentication, how do you manage the identification, how do you manage the authorization, Mm, how to make the access decision, how to manage the identity and access management, also in terms of how do you account for resources. So these are the six important factors in terms of uh, IAA. So first one, in terms of managing identification, this involves creating and asserting validity of an ID or a token. Say for example, when you want to create your passport, then you need to provide information. You have to fill an application, you have to submit your documentation to say that, okay, this is how, like, this is what I am previously, with some of the information, like basic information. And then it will create an ID or token, which is kind of valid. Next one is managing authentication. There are several ways of authentication, especially in terms of when we, if you go for passport, then they provide the passport, then they check your previous validation, check your like degree certificate or birth certificate, and then give you the access. In terms of cloud, previously it was like basic login ID and password, which was not safe. Then we can create kind of more specific in terms of like MFA, multi-factor. So they always you have to provide your email ID, password, then they will send you a message, and then you have to provide again, either if it is a code, then you have to provide the code, or if it's a app based, then you have to kind of tap on the app with your biometric, either thumb or your picture. So sometimes it's random, like sometimes they ask for OTP, sometimes they may not ask for OTP. But if you're using some specific secured applications, such as banking based application, they always ask for OTP. But if you're using GitHub, then they, most of the time, they ask for password. But rarely, like at random, they ask for you, they send you that, okay, validate using your either email ID or your phone number. So they send you OTP on your phone or your email ID, and you have to type those OTP. So next one is managing the authorization. So in many organization, authorization is performed using a federated identity model. So again, if you have visa, then you are kind of identified that, okay, you have this access. In terms of a company, they already have the background model where it's defined that, okay, this particular user has access to this particular resources only. If you want to access the banking detail, or if you want to access some customer data, especially in terms of personal information, you don't have access. So this is implemented in the background side, uh, where uh, where this authorization is defined in terms of accessibility for each of the employees or users. And then we have this accounting for the resources. It measures the resources, sorry, measures the resources a user consumes during the access, that includes like billing, trend analysis. So now, in especially in terms of cloud, this is very important that we need to know how much we are analyzing, because cloud uses this pay per use basis. So we can get the bill, get the trend analysis. uh, Cloud also uses these information for providing resources in the future, So they already know your current uses as well as your past uses, and they will predict the future uses. So sometimes even if you are accessing uh, like 16 GB VM, uh, 16 core VM, and based on your previous uses, if it seems that you want like 32 core VM, then cloud automatically like enables your system on a 32 core system, so that like when your user or when your use increased, it instantly you can easily kind of scale up without even changing the virtual machine. So it all depends on your previous uses and how resources are accounted in the cloud environment. Next is this managing identity and access management that we are going to discuss a little bit later. That how we are registering, how we are provisioning and deprovisioning users to allow their identity check, like identification, authentication, authorization, and how much access we are providing for each of the user. So one of the manager, they can specify, IT manager can specify for each of the employee depending on their requirements. Finally, making access decision, like again this is somehow linked with this IAM role that allow to make a decision that okay, which user is going to access which resources in terms of control matrix, if how much permissions we are giving, or what time permission we are giving. Sometimes it's time oriented, sometimes it's space oriented. Like sometimes we ask or we give employee to access the resources only uh, from the office device. Sometimes we allow them to access from any device, but they have to use the VPN, and VPN is allowed based on the IP address of particular network, a network based location. So all these are required for defining this access decision making. Again, when we are using all these information, then we have to audit. Again, I previously also said that it is very important in terms of security to know if our system is in the right state or not, or not only that in terms of security, but also in terms of performance, if our system is performing correctly or not. uh, like in terms of security or in terms of performance, it can happen only by auditing. So if we are monitoring our system continuously, then only we are able to know that the system is in right state or not. It also allows like transparency and assurance. If auditing can be happened or can be performed by the organization or by a third party which which is trusted by uh, all the components, like customer, organization, and cloud service provider. uh, it also kind of assures that the service level agreement is satisfied while while considering the quality of service parameters or quality of service requirements. It makes sure that security and other requirements are being met, and if it is not met, then at what time or for how long the service is unavailable for the users. It also makes sure that the regulations are being compiled all the time in terms of like GDPR or any security rules depending on the location of the country. uh, so how the question comes is how to perform the audit. So auditing can be performed easily depending on the logs, like system log, reading the system log continuously, or capturing the network packet. uh, so these are the kind of metadata information that got generated whenever any operation is performed on the system in terms of success, warning, error, or any time. It also captures or stores uh, login is performed at what time, who accessed the system, or who entered the building. Uh, if someone else entered the building, what is the user's pattern, and using all these information, it can be used to kind of deduct whether the system state is secured or in future is going to be secured or not. In terms of packet capture, it also kind of interrupt the network and captures the packet. Recently, there are some new technique in terms of extended Berkeley packet files are available uh, that captures the network or that captures the system performance without affecting the system performance at very low level, especially at the hardware level. uh, those information got captured, and that can easily be sent to some web application for easy visualization. Although although we can audit these mechanisms, but untrusted auditor or uh, unsecured auditor may leak these information, which can create or increase our uh, security framework or security based environment for some of the cases. So we need to be very specific to choose the auditing mechanisms and to choose the background information and auditor for our services and cloud environment. Next is design and implementation for the information right management, which is also known as IRM. This is again one of the most important ways to kind of restrict the access for each of the user uh, or customers of the cloud environment, especially for an organization. Uh, when the organization is accessing the cloud, one of the IT manager can allow the remaining employees, or they can allocate the resources to each of the employee while controlling the access rights in terms of security, sorry, in terms of resources, in terms of visibility, in terms of accessibility. IRM can be uh, it protects the sensitive information from unauthorized access. It can be defined, or it can be understand in two ways. First one is objective. What is the objective behind behind IRM? And second one is what are the tools for using the IRM. So in terms of objective, it kind of protects the data right. It gives the data right. Data right give people authority over their data. So their data is so they have the access to their data, and they are responsible for their data. So if anything is happening with their data, that particular person's data, it is their responsibility. It is not it does not belong to the organization or the cloud service provider. In terms of provisioning, using IRM, we can easily provision the resources to different users. Also, it allows the access model. So any access model defines users can access the data based on factors such as roles, as I already discussed in terms of permission. If they have the IT manager role, they can access a whole virtual machine information. But if they can start, they can create the VM. But if they have the access right only to execute the VM, they can't shut down or they can't delete the VM. They can only execute the VM by while running the application. The remaining access right belong to some other, depending on the type of application or depending on the scenario where this is executing. uh, Tools is it like specialized tools are used to issue cryptographic certificates which securely specify users identity and tasks that they are permitted to do in terms of so we can associate some uh, certificate to each of the resources, and we allow each of the user to kind of follow those certificates, and their access right or their identification can be defined by these certificates. These certificates can be provided by the cloud service provider or some third party, depending on the application and how the IRM is defined. We can easily like create a certificate. We can also revoke or a kind of deactivate the certificate either for some time or forever, depending on the requirements. Also, the certificate can be replicated. Say, for example, if we are running our application on one server and the server got crashed, or there is an issue in the server, or their requirement increased. So we have to kind of scale up their virtual machine. So in that particular scenario, we can replicate their certificate from one machine to the other machine, and that's how we can so using IRM, we can easily perform that. So the next small section is design and apply data security technologies and strategies. So here we talk about the data security specific issues. So data security is to secure the data. The simplest way is to encrypt the data and hold the key. So we have some plain text. The data which is generated or which is available from the customer or user is in the plain text. We want to apply some encryption algorithm to convert the data into some ciphertext. The algorithm uses a key. Now the key is depending on the encryption method, whether it is symmetric encryption or asymmetric encryption algorithm. We have one key, or we have like public key and private key. Public key is available to everyone, while private key is specific for the signer or for the authenticator. The data can only be decrypted to the plain text again if that particular machine or that particular entity has the key. Again, in terms of hashing, if the data is too big to handle or to save, then we kind of use some hashing mechanism. Hashing mechanism, just we pass the data to a hashing mechanism, and we create a hash, so we can easily access the data using that particular hash. Again, hash cannot be converted to the data, so it's considered to be very secured. Even if someone know the hash, they can't access just the data, because they need the data to be available. We can implement some security parameters to hash. See, for example, just encrypt the hash rather than encrypting the data. So even if someone has the data and the data is so big that it's hard to get some of the some particular information from the data, so using the hash, we can so someone who has the hash as well as the key can only access some part of or useful information in the big data. Other people, they can't access the useful information. The other thing is masking. I think we all know about masking. Is that in terms of masking, is that to kind of limit the visibility of some of the information, especially in terms of email ID or pass or telephone number. When we save our data in the database, some of these values are masked. Now, this masking can happen in some specific ways. So there are multiple algorithms for masking these information. These masking can kind of protect the data from the commercially sensitive, especially when we are typing our bank account details, when we are kind of ordering something online or buying a pizza or something like that. Then if we are providing our bank, like our email ID or other information, most of the time some of the information got masked, especially in terms of bank detail, like first digit or last digit is available, remaining all the information is masked. So that is also very important strategy for data security.
All right, guys. So moving forward now, let's go ahead and do some hands-on. So what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. All right, guys. So the first thing that you would be doing is heading on to aws.amazon.com. Okay. So once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat-test, right? We'll click on continue. Then it'll ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give 1, 2, 3, 4, 5, 6, 7, 8, 9. And the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number. right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS, guys, is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS, guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right. So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have Ground Station, Security Hub, Artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. All right. Now, what we wanted to do was we want to launch our first server, and for that, there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2. So I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that. And now this link would basically open your EC2 dashboard. Right? So from here, you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service, and that will be in the further sessions that we're going to have. For now, just understand how to launch an EC2 instance, and for that you just have to click on this blue button which is here which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. you have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay, so let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from, right? But the only server that is free for you would be T2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select T2.micro if you want to be under the free tier and not be charged. So just select T2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this instance belongs to is this. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches, you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add, or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is a message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being in launch. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's the software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch a Putty software. Right, this is my Putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part, now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH. Then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it will give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it will verify the key that I inserted and it will be able to connect to the Putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay. So you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this, right? T2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right, so let's name this instance as Windows. All right, and now in order to connect to it, this is the IP address that you get. Now just click on actions So select the machine that you have to connect with. Once it's launched, you'd be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect, and this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator, and if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch, but this is the way you get the password. Okay, now if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here, right? Once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this PEM file will work. So I'll just enter the test intellipaat.pem. Remember, the PEM file will work and not the PPK. Let's click on open. And now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here, and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes. And now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything, okay? So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard look for Elastic Beanstalk, right? So as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test, okay? And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET, I can put my web app in Go, I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these are all the settings that you have to do, guys, nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys, you will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL, which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy, and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. All right, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kinesis, fire assist, log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Auto scaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, you know, it was a file before and now it's an object. Object basically is at the back end. That is how you store a file is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that, you know, your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that that AWS guarantees that your object will have. And obviously you can increase this SLA, this basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service, and for that I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket, and you will be able to host static websites in that case. All right. Our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service, and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that, there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS, and you feel that you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Leave everything at default, and now let's just click on create bucket. Alright, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures, and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3? You want to archive the data, put it in Glacier? All those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here. Right now, if I select this file, I can actually see the properties of this file via this link. Right, here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm, and my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now if I go to the website, hit refresh, I can see the image over here. Now this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS Management Console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step, right? Leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright, guys, so my file system is now being created. Now remember, guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by You can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here to basically connect to these two instances. Right now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here, and now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is the security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking. You'll go to actions, go to networking, and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command, and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command, and my NFS common package will install over here. Right now, what I can do is I can create a directory on my first instance. Let the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test2. Okay, now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command, and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It makes sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens, your server is again and again doing a query on the database using a particular query that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay. So each user can have their own user ID and password, but basically they will be logging into the same AWS account. And that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS Management Console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now what is an application account? Let's say I have a website which can upload data to S3. Now how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise, it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means Key Management Service. So Key Management Service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation, then we have AWS OpsWorks, then we have AWS CloudTrail, and in the end we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay, so let's say I have launched two EC2 instances with a load balancer in an auto scaling group which is connected to an RDS instance, which in turn is also, connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region. I want to replicate it across multiple regions. So in that case also, CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks, and what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say MySQL on, let's say 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the OpsWorks architecture. And then in that case, it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes, which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening. And it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it. And then that log data, basically, you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now what kind of alarm can it trigger? It can either email you or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay, moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now, this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, you'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services basically, guys. One service is called Simple Notification Service, and the other one is Simple Queuing Service. Let's see what these services are. So the first service, which is Amazon Simple Notification Service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now, that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received, and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay, so based on the topics, the messages are filtered, and what you do is in the topics you will define which service to basically trigger, and based on that those services will be triggered, and the services to be triggered are basically called subscribers. Okay, so guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue or it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay, what it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to that to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So for I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will pay, you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay-as-you-go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. All right. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get, for instance, is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS, which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS, which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this, basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS, or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right, so the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you are running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect the service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free, and the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. All right, moving forward, guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now, as of now, this MySQL database is on the local host, and also the website is on the local host. And right now my website cannot connect to S3 because it is not being able to authenticate itself. All right, so this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right, so without any ado, guys, let me first show you how my website basically looks like. So let me jump on to my browser. Right, so guys, my website basically exists on localhost/new. Right, so this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading, I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my local host. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. All right, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once entry is made inside the database. Second thing is, right now if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now, how can I give authentication to my website so that it can upload on S3? For that, I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here what I'll do is I will create a user, right? And let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now, the kind of services that I want my website to access is only S3, right? So let us put an S3 over here, and as you can see, there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user, guys, I will have the access key ID and I will have the secret key, access key. Now this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID, guys, and this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like, guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket. Right, which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website. And as you can see now, it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded, right? Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload, let us not take an image. Let us try to put something else. So let's say there's this app, there's test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size, that's why it's not uploading. So what I can do is let me take this particular image, right, and let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on create database, and the type of database that I want is MySQL. Let's select that, and now let's click on next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on next, right? Now it'll ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only the instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay. So, but because our website right now is in my local host, from local host, I should be able to upload data onto the database of AWS. So for that, I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay. What should be the database name? So the database name would be the same that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on create database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. Right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on create application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take guys 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. All right. So it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit, right? So this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? And my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry guys, I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket, and this remains the same for each and every object which gets uploaded. Right, so I'm uploading, I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website. Right, so if I can show you over here. As you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right. So once I've done that, it works great. It works like it is supposed to. Now, I guess we should go ahead and check if my RDS is ready. Yes, guys. So my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my local host. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait. So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for their security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which would be the same as what I did on my local host. So the table name would be names and the field name would be name, and the type of information that can go in is varchar. Let's specify that. Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. All right, that's it, guys. That's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select start from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great, guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk, guys, and this is the dashboard that I get when I use the platform as a service instance. Right now it says here upload and deploy. So that's what I'm going to do. I'm going to click on upload and deploy, and now it's going to ask me to choose a file. Now the way you can upload your website over here, guys, is you will have to go to your website codes, right, and then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay. And now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said, and whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS :1.0. So let's say in the future I make change to my code, any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete, and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database, which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if you go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here. And if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my localhost, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that, guys. And it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it.
As I already told you, in this session we'll be looking at a hands-on. So before moving on with the session, let me briefly show you what is going to be the output of our hands-on. So this is our local host and this is our Elastic Beanstalk. So first in localhost, what I'm going to do is I'm going to upload this doc1.pdf and I upload it. So the file has been uploaded successfully. So now let me open Amazon Web Services account and I'll open my S3 bucket. So first I'll open the S3 service, and inside that there are already buckets which I've already created for this demo. So first let me go to from the bucket, because in this bucket I'm going to store all the files which have been uploaded. So first, so you can see already there was a doc1, and right now another file has been uploaded, and also because it is the same name, the file will be overwritten with another name of the current time and the file name. So we have uploaded one more file. Let me show how it works in Elastic Beanstalk too. So it is the same operation, the same code in Elastic Beanstalk. So let me upload another file. So I'm uploading this photo here. So I upload it and the file has been uploaded successfully. So in S3 now, if I reload it, and you can see that that file has been uploaded. So the final output is going to be, so we go to the bucket image. So you can see I already had 2 images, and now there is another image which we uploaded already in the bucket, from the bucket. So here you can see to the bucket PDF, and if you go inside you can see the doc one, and this one was uploaded from this local host. So you can see here that it has the same name as this one. So it is exactly the same file which was uploaded here, and it was copied to that bucket. So how did we do that using AWS Lambda? That we'll see in this session. So first let us learn the theory concepts of this session, and then we'll move on to the hands-on part. So come on, let us go.
Okay guys, now let us begin with the session. So typically an application comprises of 3 components: the front end, the back end, and the database server. Before the cloud technologies emerged, when a company wanted to host their application, what they did was they used to host all the software components, that is the front end, the back end, and the database service, on an individual server. So what happens here is, whenever you want to do an operation, like consider this website is for storing photos like Google Photos. So you upload a photo and then press the button upload in the website. So what happens now is the website does not process. It goes to the backend service. So whenever you click something here, so the process goes to the backend code. Some code is triggered. So what happens is that code runs, and after that, if you wanted to upload the photo, it will store somewhere. It will use the backend's help, and it will store somewhere, and it will show the response in your website. Also, there needs to be information stored in the database, because there is a name for the photo, there is a link where the photo is stored, and also there will be other properties like size and something else. So they will be stored in the database service. So what happens here is all the software components are hosted in an individual server. Whenever you wanted to do an operation, you click some button or do some operation on the website, which will trigger a service in the backend. So that will happen, and if there needs to be any data stored, it will be stored in the database, and the output will be shown on the website. But what is the problem with hosting all the software components on a single server? The main problem is it has limited resources. So let me explain this. So consider your website is getting a lot of traffic and it is using 80% of CPU's resources. And at the same time, the backend service needs 50% of the CPU's resources to run operations in the backend. So what happens here is front-end service uses 80%, but the backend service only gets 20% of CPU's resources to work on. And if a database service wants to use some resources, there are none left for it to use. So right now the system falls under a deadlock, and the whole server will be in a problem. So what happens is they cannot be scaled, and also this is the reason why the websites get crashed. Hosting all the software components on a single server is quite easy, but it comes with all these possible drawbacks and demerits. So what is the solution for this? Let me provide you the solution with an example. Let us see that. So the solution to this is using a distributed application architecture. So what is a distributed application architecture? It is basically using dedicated servers for each of the software components. The front-end software component is hosted on its own dedicated server, so does the backend and the database. So the front-end server only hosts the website, the backend server only does the backend operations, and the database server only is used when there is a need for the database service. But how does this improve the situation? So let me explain that. Consider the backend service under a lot of traffic or workload. So what happens now? Basically, in an individual server, when all software components was hosted, so what happened there was backend server will consume most of the CPU resources, and the other services will not have enough CPU resources, which leads to a crash. But what happens here is only the backend server will be having workload on that. The other two servers will be left unharmed. So considering the backend server has used all of its resources and has crashed, the other two servers will not have any harm on them. The front-end server will still be hosting the website and the website will be still visible to the users. Even though the backend services won't be running at the current time, the users will not be able to use the services provided by the website, but the website will still be visible on the browser. So how does this solve the scaling problem? In this particular architecture, you just have to scale the particular servers which you want to scale. Actually, so here we consider that the backend server is using all of its resources and you only want to scale that particular server. So you can just do that. You can just scale your backend server instead of scaling all the three components. Obviously, this is going to reduce a lot of cost and time. And for example, if you want to only increase the space for your database service and you want to scale your database service, you can just scale that. So to understand this better, let me give you a real life example. Let us consider Google Photos as the example. So here you can see the website. So this is the front-end server and the images which are being retrieved are using the backend service to do that. And also the links for these images, the data, that is the name of this image, the size of the images, are all stored in the database service, and whenever to retrieve this particular image, the database service provides the link and the backend service will use that link to show the image to us. So let us consider this and let me explain how all these services work together. So whenever you search anything on the search bar, so I have two images named hello and hello yes. So I'm searching hello over here. You can see there is photo ID over here 1 and 2. So the names are hello and hello yes, and the site links are this. So this is the site link for the first image, this is the site link for the second image, and the backend service retrieves these information and it will produce it over here. So this is how the front end, the backend and the database services club together. So now we have learned what is a distributed application architecture and how the front end, the backend and the database works together. So now let us move on and see what is AWS Lambda. So AWS Lambda is a serverless compute service, which means you don't need to worry about servers while building and running applications. You will just have to code as per your needs, save it in Lambda and relax. It will take care of everything else like provisioning servers. We will learn more in depth as we move along. So now what distinguishes Lambda from EC2 and Elastic Beanstalk? They all are compute services, right? But there is a difference. Let me give an idea about that. First, let us compare Lambda and EC2. Later we will move on comparing it with Elastic Beanstalk. Let me start with the first difference. Lambda is a platform as a service while EC2 is an infrastructure as a service. In Lambda it provides you a platform to run and execute your backend code, but in EC2 it provides you virtual computing resources. The second difference is that Lambda restricts to a few languages like Python, Java, C# and a few more. No restrictions in EC2, you can install any software you want in the platform given to you. And then you can choose the environment like Node.js or .NET and push your code into it in Lambda, but not in EC2. In EC2 you have to decide the operating system and then install all the required softwares, and then you have to upload your code or code internally and then execute. And then moving on, Lambda does not provide you the luxury of choosing OS and runtimes, but in EC2 you can configure every single aspect like different instance types and security preferences. So this is what makes them different. I hope you understood the difference between these two services. Now let us discuss what distinguishes Lambda and Elastic Beanstalk. Let me start off with the first point. Lambda can only run your backend code, while Beanstalk can run your entire application without you worry about the infrastructure which it runs on. Secondly, Lambda provides resources based on your workload, but in Beanstalk you have the flexibility to choose the instance type and other configurations. In Lambda you don't need to worry about any configurations or instance types. So the last difference is Lambda is stateless system and Elastic Beanstalk is a stateful system. So what is the difference between them? A stateless system is when the output is based only on the current inputs, not using any other inputs which were stored before. But in a stateful system, it may provide different values for the same inputs by comparing the older inputs. Being stateless provides Lambda the ability to create millions of process threads and execute them all with different inputs simultaneously. Okay guys, now we understood how does EC2 and Elastic Beanstalk services differ from AWS Lambda. Moving on, we'll first take a look at benefits Lambda provides and the limitations of Lambda. First, let us look at the benefits provided by Lambda. Later, we'll move on to the limitations of Lambda. The first benefit is that it provides a serverless architecture. So you don't need to worry about provisioning and managing servers. You'll just have to concentrate on building and running the application. So to be very simple, you will be given a console. You choose the language, write your code and hit run. It chooses an EC2 instance according to the required processing power. The next point is code freely. There are multiple programming runtimes and editors, so you can just choose it freely and code it in like how you do it in an offline editor like in Visual Studio or an Eclipse. The next point is no virtual machines needs to be created. You don't need to create and configure any EC2 virtual machines. As I already told, they are provided by Lambda according to the processing power needed for your function. The next point is pay as you go. Pay as you go is a feature provided for all services in AWS, and what is here is in Lambda you will be only charged for the number of seconds your Lambda function runs on for the particular seconds how many services have run, and that's it. You won't be charged anything more. The fifth point is monitor your performance. You have a default monitoring option in Lambda which is connected with CloudWatch and this particular Lambda function which generates multiple logs and metrics for you to visually and textually understand what is going on in your Lambda function. So whatever advantages a service provides, there will always be some limits to it. So now let us take a look at the limitations of AWS Lambda. The first limitation of AWS Lambda is the maximum disk space provided is 512 MB for the runtime environment. This means the /tmp directory storage can only store 512 MB at the same time. Why do we need /tmp directory storage in Lambda is that because we need a temporary storage for storing the current Lambda function's inputs and outputs, because the same Lambda function, there is no guarantee that it will execute 2 or more times. The next limitation is that the amount of memory available for Lambda during execution is 128 to 3008 MB. So this is the amount of RAM you can choose between either 128 or 3008, and between that it is a 64 MB increment like 128 plus 64, and it keeps on adding. The third limitation is that the function timeout is set only to 900 seconds. So the maximum amount a Lambda function can execute is 15 minutes and the minimum is 3 seconds. So if you want your Lambda function to execute more than 15 minutes, that is not possible. It can only execute to 15 minutes and the default is 3 seconds. So maybe your Lambda function's execution completes in 1 second, but it has to run at least 3 seconds to stop. The fourth limitation is that the only available languages in Lambda editor can be used for writing the code. The languages are like Python, C#, Java, Node.js, Go and Ruby. Okay, alright guys, we've seen the pros and cons of AWS Lambda, so now let me give you a brief idea on how Lambda actually works. Okay guys, now let us move on. So first, what you do is you write your code on the Lambda editor or upload it in a supported programming language in a zip file. So it is not that you have to create only one Lambda function. You can create any number of Lambda functions your application needs. And after that, the Lambda executes the function or the code in your behalf. You don't need to run it. So, but to run the code, you need to trigger the Lambda function, right? So how do you trigger it? It doesn't run automatically. You need an external AWS service which can trigger and invoke the Lambda function. So for example, it can be an S3 bucket or a database. So what happens is whenever a write operation occurs in the database, your function should be triggered. So you set that as a trigger. And whenever a new record has been uploaded or inserted in the database, the Lambda function will be automatically triggered and retrieve the information which you need from that. So after that, we know that the Lambda code is running, but where does it run? It needs a server or a computer to run, right? So what it does is it provisions servers and also monitors and manages it. So how does it provision servers? So Lambda functions have various types of code. So if your code requires a lot of processing power, it will choose an instant type which has more processing power and RAM. Or else if your Lambda code only executes for 2 seconds, it will choose the lowest possible instance. This will save you money and time. Okay guys, now we understood how Lambda actually works. So what are the various concepts in Lambda? Let us look into it. So now we are going to see various concepts in Lambda, and the 4 concepts you are going to see is functions, runtimes, layers, and log streams. So what is a function? A function is a script or a program that runs in AWS Lambda. So the Lambda, whenever it is invoked, this function runs. So you can see here, this is the function name, and here you write the code. So the function processes the event and returns a response. So let us see some function settings. So here you can see the code. The code is the logic you use in the Lambda function, which you write over here. And then runtime. Lambda runtime executes your function. So whatever runtime you choose, that particular code it will be written here. So that will be executed by the Lambda's runtime. And then the handler. The handler is where you mention the function's name with the file's name. So whenever the Lambda function is invoked, this particular function is executed. And then tags. Tags are key value pairs which you can mention for any AWS service just to track their cost or track their metrics. And then description. Description is describing a function which you can give while creating a function in Lambda. And then timeout. You have to set the timeout between after 3 seconds to 900 seconds, because that is the capacity, or that is a timeout period for a function, which I've already discussed in this session. So let us move on with runtimes. So what is a runtime? A runtime allows functions to run in different languages in the same base execution environment. That means in the same environment, you can run a Python file, a Java file, and a Node.js file. And this runtime sits in between the Lambda service and your function code. So it is in between. So whatever code you send, there are multiple runtimes, and it will choose the correct runtime for your file. If it is Python, it chooses Python runtime. If it is Java, it chooses the Java runtime, and it runs and gives you the executed response. So also see, you can take a look at multiple various runtimes. So these are the latest supported runtimes, and these were already announced. So first it's .NET Core 2.0 C#, so and then Go programming language, and then Java, Node.js, Python 3.7, and Ruby 2.5. And the other supported languages are Node.js, but an old version 8.10, and Python an old version of 2.7 and 3.6. Okay, now let us see what are layers. Okay, so Lambda layers are a distribution mechanism for libraries, custom runtimes, and other dependencies. So instead of downloading using the code which you write in your Lambda function, you can create layers and store those particular libraries or custom runtimes which you want to run your program in, and you can store it in multiple layers, and you can create only 5 layers for a particular Lambda function, and you can upload it so that there is no confusions while the code is choosing a particular library or a custom runtime. For example, if your code needs to run a particular library which it needs for uploading information to an Excel sheet for a CSV file, so what you do is you upload that particular library to a layer, keep it in order so that your code chooses the appropriate layer and gets out the libraries. So after that, also your layers lets you manage the in development function code independently from unchanged. You don't need to change your code or resources that uses. You can just upload the information in a zip file as layers and take information out of that, and you can create multiple layers. The maximum number of layers is 5 per function, and you can use layers which is provided by AWS customers or already available layers, or you can create your own layer. And then comes the log streams. This is the part where you monitor the Lambda function. So normally Lambda automatically monitors your function invocations and reports metrics to CloudWatch. If you don't want to just watch metrics, you can write the code in your Lambda function so that you can get logging statements for each and every step your function goes through, and you can look at the execution flow and how your Lambda function is performing and whether it's working properly or not. So moving on, now let us see how AWS Lambda works with S3. So here we're going to see how exactly an operation in the S3 bucket can trigger the AWS Lambda function. So consider a user is trying to access a website which you can use to upload photos. So if you upload a photo here, it will be stored in the AWS S3 bucket, which it is connected to. Also, whenever a put operation occurs, that is when file is uploaded to the S3 bucket, the Lambda function will be triggered. So for example, you can use it as a put operation or a get operation. So consider it is a put operation for now. So whenever the user is uploading a photo here, so it gets uploaded to the S3 bucket, and when it's uploaded, the Lambda function is triggered. So the Lambda function's code can be anything. You can make any microservice out of it. So if you want to store the file's name and the location, you can store it in the database using the Lambda's code, or you can watch the CloudWatch metrics, and you can also look at the logs which you have coded in the context of your program. So after that, you can also copy this particular file into another S3 bucket using your Lambda code. Also, if it was a get function, like if it was a get operation, if the user is trying to download a photo, again the photo will be downloaded, which is from the S3 bucket, which is stored there. So you can use that also as a trigger in the Lambda function, and you can make any microservice out of it. So this is how S3 is used as a trigger with Lambda functions. So now we understood how this works theoretically. So now it is time to move on for practicals. So now let us do an hands-on on creating an S3 bucket and then using a Lambda function to copy it to various multiple S3 buckets. So why does it go to various multiple S3 buckets is because we have mentioned a different type of file extension. So if it is an image, it goes to a different bucket. If it's a PDF, it goes to a different bucket. So whatever the file extension is, it goes to a different bucket. So let me explain that part now. Okay guys, now we are going to do a hands-on using multiple AWS services. So let me show you what we are going to do exactly before moving on with the hands-on part. So what we are going to do is, I already told you how Amazon S3 works with AWS Lambda. So what we are going to do is, we are going to create a simple website which can upload a file to the S3 bucket, and whenever a file is uploaded to the S3 bucket, the Lambda function is invoked. So what happens is, we are going to upload three types of files. One is a .jpg file, a .pdf file, and a .txt file. So whenever an image file is uploaded, it goes to the image bucket. Whenever a PDF file is uploaded, it goes to the PDF bucket. And whenever a text file is uploaded, it goes to the text bucket. And we are going to do this all with a simple Lambda code. And what we are going to do is, we are going to use the S3 buckets uploading, that is put as or post as a trigger. And whenever an object is uploaded to the S3 bucket, the Lambda function will be triggered. Okay guys, now let us see this on the AWS Management Console and how to do this practically. Okay guys, at the beginning of the video I told you that I'm running this file both on the local host and the Elastic Beanstalk. So to understand it better, first let me explain the local host part. So let me show you the code first. So this is the code. There are two files, one is index.php and the other is filelogic.php. So let me briefly explain this. This is a simple form which has an input and a button. So input is you click on a file, and button, whenever you press the button, it uses filelogic.php to execute the uploading to the S3 part. So here I'm mentioning the bucket which I'm going to upload to, and here you can see my credentials. So this is my region and version I've given latest, and these are my secret keys and the key which I have, so that it can access my AWS account and that particular bucket in my AWS account and upload it over there. So here you can see if that particular object with the same name exists, what it does is it adds $time in front of it. So if that same file exists, what it does is, normally if it does not exist, $key will be just $key. But if a file exists in the same name, if doc1.pdf and I'm again uploading doc1.pdf, so it takes the current time and adds it in front of the file name. So this is why we saw in the beginning of the video there was one doc1 and it had another doc1 file with a time duration in front of that. So now we have seen this code. Now let me show you the Python code which is used for the Lambda function. So in the Lambda function, using that we are going to send
this particular objects from one bucket to various buckets using their extensions. So let me explain that also briefly, and let us move on to how to do this using the AWS infrastructure. So this is the Python code, and first I'm importing some things which I need actually. So I'm importing JSON, I'm importing os.path. This is for getting the extension, and I'm importing Boto3. This is mainly important because Boto3 is the AWS SDK for Python. This allows Python developers to build and run applications on AWS using this. So you can write Python applications using Python programming language when you include this particular Boto3. So, and I'll explain this briefly. So this is the source bucket. I'm getting the name here. This is the file name. I'm getting it here. And copy source, I'm giving bucket, source bucket and key. So this is why I imported JSON. So I'm recording the copy source as the bucket which I'm going to upload it from. And this is the object which is going to be uploaded. And this is our CloudWatch info. So if I print it over here, it will be available in the CloudWatch streams. Like you can go to that log streams and check out these things when the function has started. So when the function started, this will be there. And after that, this information will be given. So, and then here comes the logic. The logic is pretty simple. You first check whether the object exists. If it doesn't, you check whether extension. First you get the extension or the last 4 characters, that is either .jpg, .pdf or .txt. So even if it is a file with a different extension, if it is a .png, the file will only be available in that particular bucket. It won't be copied to any other bucket. If it is .jpg, it will go to the bucket image. If it is PDF, to the bucket PDF. If it is txt, it will go to the bucket txt. So s3.copy object, bucket, this is the destination bucket. This is the file name, and this is the copy source. That is the file which you're going to upload from the bucket. That is, from the bucket is the name of that particular bucket. So also if it does not exist, so this will be printed in the CloudWatch log stream. Okay guys, now we've seen the code. Let us move on to the AWS implementation part. Okay guys, let us start from the beginning. So first you have to go to the IAM management console because you have to create a role. So first thing you have to do is you create a role. I've already created a role test. So I'm going into that, and you have to attach a policy. And I've created a policy already, which is s3_move. So you have to create a policy and use this particular JSON code inside it. So what I'll explain what this means. So I'm giving effect allow, and also over here. So here I'm giving the actions logs, create log group, log stream and events. So I'm allowing all these events to happen in the CloudWatch whenever I'm using this particular policy. So in S3 I'm allowing all operations like post, get, put, whatever operation it is, I'm allowing it to happen. So I'm giving effect as allow. Also they should have a unique resource name, so I'm providing that. So without this particular policy and role, you can't do this. So you can't basically do what I'm going to do right now. So we cannot copy S3 buckets objects into multiple S3 buckets. So you have to create this role and policy and use it in the Lambda function. So the first thing we are going to do now is we are going to create 4 different S3 buckets. One is from the bucket, which is the main source bucket, and we are going to create 3 more buckets which are for image, PDF and text. So let us do that. Before moving on with the S3 part, let me tell you how to do this without copying and pasting this JSON code over here. First you have to create a role which lets Lambda call other AWS services. So here, after clicking on create role, you have to choose Lambda so that it can be calling other AWS services. And next you have to give it permissions. You can see here there are a lot of permissions, that is, there are policies available. So before we created a policy s3_move, and we pasted that JSON to allow access to CloudWatch logs and S3. So what I'm going to do now is I'm going to give full access for S3 from searching here. So I searched S3 full, so I got full access for S3, and I'm searching CloudWatch.
Just a quick info guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now let's continue with the session.
CloudWatch full. So here you can see I got CloudWatch full access too. So I gave both. So next I'm going to tags. I don't need any tag. So I'm reviewing. I have to provide a role name. So I'm going to give this as practice because I'm not going to attach this. I'm just explaining you how this is going, how to create a role and how to attach policies to it. So you can see here there are two policies attached: Amazon S3 full access and CloudWatch full access. So what I'm going to do now is I'm going to create this role. So I've provided create this role, and now the role has been created. And as I showed you before, here you can see this, and also I can go into the policy and show you the JSON pod. This allows all the actions for S3, and the other policy allows all CloudWatch actions. See, you can see in the JSON. So you can see here it allows everything. So it allows all CloudWatch actions. So that is what I wanted to show you. Now let us move on with the S3 part.
So I'm opening the S3 management console. So I already have a bucket. This is for a beanstalk I created earlier. So now let's create 4 more buckets as I told you already. So first bucket is from the bucket. So this is what, so you don't need to configure anything. You don't need to give any tags. So you just click next and it already sets permissions. So block all public access, and also if you want you can review it once and then create bucket. So this is how you create a bucket. It's actually pretty simple. So then I'm creating to the bucket image, and I've created that. Okay, next thing is I'm creating to the bucket PDF, and I'm giving next, and create bucket. And finally I'm creating to bucket text. So I'm giving next, and I've created buckets. So right now we have created 4 buckets, the 4 buckets which we need, which is in the code for us. So what I'm going to do now is I'm going to move on to create a function in the Lambda. So first what we'll do now is we'll go to the Lambda management console and create a new function. So you can see here I already have a function. So let me create a new one. So author from scratch, use a blueprint and browse serverless appres or repository. So using a blueprint is that there are already many things. So here S3 get object Python, config rule change triggered. There are many things. So what we are going to do is we are going to author it from scratch because we are using our own code. So I'm giving the function name as AWS Lambda, AWS Lambda demo, and I'm writing my code in Python. So I'm giving Python 3.7 as my runtime. And another thing, so what I told you, we have created the role and attached a policy to it. So we have to use an existing role here. So the existing role which I told you was test. So I'm using that particular role here. I'm creating the function. So the function has been created successfully. So what we have to do now is see, I'll first explain the dashboard. So here is the configuration and here is the monitoring. So you can see CloudWatch metrics and CloudWatch logs insights. So right now it is loading. So let us see. So it will be empty right now. After the function starts executing, then we can see some data over here. Also we can see the logs in CloudWatch. Let me show that later. So first we'll configure it. So first I'm adding a trigger. Our trigger is going to be S3. So also what I'm going to do is the bucket is actually from the bucket. So whenever an object is uploaded to from the bucket, it has to be triggered. So our bucket is from the bucket, and here I'm put post or copy. So however it may be, if an object is uploaded to from the bucket, it triggers and the function starts executing. So it is all object create events. And here I don't need to give anything. If you just want to copy one particular suffix, like if you want to copy only JPG files, then you can mention it over here. So right now I'm implementing that in the code, so you don't need to give that. Also give enable trigger here and add it. So this trigger will be added. So you can see here trigger has been successfully added. Okay, so the next thing is now we have to use the code here. So you can already see there is a code written, a simple code. So let us consider this as our runtime right now. So the runtime is Python 3.7, This is the editor to edit the code. This is the handler which I showed you. So lambda function underscore lambda function dot lambda handler. So even my definition, even my function's name is lambda handler. So I don't need to actually change anything over here. So let me copy that code and paste it over here, and let us save this particular lambda function. So I'm going here, I'm copying this code, I'm pasting it over here. So the code has been copied. So you can see the imported function, imported libraries, and here is the print function, and here is the CloudWatch info, and here is the logic to copy from S3 to another S3 bucket. So now let us save this. So once we save it, it is saved. So now whenever an object is uploaded to the S3 bucket from the bucket, then this process will start happening. First, let me show whether it happens or not. So you can see here from the bucket is empty, and to the bucket image is empty, and even these two will be empty because we just created them. So right now I'll manually upload a file to from the bucket. So I'm adding files, I'm adding this image, I'm providing next, and upload. I'm uploading this file to from the bucket S3. So you can see here that the file has been uploaded. Now let us cross check with to the bucket image. So it has to be uploaded to the bucket image because our lambda will be triggered right now, and that function will be running, and this process would have happened. So I refreshed it, and you can see panda.jpg file has been uploaded here. So right now it manually works. So what I have done is I've created a simple web page which can upload files to S3, and then the process happens automatically. So what we are going to do now is we are going to create the same web page which was running in the local host. Now we are going to make it run in the Elastic Beanstalk using a URL. So anyone can upload a file right now, and it gets segregated according to the extension, and it gets copied. So I told you after execution of the function, you can see the CloudWatch metrics. So let me go to monitoring. So here you can see CloudWatch metrics, and here you can see some data. So this is invocations 1. So the function has run one time, and the duration is given here. And also the success rate was 100%. There was no errors. So you can see that here. Also let me show you the logs. So a log has been created. I'm opening that. So you can clear. So function start CloudWatch. So let me open the code first. Okay. So here function start CloudWatch. And you can see the details being delivered there. So log stream name, log group name, request ID. So log stream name, log group name, and request ID has been. So after the request ended, it is ending the report, and the report has been sent. And you can see here it took 566.10 milliseconds, and duration was 600 milliseconds. So it is rounded. So memory size, the maximum memory size was 128 MB. So there was no more memory needed for this function. So now let us move on with Elastic Beanstalk, and we'll create and deploy a Elastic Beanstalk application over there. So let us get started. So let me click on get started. So first thing I have to do is I have to create an application. So my application is going to be AWS Lambda demo, and I have to choose the platform. So my code was in PHP. If your code was in any language, like if it was in Java or Go or Python, you can choose that. So right now I'm choosing PHP. What I'm going to do is right now I'm going to create the application. Later I'll upload the code to make it more clear. So the application is creating right now. So it would take some time. So let us wait and start the processor. Okay guys, now you can see it has been created successfully. So let me show you what actually is there before we do this. So there is a default PHP page over there. So this is the default PHP page, and what we're going to do is now we are going to upload and deploy our application here. Before that, let me explain what actually there is a little change in the code because okay guys, before uploading our application and deploying it, let me show you and explain you the simple change which I made in the code. So this is the code. So here you can see index.php. So there is no change in this, but in FileLogic.php you have to change the path because you're going to upload it to an Amazon Linux environment and the path changes there. So it is /var/app/current/your file. So index.php and FileLogic.php will be in this directory, and whatever file you upload to Elastic Beanstalk will be in this directory. So what I'm going to do is, you have to click on all the files and choose over here, and you have to archive it into a zip file.
So if you ask why should we zip it rather than make the file a RAR file or a tar file, because Elastic Beanstalk environment only accepts .zip files. So you can just do it in a normal way. Instead of using WinZip, you can just click on them and you can just send them to a compressed file, which will automatically create a zip file. So I've already done that. So now let us upload this file to the Elastic Beanstalk. So let us upload now. So I click on this button. So I have to choose a file. So what I have to do is, I have to go back. We go to AWS demo. So this is the file which I have to upload. So AWS uploads FileLogic and index files are within this particular zip file. You should not create a file on top of this and give that. You have to create a zip file just clicking on these files. So I'm opening it and I'm naming it as AWS Lambda demo. So it is AWS Lambda demo. So I'm going to deploy this. So deploying it takes time. So let us wait until then and we'll check out how our application works. Okay guys, now our file has been uploaded. You can see the running version is AWS Lambda demo. This was the name which I gave for this particular application. So now let me open the URL and show you the website which is running. So here you can see our website is running fine. So what I'm going to do now is I'm going to upload few files to this and check whether it gets uploaded in our S3 bucket and it is moved to the respective S3 buckets for image, PDF and text. But before uploading, let us check whether the S3 buckets are empty or not, so that to make sure that there were no files before and only the uploaded files are getting uploaded right now. So I'm going to, from the bucket it's empty, and I'm checking all the other buckets just to make sure. Okay, now all the buckets are empty. Now let us upload few files. So I'm going to upload 3 different types of files and check whether each of the file goes to its respective bucket. So first I'm going to upload a PDF. It is successful. And then I'm going to upload an image and it is successful too. And then I'm going to upload a text file. So first let us check whether all these files have been uploaded here. So now we can confirm that the doc1 PDF, doc.jpg and text1.txt have been uploaded to the S3 bucket. So now let us check whether each of the respective files with different extensions get uploaded to their dedicated S3 bucket. So first let me go to the bucket image. Let me refresh it and you can see the .jpg file over here. So next to the PDF bucket and you can see the PDF file over here. And then to finally to the text bucket and I'm refreshing it and you can see the text1.txt file over here. So right now our Lambda function is working and it corresponds with whenever we are uploading a file through the Elastic Beanstalk. So Elastic Beanstalk is successfully running our application and it gave us an instance to run it on. So whenever you upload a file using that, our files are getting uploaded to from the bucket and Lambda function is triggered, and using this particular logic, if it is to the bucket image, it goes to the bucket image and then PDF and then text. So this is what happening in our hands-on. So before finishing this hands-on, first let me explain the complete process which we did to make this happen. So first we created a policy and first we created a role and we attached a policy to allow all the functions which we wanted to do in the S3 bucket. So and then we created 4 different S3 buckets, 1 for source, 3 for destination. And then we created a Lambda function and we uploaded a code which basically copies from one particular S3 bucket to a S3 bucket which we give the destination name. And we also created a trigger for S3, which is whenever an object is created. So from S3, from the bucket, whenever an object is created, this particular trigger happens and this function code runs.
So this function code runs. So whenever this function code runs, what happens is a file from the particular source S3 bucket is copied to the destination S3 bucket. And then what we did, we launched our application, we uploaded our local application into Elastic Beanstalk and we deployed it. And we right now have an URL to run our application. So then now we are going to see CloudWatch. So let me refresh it once more. So we've uploaded multiple files after that, and you can see there are multiple logs over here. So this was the first time, and then you can see whenever the next time the function is coming as function start, and that is the next function. So the function will be keep on running. So you can see log stream name, log group name, request ID. This is one particular function execution, and this is one particular function execution. This is one. This is one. So the function has been executed this many times, and the function was started at the first time. So this is how we have to use CloudWatch. Also, you can see the CloudWatch metrics over here in the monitoring tab. So here in the monitoring tab in CloudWatch metrics, now you can see there are totally 5 invocations. So the CloudWatch has been invocated 5 times. That means the function has been run 5 times. And here you can see the success rate. The success rate has been 100%, and there are no errors because all the files which we were uploading got uploaded, and the function never got any errors, and it ran successfully. So right now I hope you guys know how to use Lambda to write a code and use that and use other services like S3 as a trigger to run your particular application. So right now we've learned multiple services. We learned IAM to so that we have to create a policy first, and then we know how to create S3 bucket. We know how to write code in a Lambda editor, and then we know how to use CloudWatch, log streams and also metrics, and also we learned how to upload your local application into Elastic Beanstalk so that you will get your own URL. You can access it from anywhere in the world.
So use cases of Lambda. There are various use cases of Lambda, but right now we'll discuss 3 of them. So the first one is the serverless websites, the second one is the automated backups, and the third one is filtering and transform data. So let us see serverless website. So I already told you what is a serverless architecture. A serverless architecture is where you just have to code and it automatically takes care of provisioning and managing servers and its infrastructure completely. So what you can do here is you can host your static website on S3. Your static website is basically HTML, CSS, JavaScript or TypeScript files. It cannot run server-side scripts. You can only run client-side scripts. So in server-side scripts like PHP and ASP.NET cannot be hosted on S3 as a static website. And using S3 for static hosting is very cheap. And you can write Lambda functions and connect them with the S3 to correlate it. You can make your static website available using AWS Lambda by writing some code so that the users can keep track of any resources which is being used on the website. So next is automated backups. So the word says you everything. The sentence, the automated backups, you can automatically create backups. You can create Lambda events and schedule them at a particular time on a particular day and create backups automatically in your AWS accounts. So to create backups, you can check whether there are resources idle and take those content and just back it up and delete it from that particular place. And also you can generate reports using Lambda in no time using code or just connecting it with CloudWatch. So you can generate every report and you can see how much of data has been backed up, how much of data has been deleted, and you can manage it very easily and schedule it on time. So the third use case is filter and transform data. So you can connect Lambda with other Amazon services like S3, Kinesis, Redshift, and database services like RDS, DynamoDB, or Amazon Aurora. So you can filter the data before sending the data to any Amazon storage service or database service. You can filter them using the code, and you can easily transform the code and load the data from between Lambda and to all these services. Now let us discuss Lambda pricing. First, let me explain what is free tier. Free tier is provided by AWS for a 12-month period, and in that period you can use free services which are provided by AWS. You can use free tier eligible services You can use services like EC2, S3 and even Lambda for free, but they have their own limitations. For example, in Lambda, you can use 1 million requests per month or 400,000 GB seconds of compute time per month for free, and anything exceeding that will cost you. Also, you might be guessing what is GB seconds and 1 million requests. 1 million requests is when the Lambda function is triggered 1 million times, and GB seconds is gigabits, that is 1000 megabits per second, that is the transfer rate. So 400,000 GB seconds of compute time per month is allowed. 400,000 GB seconds of transfer time is allowed per month for any given Lambda function. And then requests, as I told, 1 million requests are free, and then after that each 1 million requests costs you $0.2. And after that duration, I already told you what is GB seconds, so 400,000 GB seconds per month is free, and after that every GB second you use will cost you the number which is given there, that is $0.000166667. So that is all about Lambda pricing.
We have seen the various Amazon services. We are going to learn about some more services on the management side, the deployment and managing of Amazon services. Till now, if you see, if you want to deploy applications, you might be using EC2, EBS. For monitoring, you would use the CloudWatch. For storage, S3, even EBS would be helpful for your persistent storage. For scaling, auto-scaling, Elastic Load Balancer and CloudWatch. VPC for security, IAM for security, RDS for database. Now, we will be talking about the deployment and management. How do you deploy your application better way? How do you manage them better way? That is what we are going to cover. The Amazon Elastic Beanstalk. We would see what is Elastic Beanstalk. We would see about the key features. Now we are covering a few services where it's very important for us that we understand why they are used. We might not be going so deep down, but at the same time their understanding why this would be useful and how would I use that service, it's very important for us. Elastic Beanstalk is a easy to use service for deploying and scaling web applications and services like Java, .NET, PHP, Node.js, Python, Ruby, Go, Docker, whatever stack you want to work with, it is available. What it does is, if you are a developer, suppose you are a developer, you want to deploy your application on Amazon. What are the steps you would be creating? You would be creating an application. Now it's a Java, you might be creating a var file or jar file, something like that. For .NET, it might be separate format, something you would be making over there. Whatever the version of your code, you would be uploading that to an EC2 environment. So you would be launching an EC2 environment. You would be managing this environment. So the management includes so many tasks like security, AMI creation, server setup, that's your Tomcat or PHP or whatever, your load balancer, your auto scaling. So version management, whenever new version is coming, that you would be doing with the AMI also. Backup management. Now, log management. All these tasks you are doing in managing environment. What if there is a tool available which would be doing all these tasks on behalf of you? All these tasks it's doing on behalf of you. You only need to focus on creating an application and uploading here. Everything else is being taken care by this environment or this tool. What would you call that? Yes, I'm sure you would be saying it's an elastic beanstalk, you would call it. No, there is something different word also. It's a very easy to use, very simple. And the advantage is it gives you very quick deployment options. It supports various stakes, multiple stakes. It also supports the automated deployments. It's available free of the cost. No charge at all for all this management. Yes, any resource it you launches, like it launches an instance, it creates a load balancer, whatever it is doing, that would be, it's charging for that. It's a scalable because it's doing all this scaling activity on behalf of you. highly reliable. It does support your version management too. This is a PaaS offering. It's a platform as a service offering for you, which is managing all the platform for you, your deployment, scaling, backup. A platform is offered to you. If you remember in our cloud computing video, we talk about this. This is a PaaS which helps me manage my platform. Here, Elastic Beanstalk, where the developer would have a full control. Here you would have a root access to your EC2 instance also. And in that same instance, you can create your own applications also. It does support auto scaling, elastic load balancer, RDS, CloudWatch, so integrate with those application services. It also helps you make your custom AMI. If you want to make your custom AMI, you can do that. Let's not stop that only Elastic Beanstalk is doing this. Elastic Beanstalk says, I am doing everything on behalf of you, but you are also free. If you want to do something more, you can do that. Important is, if you want to manage load balancer, you want to manage the auto scaling, you want to manage the CloudWatch part, you want to manage the EC2 configurations. Here with Elastic Beanstalk, everything available monitoring at single place, easy to manage for you. It gives you an automated deployment, automated version management. It has the manage environment settings. So all environment settings are managed by it. You can always modify that. Whenever you upload a version also, new version, it keeps the backup of the older version also. And whenever it is deploying this new version, it would automatic restart of server and AMI creation would be taken care by it. Whenever this version is doing, it also manages the log for that. So everything is easily managed by you with the Elastic Beanstalk. If you see under the hood, underlying how the Elastic Beanstalk would work for you is, it gives you an environment where you would have a, when you create an environment, it would be creating a various EC2 instances. That each EC2 instance would have a internally, if it's a Java stack, it would be having Amazon Linux. On top of that, there would be an Apache and Tomcat install out of that. Only thing you need to submit is application. Application would be automatically deployed on Tomcat. A log file would be created for that over there. Automatically, it would be making an AMI also out of this. And this whole environment would be managing, it would be if required creating auto scaling, load balancer, everything it would be creating for you. If it needs to replicate more environment, it would be doing everything managed by Elastic Beanstalk. Let's see the demo of the Elastic Beanstalk and see how it helps us. So I am in my AWS console and I am going to the Elastic Beanstalk. Here currently I have no application available. As we say, it supports the multiple platforms: Java, Node.js, PHP, Python, Ruby, Tomcat, IIS, Go. These are the web servers you want to, or Dockers also, the containers also it supports. Pre-configured Docker with the Glassfish, Go, Python, it supports that. I can go and say create a new application on top. I give name something like this. For Elastic Beanstalk, I shouldn't write. Now, which web server do you want to use? Do you want to use the web or do you want to use the worker environment? The web means you are going to deploy an application with the web server like Tomcat or something like that. I can say create. I'll say I'll go with the Java. Do you want to go with the single instance environment or do you want to go with the load balancing environment? I say go with the load balancing environment. I am okay. Now, do you want to upload your own application or you say no, use the sample application only? Whatever the sample application available with this Beanstalk, you can do that. It also supports the how do you update your application also. Sometimes you want to upload your application. What you can do is, if it's a with the load balance and all that, you can say 30% of the fleet only update that time, or only whenever you're applying a batches or patches, whenever you're applying new application, do it for one instance at a time, then do for the rest instance. Then this is my environment name would be, and my URL would be something like this. Let me check it's available or not. It is available. I just give some description and I say next. Do you want to create an RDS database also with that? If you want to, do you want to create this environment inside a VPC? I say yes, create inside a VPC. Okay, which key pair you want to use? I say use my original key pair, Intellipaat. Do you want to get notified anything about that? I say yes. Do you have any application health check URL you want to specify? I say no. Whatever the load balancers, these are the, now you see, these are all load balancer settings you are doing. You are making those checks here. Automatic updates, health checks, cross zone load balancing, connection drainage, everything you would be supporting here. What would be your root volume? Do you want to say magnetic general purpose provision? I say general purpose. Do you want to specify your size of the root volume? I say no, go ahead, whatever is default I would use that. What is the key name? So name is already we have reserved. So if I want to give additional tag saying that environment, it's a demo environment, I can say that. Which VPC do you want to use? I say this is the default VPC. I want to go assign a public IP address. Yes. Do you want to use the ELB supports all zones? EC2 also supports here. So auto scaling would be also supporting. So here we are supporting for the ELB and the auto scaling, which zone it would be used. VPC security group, I can say use my Intellipaat security group. Elastic load balancer visibility, it's external only, it should not be internal. Do you want to create a role? No, I'll just go ahead with whatever it is. These are the settings we have configured. So you see application information, environment, it's a web server, 64-bit Linux with load balancing and auto scaling. Sample application we are using. Environment name is this. This would be my URL. It's a t1.micro. Key pair is Intellipaat. General purpose volume. VPC with security group. All is configured and I'll say launch. It has started creating environment for me. Isn't that easier? Everything is being taken care. Now we learned the load balancer, we learned the auto scaling, how do we configure everything. Here everything is taken care by a single platform. Wouldn't that be a fun and easier way to manage? It would be creating each and every, so you can see the log also at the bottom, what it is doing. Whenever it keeps doing everything, it would keep adding the things at the log also. So we can see, till the time it logs comes, we'll see different part. When I go to the configuration, you can modify various configuration. As I mentioned, it's one place to monitor or manage all your configurations. So here you can say, this is my auto scaling configurations, where it says number of instance 1, auto scaling by entity also defined here. So it says currently there is 0 instance, but minimum and maximum is set. It says minimum is 1, maximum is 4. It supports all availability zones. Cooldown period is 6 minutes. Scaling triggers are also set that on network out you scale out, network in you would be scaling up. So scale out means adding one instance, or scale up over there. Scale in means you are decreasing the instance. If you want to set up the time based, schedule based scaling, you can also set up that here. You can add a schedule event also here. So this is how you are configuring your Elastic Beanstalk with that. I come back to configuration. You would also see this is the instance type, storage type. If you want to modify that, you can do that. This is the notification. This is the software configurations. How the updates would be deployed. Your networking. So this is your load balancer thing. You want to set up. This is the listener port. If you want to use the SSL with that. Do you want to enable the session stickiness? Health check interval. This is how we configure health check with the elastic load balancer. So all the elastic load balancer parameters in a single page. Same way all your VPC parameters in a single page. Now remember what is happening. Till now we learned the various services. We learned the EC2, we learned the EBS, we learned the autoscaling, we learned the load balancer, we learned the VPC, we learned the CloudWatch. Now you see combine of everything is available in a single page. This is your pass. Gives you the power to manage your application. It would also keep generating the logs. What is happening? Currently, since application is not logged or launch, after that it will start generating the logs and do that. It will keep checking the health of this also. What is the instance ID? What is its status? You can see also here very easily. So load balancing request, latency, how it's performing, load average, everything available here easily. You can do your own monitoring with the CloudWatch. Alarms you want to configure, you can add alarms also. If you want to subscribe to various events, you can do that. You have given certain tags, it would be doing the tags also. If I go to my EC2 by now, you would find that it has started launching one instance for me. The demo name which we give, it is the URL of this. This URL it is working on. It is having the various security groups. So it is having 3 security groups. One is Intellipaat, which says 80 and 22. Should just check the rules here. We can check the rules here. So it has opened 80, 22, 80, all rules it has opened here. So this rule it has added from the second rule is coming from this new security group it has created. The new rule says open port 80 for this security group. Now what is the security group? We will see that. This is SG414, which says open for some elastic load balancing security group. That's a 94. I add the second group also. This group allows over 80 traffic. So now load balancer is allowing the traffic on port 80. My security group allows traffic from port 80 from load balancer only. So if I directly try to hit this URL, it would not allow me. It would allow me because I have another security group which is added. That's the Intellipaat. If I remove that, it should not work. Rather, it should not allow port 80 directly with this. Even if I have not selected Intellipaat, that is okay. It was not required because Elastic Beanstalk has created its own security group and manage everything on behalf of me. I believe everything is ready for me. It's still creating. Let's check the URL if it's available and working for me. You can see that's ready. Your first Elastic Beanstalk Java application is now running on your own dedicated environment in the AWS cloud. You can see how do you work with the Elastic Beanstalk. That's the links they have just given. How do you work with the logs? These are the things available. But this is my application is set up and running over here on port 80. So this is how you will be setting up your environment and how it would be working for you. We can now go ahead. We can see this is the environment. It must have created a load balancer also. A load balancer is having a URL something like this. This URL is mapped with my Elastic Beanstalk URL. and this is how it is managing. My load balancer is managed with the URL, so that is managed by the Elastic Beanstalk internally. It would not be using my Route 53. It would be using the Elastic Beanstalks, and how this load balancer URL is mapped, that is managed by the Elastic Beanstalk. But overall, everything, yeah. If you want to give a sensible name to this URL, then you can use the Route 53 on your own. You can use Route 53 and manage this. Otherwise, you can directly use your own or whatever they given by Amazon, you can use that. So this is how the Elastic Beanstalk works. We are going to learn about the AWS DynamoDB. For that, first we would try to understand what is a NoSQL database. We would have an introduction to DynamoDB. We would have a key DynamoDB terminology, and then we would have a hands-on on the DynamoDB. Generally, when you have an RDBMS, that's a relational database, what does it follow mainly? It follows the ACID properties of a database: atomic, consistency, isolation, and durability. Now, in some cases, it's not possible to follow the ACID. Plus, when you see a database structure in a table, what would happen? If you have a, suppose you need an address record, you have a 10 fields. 6, 7. For now, keep it 8 or 9. Now, each column or each row would have the same number of columns. Whether you are using or not using, it would always have same. That is the rule of the RDBMS. But in some cases, you need only 2 columns. In some cases, you need only 4 columns. In some cases, you need completely different data structure. Is it possible to achieve with the RDBMS? No, the ACID properties does not allow that. What if we have a completely unstructured database? Unstructured database means in one row you want 3 fields, you get 3 fields or 4 fields. In one row you need 10 fields, you get those 10 fields here. In one row you need only one field, you use that only. This is the unstructured, and it may happen that whatever the data is in row 2 might not be similar way, the columns might not be similar as row 1. They all would be different. It's a kind of a schema-less unstructured data. NoSQL database is an unstructured database. It stands for not only SQL. It doesn't mean that it doesn't have the SQL. It means not only SQL. There are popular NoSQL databases like MongoDB, Cassandra, CouchDB, and many more. Amazon is having its own offering called Amazon DynamoDB. That is the NoSQL offering from Amazon. Amazon DynamoDB is a key value store where everything is stored as a key and there would be a value corresponding to key. So for example, you take the data of a citizen. A citizen would have some unique ID to identify that. Now one thing it would have is its a name, email, address, phone, everything. One would have this ID, but only its education, you have not much information. One would have its a name, plus it would have some more data like its a name, phone, email, address, education, graduation, job information, his personal information, everything would be one row might have that. So it's a completely unstructured. You can do this with NoSQL. So important is there would be a key and each key would have a corresponding values. It's a highly scalable and fully managed database. Now what do I mean by the fully managed? The fully managed database means you don't have to worry about the database creation, database scaling, database backup, security patching. You don't have to worry at all about that. Everything is being managed by the Amazon itself internally. High availability, fault tolerance, everything, even scaling. So what you have to go is you have to go and create a table only. When you don't have to create, like we in RDS we were creating a database instance, and inside that we created a database, and there it had a database tables. So where we were responsible for managing backup, or if we require snapshot, though RDS provides all the mechanisms, or we have to plan for the multi-AZ, we have to plan for the failover, we have to plan for the performance with the read only, even we have to select the instance type, large, small, extra large. Nothing here. You just have to go and select a database, or directly create a table only. Now what is the advantage you get here is, with this, since it's a fully managed, you would be now able to work in a way that it would be able to, you just have to define the performance. What are the concurrent users you would have? Only thing you need to define is that, and based on that you would get the throughput. Based on that, automatically it will be scaling, automatically security patching. Fully it will be managing on behalf of you.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
You can access through console and APIs. It doesn't have a separate database client. Like in MySQL, we use the HeidiSQL, or you can use the Toad, PLSQL Developer, MSQL Studio, something, whatever you're using. Here, there is nothing like that. It is only through console or APIs you would be able to use that. Very high performance, and you can dictate your performance also. You want to say, I want the 1000 reads, 500 writes, or I want the 10,000 reads, 200 writes. What is your performance required? You can define and you get that. It's a fully managed, so automatic hardware and software provisioning. It's internally secure, all the data encrypted. It does manage automatic patching, upgrade, everything. Very, very, very easy to use. So we saw that DynamoDB is a fully managed scalable database, and it gives you predictable and controlled performance. The predictable and control means you can define what kind of a performance you want. You define and say what is your requirement. It comes with a built-in fault tolerance. So whether it's a working fine, not fine, it's everything is defined here. Automatically it would be internally, if it fails, like we saw the case of the elastic load balancer RDS, inherently it's a fault tolerance and it would be start serving you from the different infrastructure. Very flexible. What's your requirement? So you watch your concurrency requirements, otherwise it's scalable, easy to use. It can integrate with the Amazon's own Hadoop offering called Elastic MapReduce. It can work with the CloudWatch for the monitoring it provides services. It gives you strong consistency and atomic counters. So there are two kinds of a consistency model it offers, which we will see in a while. When you go to the DynamoDB in RDBMS, if you go, it would have a table. Each table would have a row and a column. Here, it would have the table, but then table would have an item and the attribute. You do not need to create a database, just create a table. And DynamoDB database itself is a collection of table for you. So table would be collection of the data. In each there would be an item which is nothing but a group of attributes, and this attribute is nothing but a fundamental data entry or the how the data is stored. For example, you have a training record, so for that you have a given unique ID, that's ID number 1. Who is the trainer name? ABC. Which training did he take? That is the AWS. On which date did he take? This is the date. What was the rating, 4 or 5? Whether course material available or not. In some case it's not that, it would be who took the training, that's a XYZ. The training is still not ready, so you just have that content ready or not, it's not ready. In third record you would have a trainer name, trainer email, trainer rating, date, follow-up session, hands-on session, training material available, feedback, and many more attributes. Each and everything, this what you are seeing is an attribute. You can say attribute is like a column in database, but the difference is it's a fundamental data entry, and it can be unstructured in a way that multiple attributes make one item, and each item can have a different number of attributes. In our RDBMS, each row had same number of columns. Here you can see one item has a 2 attributes, another item has a 10 attributes, another item has a 6 attributes. That's why besides the key attribute, this is the key attribute. That's where the record is identified. Apart from that, everything else is unstructured. Each attribute is identified by a primary key. in the primary key is nothing like through which you identify. The primary key are of two types. One is a partition key, which is a simple primary key, which is composed of one attribute known as a partition key. That's like a normal primary key. Apart from that, there is a partition key and a sort key. This is like a composite primary key. Sometimes you want to say the training record and then the trainer name. Both should be combined, because one training is conducted by many trainers. So here the trainer name would be a sort key and the training ID would be a partition key. So one would be having a multiple names over there, or training name would be. Till now we have learned the various services and covered about the Amazon CloudFront and Amazon Import Export with the Snowball. Amazon Simple Email Service. You would see what is Simple Email Service, where this is used, what are the key features of the Simple Email Service, and we will see a demo of Simple Email Service too. Amazon SES is a cost-effective, scalable email service. It is useful to send bulk emails. Remember, this is not your replacement of your Gmail or Outlook mail. No. But if you want to send a bulk mail, transactional mails, huge number of mails, this is the ideal solution for you. A few months back, Amazon SES also started a service called Receive Email. Initially, it was only for sending email, where the mails would be received, delivered to your AWS S3 bucket. But the major purpose is it's used for the sending email. Important aspect is it supports pay-as-you-go model, very cheaper. Free tier gives you almost 50-60,000 plus emails in a month, free of cost for up to a year, and then over again also it would be charging you 6 cents per around 1,000 emails. So that's a very cost effective and cheaper service. It's highly reliable and very scalable. Simple email service, easy to use and very scalable. Important is it gives you a feedback loop mechanism also. So whenever a mail is bounced due to any reason, over quota or due to the wrong email ID, it gives you back. And it also keeps track of that how many mails from your end are bouncing. And with this feedback loop, you can always increase your delivery rate. It does work with the Amazon other email services or other services. It can integrate with them. And it is a very easy to use interface. We will see that also in a demo. Where it would be useful. When you want to send for bulk and transactional emails, it's a perfect support. It does support the SMTP also. So you can use the SMTP to send the emails using Amazon SES. It does support the receiving emails also and deliver them to the S3 bucket. But do not use as a junk email, as AWS may stop your access. Remember, that's a very important point. If you try to misuse the SES as a junk email for sending junk or hacking or some other purpose, Amazon would stop your access, because Amazon keeps giving you feedback, what your success rate, everything, and it also keeps track of that. If it finds there is a huge number of bounds and your production access may be stopped for SES, it would not allow you to send more emails. It's very important you use it wisely. It's a very cheaper email service for delivery, cost effective. And those emails are bound to fail. We know that emails may bounce. So it doesn't mean that if one or two mails fails, Amazon would stop your production access. No. But it evaluates you. It continuously keeps checking what is your bounce percentage. If you send 1,000 mails and 10 mails bounce, that's okay. But if you send 1,000 mails and 600 mails bounce, there is a serious problem. If there are a huge number of complaints received from your email, or the quality of email is not good, it keeps checking how much bounce percentage, how much complaints, how much over quota, something like that, and it thinks, okay, there is something wrong. SES takes those parameters very seriously, and it can reduce your production access. But if your bounce percentage and the quality of email is good, it's within a measure, that measure is defined by Amazon, SES is very cost effective and service for sending email for you. How would you use SES? When you sign up with the SES is having two modes. First is you have to sign up with a simple email service. you would be using, initially you would be using beta access. During the beta access, whatever email you want to send from, so if you want to send from my email ID, learnawsonline@gmail.com something, and you have to first verify those emails before you can send from that ID. Even if you're sending a mail to abc@abc.com, you have to still verify that email ID. Otherwise, it would not support. You have to send to approved emails only. So abc@abc.com has to approve you. Then once it is done, you can request a production access. Once the production access is approved, Amazon would allow sending around, if I remember, 24,000 50,000 emails in a day, or little more, much more. But everything keeps increasing gradually based on the mail quality you are sending. And then you can send email to all. It will keep checking the feedback. So in the production access, you do not need to get approval of each and every email addresses. You can send to all, but yeah, in that case, the feedback would come in a picture. It would keep checking whether person is having a lots of bounds, complaints, and if there is so much complaint, the production access would be banned. Sometimes it may happen that the people, suppose you are sending an email from abc@gmail.com. Now, the mail would be from this person, the SMTP and the from would be something from Amazon SES. In this case, quite a few mail clients would consider that this is a spam mail and they would immediately move that to a spam. So that's not the right way. How can you overcome this? You have to use domain key identified mail service. This is this is a standard that allows senders to sign their email message. So when those email messages are signed, they know this is an authorized email, this is not a junk. It might be used from a program, but it's an authorized. Then it's considered as a legitimate mail and it would be delivered to your inbox only. It would not go to some other box. This DKIM signing helps you delivery of email message. ISP can verify this. This DKIM also you can configure using SES console or using the REST APIs. What are the typical use case of the simple email service? You can use for the transaction emails, bulk emails, system emails, gaming, social networking, blogging, subscription emails, business emails, and many more. Just in a case, the people who are using Candy Crush, they might be sending a receive request to their friends, though it might be through Facebook, but there might be a way you can invite through emails, or there would be a way you want to share your score with your friends. Simple email would be a easier service for you in this case, where you are a game programmer, you want to send those transactionals or gaming or the bulk social networking mails. This is a perfect solution for you. Let's see a demo of the simple email service. I'm going to simple email service. Currently there is nothing available. So either you can, if you are owning your own domain like intellipaat.com, you can verify your domains, or I'll start with the email address. I'll say verify a new email address. So verify this email address. It has sent an email to this learn AWS. The verification is pending from this user. If I open my inbox, it would show there is an email from Amazon Web Services. It says, do you authorize this person? I say yes. Once it is authorized, Now I can use this console. It's a verified. I can use a send a test email. Remember, I am still in a production access. Sorry, I am still in a beta access. I need another email ID. So if I say abc@gmail.com, just an example. When I try to say send, it would not. The abc@gmail.com is not verified yet. I need to verify that email ID, else I have to send an email to only authorized email ID. So it would send the mail to them. You would see that there is a mail from me only. The sender is me and it has sent me, hello, how are you? If I go and try to see the headers, you would see the received from a@smtp amazon ses.com by Google to learn AWS online.com. So mail is received from this, and in those cases, if it's not authorized, it's likely that it would be marking them as a junk. Or so that's why it's important how you deal with that. Now, if I go back to my console, this is how you send an email. If you don't want, you can always remove this ID. You can get your sending statistics with CloudWatch, how many mails you delivered, how much it worked. You can make your SMTP settings also. If you want to use it programmatically and you want to use it you want to do it using SMTP, you can do that. This would be your SMTP server name, this would be port, you can use that. If there is a Amazon creates its own separation list, like if there are the mails bounced across the globe from various people, you can use that also. Those would be automatically, if you're sending the people using SES to those same people, it would be removed automatically. You can remove those separation list also here. If you have enabled the domains, then after enabling domains, you can also enable the DKIM setting. That also you can do that. So this is all about this. Now you would say, how do I enable my production access? So to enable your production access, you have to go and request over Amazon support. Over Amazon support, you have to go and request. So if I go to support center, and here you have to request for the SES production access. I have to create a case. Remember, this is where you have to request for service limit and Amazon. Here you have to accept request for that. Okay, for US East, I want what are my times of mails, what I'm going to do. All that you will be able to request here. You have to request over support. Now remember, the support service is free of cost because you have selected basic support plan. Amazon offers various different kinds of support plans. Ideally, with a free user tier, it would be good. We can increase the limits with that also. Amazon Elastic Block Storage is mainly used for the persistence data storage. Now, what is block storage? So when you talk about the storage system, there are two kind of a major storage system. One is a block level storage system, another is a file level storage system. In the block level storage system is more like a SAN or storage area network, where each block behaves like a raw unformatted volume. It's like each block is an independent hard drive. It works like a device which is mounted. It works as an independent hard drive. This each block is again controlled by the operating system. If you want to imagine, this is more like your hard disk over a remote network. In compare, when I go to the file level storage is more like a NAS systems. It's more like your regular file system. It's very easy to use and manage. Now when you go to the Windows and whatever kind of a file system you find, that's more like a NAS systems. And that's why it supports the various protocols like NFS, SMB, CFS kind of a protocols it does support. Advantage of the file level storage is that each can control individual files and folders, and that can be managed by this file level storage system. We know that we have in Windows, we would be creating a files and everything we can work with. Here in the block level storage, they are unable to directly control the smaller storage blocks. Here everything works as a block. Yeah, block might have as a data as a folder, or block might have a data as a file, but it's a whole as a block. One block may have a multiple data as part of that. And that's why those smaller storage blocks would make up your files and folders. So if you want to control at the OS level, now when you see at the OS level, you can see, oh, even my Linux machine would have a files and folders, then why it's a still block level storage? But remember, at the underneath, there is a block level storage, which everything works as a blocks, and the data might be stored in the various blocks. And Amazon, when you talk about, manages those blocks independently. So that's why when you talk about the block level storage, one thing which is very important, you have to create a volume, you have to deploy an operating system, and then attach this created volume to the instance or server where you want to attach. While in the same case of the file level, the storage device handles the files and folders on the device over there. So there is a difference between block level and file level storage. At the same time, block level would also bring you more control, because if you want to take a backup and something, it would be easier to do that part also. Very good part over there. So we would be talking about the Amazon's own persistence block level storage, that is EBS. It gives you block level storage volume. So each EBS is known as an EBS volume, and that would be used with the Amazon EC2 instances. Also, Amazon does offer the relational database service, that's a RDS, which we would be seeing in the future videos. That also uses the underneath the EBS, because at the end what you need is a persistent storage, and that makes it idle for file system persistent database storage. EBS is the use case for you. If you remember, in the EC2 section we talk about there are two kinds of AMIs, EBS backed and the instance store backed. In the EBS backed, the root device is EBS volume. It gives you persistent storage, and this persistence also helps you achieve high availability and the reliability for the volume and the data. If you want to take the backup, it's a very easy mechanism. Just take the snapshot, and we would be doing in the hands-on also. That's a very easy to do that snapshot. Advantage is snapshot is an incremental. So whatever the data is being modified, only that part would be backed up, not everything. This EBS volume comes between size of the 1 gigabytes up to 16 terabytes. So you create volume as per your requirement. You increase that. It also helps you with the security because it provides the encryption mechanism. In addition, if you want to increase the size of the same system, you can do that. You can add multiple volumes to a single instance. So there are multiple use cases and advantages of using Amazon EBS volume.
So let's get started right now with the IAM, that is Identity and Access Management. So Identity and Access Management is basically a service wherein we can create multiple users to whom we can assign the AWS login ID and password, the access and the credentials. So let's get started. We will look into what is IAM. We will look into users, groups, roles, and demonstration, the hands-on demonstration I'm going to perform for each one of them. Identity and access management enables you to securely control access to AWS services and resources for your users. So we can create and manage users, assign policies, we can create groups. Then Identity Federation is the service using which we can associate Active Directory with AWS, and we can create and manage roles, and we can restrict the users like what all services they can use in AWS. So that's the reason the term has been used. Fine-grained access to AWS resources. We can create and manage policies, and the most important part, this service is free. Only you are charged for the underlying resources. So let's get started with IAM. So, and sign into the console. So here we go, and we have to go inside IAM. IAM. Using IAM, we can create groups, we can create users. So first thing first, let us create a group. So I'm gonna give the name Intellipaat admin. So all the admin users will be put inside this group, and I can attach the policies. Suppose all the users who are being added, I want to give them EC2 full access. That means both read and write access to EC2, but not anything else. And I will go in users and add user. So the first username will be Ram, then it will be Ramesh, it will be Rohan, then it will be Rahul, and one more. So these are the 5 users I have added, and I want to enable the AWS management console for them to be accessed using the username and password. So either I can go with auto-generated password or I can customize the password. So as of now, I will keep the password as 12345678. And if I check mark this option, users must create a new password at next sign in. And now it's asking me, there is already a group that is int admin. Do you want to associate it, all the users with the group? Yes, I want to. So these are the choices I have made. There has been one policy attached, that is IAM user change password. That means on the first login, it is gonna ask the users to reset the password for them. And then I will hit create users. So these 5 users have been created. I can download a comma separated file so that I can share it with my management. So individual user's name has been added with a link with which they can log in. So he will use this particular link, and the password, the username is going to be Ramesh, and the password will be 12345678, and sign in. We can see that Ramesh is able to log in right now. So straight away it is asking to reset the password. So the new password is going to be any random password, 8765431 and 8765431. So he has Ramesh @root login ID, and he cannot use any other service other than EC2. So the only service that he can use is EC2. The only service he can use is EC2, and let us say if he wants to use S3, because we have only given the rights, that is EC2 full access. So you can see access denied, but no issues at all with EC2. He can spin up the virtual instances, he can see the other virtual instances, so on and so forth. Now I can log out from here and log into my root. IAM username is going to be, so I will log in with the root account, that is my account credential. And now, so the users have been created right now. So we can add a feature called multi-factor authentication, right? Like those of us work from home, the companies provide us one key fob so that we can access the company's network remotely using a VPN. So we can have the same feature here as well. Like, so we are inside Rahul's account, and we can go inside the Ramesh account as well. And if I go in security credentials, so you can see that the console login ID, we cannot edit it. Like the password, we can edit it, and we can also enable multi-factor authentication. So how do we do that? I click here. It's asking me, do you want a hardware MFA device or a virtual MFA device? So I will go with a virtual MFA device. And next step. So it's basically asking here that on your smartphone, you should have one Google Authenticator. Okay, so you can see on my computer screen, this is my mobile phone. And so this is the application that I have downloaded, that is Google Authenticator. And you also need one application that is QR code reader. So QR code reader is right here. It's right here. So what I'm going to do is I will go here, and it's asking me to scan the code. So I'm going to scan the code with the application that is QR code reader. And you can see that on my mobile phone, Amazon Web Services, a key has been added in Google Authenticator for Ramesh. And for Ramesh, this is the code 254157. 254157. So I will type 254157 and wait. So it's changing. The new code is 718125. So I'm going to say 718125. Hit enter. It accepts. So I will say finish. Now next time Ramesh tries to log in, okay, so here we go for Ramesh, and the password is 8765431. I say sign in. It asks for a multi-factor authentication code. So I will again refer to my cell phone 300083. So 3000. Now I'm able to log in into the Ramesh account using multi-factor authentication. Let me log in back with my root account. So I will say sign out, and let me log in with the, so I will click on this link and it will take me to the root account. So we can attach the different policies on the fly. Like if I go in groups, so right now in this group, we have Amazon EC2 full access. Let us say I want to give the users S3 full access, and so I can do that. Okay, now all the users will be able to access EC2 as well as S3. So that is users and groups. Now this is the flow chart create users, create groups, assign user to the groups, create the policies, assign policy to the user or group, user access AWS resources. So this is what exactly we did just now. Now these are the definitions. So these are some terminologies. The account you use to register with AWS is the root account. Then we can create the login password, secret keys, and AWS policy can be integrated with S3, so that we have already seen. Then we can add multi-factor authentication using IAM.
Now, it is very important for all of us that do we monitor this service? Monitoring is one of the key aspects of any infrastructure. Unless you monitor, you would not know how this infrastructure is behaving, what are the trends, whether you need some upgradation, whether you need some more resources, or you want to decrease the resources. Amazon offers Amazon CloudWatch as a monitoring service. Amazon CloudWatch is a monitoring service for Amazon's own services. Though there are multiple things in addition to Amazon's own services, but the major purpose why Amazon CloudWatch was launched was monitoring of the Amazon's own service. In this session, we would talk about the Amazon CloudWatch and how it would be helping for you. So when you talk about the CloudWatch, CloudWatch has numerous examples or numerous advantages. The most important advantage you can think of is it is used for the monitoring service. So you can monitor Amazon resources in the real time. Now you mean real time means whatever the data is happening within a minute or 5 minutes you get the updates. You get the updates in a graphical way, so it's easier for you to understand. You can get the data in the various metrics and trends. So you can get trends, what is happening over the period of time. For example, if you see, let me draw this way. There is a graph something like this, which tells you that at certain period of time, like 9 a.m., your load increases. At 12 p.m., your load is much higher, and then post 5 p.m., the load started decreasing. That is the case. Unless you see graphs, unless you see the data, you would not know what is happening. And the advantage is you can get up to minutes of the statistic with that. And what is the use of any monitoring service if it cannot alarm you? And that's why Amazon CloudWatch has an amazing service called Alarms, which can send you notifications. It can send notifications over email. In if you're in the United States, it can send over the SMS, and there are some other ways also where you can get the notifications. It's also integrated with the various Amazon services like Amazon Autoscaling, which helps you to scale up and scale down also resources. You get the visibility of your resource utilizations, and the most important, the demand patterns. What is the peak usage? What is the bottom usage time? How is my trend going on? And that helps you to plan or forecast the resource requirements. When you're doing budgeting, costing, everything would be helpful for you. And don't forget, it also helps you for setting billing alarms. Everybody's using Amazon for the cost effectiveness, though that's not the primary use case, but that's one of the important use case. And when you're talking about the pricing, it's a very important if you can set certain billing alarms which would tell you that how my usage is going and if it is going to cross certain limits or not. So that's what the CloudWatch is all about. Recently, I won't say it's a recent, it's a little a few months back, Amazon has started CloudWatch events concept also, which gives you delivery timely stream of the events. If there is some events happening, like there is change in Amazon resources, new instances are launched, new instances are terminated, they would be getting to the events and they would notify you also. And you can set up certain rules that on this event, take this kind of a route, notify something, or there is a service called Amazon Lambda, something you can work on that. So all these things would be working here. So this is what Amazon CloudWatch we are going to learn more and more today. And where can you use CloudWatch? You name the services, and it's very likely CloudWatch is having a monitoring service for them, whether it is Amazon EC2 or EBS, which we have seen till now. But then Apart from that, there is a autoscaling, S3, CloudFront, CloudSearch, DynamoDB, RDS. You might not know quite a few of the names. Route 53, Redshift, and as I said, estimated Amazon charges. That's the one of the key aspects. I want to know what is my billing I can get through CloudWatch. How do you start using CloudWatch? Generally, when you sign up with Amazon, CloudWatch is available for you. In quite a few, or rather, I would say most of the services, it would be giving you data at every 5 minutes. That is known as a basic monitoring. When CloudWatch is giving you data at every 5 minutes, that is known as a basic monitoring. In some cases, it gives you a detailed monitoring case also, which is where it would be giving you data at every 1 minute. And we would be seeing those services in a while. CloudWatch can send notification to autoscaling also, where it can help you to scale up and scale down. And you don't need any additional software. Use whatever is offered by Amazon. You can use that very well. Now, how do you start using it? With the EC2, if you are in EC2, go to Amazon console, launch an EC2 instance, you would be seeing the detailed monitoring part. Yeah, there would be a monitoring tab. Generally, it would be a basic monitoring. It will be a basic monitoring aspect. If you enable the detailed monitoring, then it is a chargeable thing. You can get the instant state. So what is the instant, whether it's in running state, there is some issue with the instance. That also kind of a matrix CloudWatch does provide. And you get everything in a graphical way, you can get it. Yeah, if you want to get the data, you don't want to see only graphs at the Amazon level, but you want to collect the data, you can also do that. Amazon provides the APIs, command line tools, download the data, store it for your repository, and manipulate or present in your own way also. So this is how on the right hand side what you see is the how the CloudWatch graph would look like. When you see, I said there is a tab called monitoring. So this monitoring tab, when you click on that, there would be a few aspects. One is says enable detailed monitoring. This enable detailed monitoring, if you enable this or if you click this and you enable it, it is a chargeable thing. It would be chargeable, and remember that is not part of the free usage tier. So Amazon would cost you, or rather Amazon would charge you. How much? They would charge you $3.5 per instance per month. If you enable that for whole month, it would cost you $3.5 for whole month total. And when you go, if you have not enabled, that is a basic monitoring. Now you would say, what is the difference between basic and detailed? As I mentioned before, basic means it gets you data every 5 minutes, and detailed means it gets you data at every 1 minute. So if you see here the CPU utilization, discrete operations, there are multiple metrics which we are going to see now are available with the CloudWatch just for EC2. For each and every service, there are various kind of the available metrics and you can monitor those. Now, after all this introduction, if I go and tell you what is a CloudWatch, CloudWatch is nothing but a repository of the data which helps you in one of the core part of the scalable Amazon services. How? For example, if you have set up CloudWatch with your EC2 instance, now the CloudWatch when it is set up, it would keep on generating various logs. Along with CloudWatch, you can set up alarms. When you can set up alarms, that alarms would notify you or notify Amazon services whenever there is a breach in the threshold. So if it crosses certain above level or certain below level, it can notify Amazon auto scaling. And you can configure auto scaling that whenever it receives the alarm, it can scale up or scale down. So this is the concept where CloudWatch plays a key aspect with the auto scaling. It would be very important that the CloudWatch generating the events or generating the thresholds and notifications, sending auto scaling would result in some scale up or scale down, as I mentioned a while back.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee. and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
CloudWatch is nothing but the repository of the data. It's just a collection of the data, where data is collected in certain format at Amazon CloudWatch. Now, when data is collected, that would be in a format, say, it would be if you say a metric would have some name, namespace, a timestamp, a unit, a value, quite a few parameters a metric would have, that would be stored inside CloudWatch. So if you see, it's just a database of the monitoring data. But that's not only for Amazon. It definitely, the prima function of the CloudWatch was to monitor the Amazon resources. But it does support your custom data monitoring too. You can monitor the custom resources. Like if you have a desktop and you want to monitor the resource of that, you can do that. You can send the monitors, or rather you can send the metrics to CloudWatch. CloudWatch provides APIs, command line tools, which allows you to upload your own data to CloudWatch. I'm sure everybody would say, why would I upload my own data to CloudWatch? Does it give me any advantage? It does. Because with the CloudWatch, it has CloudWatch alarm. The CloudWatch alarm can be sent that whenever metric, suppose I'm drawing a graph that my usage is something like this, and I can say whenever it crosses the above threshold, or this is my below threshold, whenever it crosses the above threshold for some time, it would generate an alarm. So I can configure an alarm that's saying whenever CPU utilization is above 70%, take certain action. Or whenever CPU utilization is below 10%, take certain action. So this way, CloudWatch alarm plays a key aspect. And we all believe that there is no use of a monitoring service unless it gives you alarm, because it's not possible to keep on monitoring 24 by 7. If you get the alarms, that would be more actionable item for you. CloudWatch goes one step beyond. It takes actions on behalf of you also. You can configure the actions. So it can allow to take three kind of actions. First action is Amazon Simple Notification Service. Now, Simple Notification Service comprises of the four major blocks, where it can send a notification over email, it can send notification over some HTTP URL, it can send notification to some SMS over through. But remember, SMS is only available for US as of now. Also, there is a SNS where you can send to your custom, like the mobile notifications you want to send, you can do that also. So it does support the mobile notification also. So email, HTTP URL, SMS, and the mobile notification. SNS, Simple Notification Service, is a service which sends notification over four channels. So whenever, for example, CPU usage goes above 70%, CloudWatch would notify SNS saying there is an increase in the CPU utilization. SNS would say, okay, I have an action configured here which says that whenever you get this kind of an alarm, send an email to Intellipaat. It would immediately send an email. It can also do that. I have also configured email that whenever there is some event, you notify over HTTP URL. Now you would say, what would the HTTP URL help me? Suppose you have created a automated report tracking tool which is hosted on some website where there is a HTTP URL. You can hit it there. It will automatically create a ticket for you. It's just an example. If you are in USA, you can get an SMS also. So CloudWatch would help you get real-time notifications. Apart from that, the second service which it sends notification is, or it can send, is auto scaling. The auto scaling service we spoke in the previous slide allows you to scale up or scale down. So auto scaling would be scaling up or scaling down and help you. Then third service is Amazon. If it's for EC2 only, it helps you to take EC2 action, like due to certain reason you want to stop an instance, you want to start or terminate an instance, or you want to restart an instance. Now just imagine a case. You have set up a web server. Now there is a web server which is running on your EC2 machine. Due to heap memory or certain issue, the web server becomes unresponsive. It has stopped. It might have crashed. Right? Now your EC2 machine is running fine, but your web server has stopped. If you have set up certain kind of a your custom parameter or certain kind of a monitoring which says that your web server has stopped, what you can do is you can notify the CloudWatch would then notify your EC2 instance and say reboot. It would reboot, and if you have set up the bootstrapping for your instance for your web server, it would automatically restart the server and would solve your problem. In some cases, you think there is a long running process which can run 8 hours, 10 hours, 15 hours, 3 days, 5 days, something like that. Take an example, some batch processing, Hadoop something. And you want to say, whenever batch process completes, it would be copying data automatically to some centralized folder or some database. But after that, I don't want the instance to continue running. Reason, it would be costing me. There is a better option available for you. Why don't you stop the instance or terminate the instance? So you can set up that for this kind of a EC2 instance, whenever CPU usage falls below 1% for 1 hour, 2 hour, you can say take an action and terminate or stop the instance. So CloudWatch can take action on behalf of you also. What are the action? SNS email notification, auto scaling, and EC2 instances action. We would be seeing in the demo most of the actions as now. What are the services CloudWatch supports? When you talk about the basic monitoring, which is every 5 minutes, it has a EC2, auto scaling, elastic block storage, DynamoDB, elastic MapReduce, Amazon machine learning, simple notification service, simple queue service, and a few more. There are quite a few services which it supports every minute of the monitoring. Out of this, only EC2 and auto scaling, when auto scaling running for the EC2, when they have detailed monitoring enabled, it's a chargeable. But apart from that, everything is free of cost. It doesn't cost you extra. Now, when you want to see the default metrics for CloudWatch, there are various kind of a metrics available with the CloudWatch. If you see, there is EC2 instance. EC2 instance would have a lots of metrics like CPU utilization, disk read byte, disk read operations, disk write bytes, disk write operations, network I/O, and many more. CPU credit usage, CPU credit balance. Those are the available when you have a T2 family, which gives you CPU credit. When you see all these parameters are available, and quite a few are available at every 1 minute also. A few parameters which would be interest for us is status check field. When you launch an instance, if you remember in the EC2 I mentioned, we have to wait till the instance state is 2 by 2 status check pass. Unless that is 2 by 2 status check pass, it's not used for us. And why it was the case? Because this 2 by 2 are one is status check failed and one is status check failed system. These are the two checks an instance has to pass before it is available to you. Now, why do you need those chains? These checks are required because it's a virtual machine available on the cloud, available over the internet. So Amazon does a checks on behalf of you, like whether instance is launched correctly, does it have a network connectivity, does that system has a power capability, if it does not have any software issue or any hardware issue. So anything at a hardware level or firmware level issue, they are check at an instance level. Then anything at the operating system level, like failed system status check or misconfigured networking or startup configuration, memory issue, corrupted file system, incompatible kernel, all these issues would be checked by the system status check system command. If these two pass, that means there is no issue in the system and system is running perfectly or instance is running perfectly fine for you. So it is important that when you see the status check, if it's a 2 by 2 means both the stakes are passed and the system is available for you to run. At the same time, when you see elastic block storage gives you the parameters for the read operations, write operations, read time, and so many. So when you see the IOPS, it would be for the operations or the for optimize total read time. So you get all these attributes which would help you to understand what are the metrics important for you. If you are interested to read more about the metrics, these are the URLs available. You can go through and it would list down each and every metric. Now I keep on talking about the metric. A metric is the fundamental concept in the CloudWatch that represents a time order set of data points. That means a data at certain point of time. For example, current time is 10 a.m. So at 10 a.m., what was the temperature? That's a 30 degree. That is your metric. So what metric would have it would have a name. What is name? Here you can think that temperature is the metric name. Then namespace would be whether it's a combined under the some environment variable or something. It's a group of the variables. It would have a one or more dimensions, timestamp, and unit of measures. Now, what are these all aspects about? When you talk about this, a namespace is nothing but a container for the matrix where a multiple metrics combine and make a one unit. So, for example, a EC2 instance. The EC2 instance has a multiple metrics. It would have a for CPU usage, it is a disk read, or it would have a CPU carried, kind of a various metrics available. All these metrics are combined under one namespace, that is AWS slash EC2. Same way, autoscaling would have a different metrics. They are combined under AWS slash autoscaling. So namespace is nothing but a bucket or a container for all the metrics. When you go to the dimension is nothing but a name value pair that help you to identify a metric. For example, in EC2 you would have a autoscaling group, image ID, instance ID. Now what does that mean? If you take an example, you have a EC2 instance. That each EC2 instance would have some instance ID that is launched from some image. It would have some image ID. It has an instance of size micro, small, large. It would have an instance type. It might have some volume attached to that, so it would have a volume ID. So these are the attributes of an EC2 instance, and that each would have some value associated with that. Now you would think, why do I need this? Sometimes you can group based on that. For example, you want to see how are my all micro instance doing. So you can group based on the instance type. Correct? Or how are my instance which are launched from this my own AMI doing? You can get it from here. The dimensions are nothing but a way to identify a metric, a different or unique way to identify the metric. Each metric would have a timestamp also. That is the most important. That would be in a microseconds or whatever way, and the timestamp would be in a UTC format always. UTC, that's what the Amazon supports, the time zone format. Each unit would have a, or each metric would have a unit also. That unit you can think of it like a byte or seconds or the percentage or kind of a unit it would have. Like. Each metric is always specific to a region because all service would be specific to region, so it would be part of that region only. Some of the sample namespace I have listed here, they are for Elastic Block Store, it would be like EBS. For Elastic Compute Cloud, it would be like EC2, or SNS, it would be like SNS, something like that. That's the namespace. And each would have a multiple metrics as part of that. And each metric would have a dimensions as part of this. So dimension, as I just mentioned, it's a name value pair, which helps you to uniquely identify an instance. Timestamp is also a very important aspect for you. Timestamp is ranging, it would be where it would be up to 2 weeks in the past. It is very important to understand that the timestamp is always measured in UTC format, so it can convert to your own format. But Amazon CloudWatch keeps the data of the last 2 weeks only. At any point of time, there would be data of the last 2 weeks only. There would not be any data beyond that. But you say, oh, I want to capture the data of the data before 2 weeks. How would I do that? Then you have to download the data on your own and you have to save that. You have to download the data on your own and save it. Amazon does not provision any option to save the data. You download it and you store in your own database. We talk about the Unix. There are the various samples which are the Unix, like you can have a seconds, bytes, bits, percentage count, bytes per second, bits per second count, or second none. So there are the various kind of units you can have that. So when you talk about the metric, as I said, has a multiple things. It would have a name, which defines the name of the metric, like it's a CPU utilization, it's a read operations, write operations. What is it that? Then it would also have on top of that a namespace which uniquely identifies helps you to group the metrics. Then it would have a dimension, which are the attributes of a metric. It is having unit, it is having a timestamp also. Also, CloudWatch provides the various kind of a data aggregation methods. That is the statistics, where it gives you statistics like a minimum. So over this period of a 1 week, 2 week, what is the minimum value? So it would show the sample values of the minimum. It would show the maximum values during that period. When you see sum, it would say all values submitted and the matching metric added together. When you try to get the average, it would say what was the value of sum or sample count during that part. When you say sample count, it would find out the sample during the each period and give you. So Amazon CloudWatch also helps you to get the various. It does have a periods also. The period can be as short as a 1 minute and as long as a 2 weeks, because it goes up to the last 2 weeks in the back. You would have a start time and end time also. You can specify to determine what period data you. Alarms, the best thing that happened to the CloudWatch. Because it helps you to make decisions and take an immediate actions. Alarms can automatically initiate the actions on your behalf, and based on the specified parameters, it can work for you. It can take an action to SNS, as I said, email, or if you want to take the EC2 action, or even it can take the auto scaling actions, kind of a various actions it can take. Each Amazon is specific to a region. Rather, each Amazon CloudWatch metric is specific to a region, and one region data is not available in a separate region. Because the service belong to that region, the data of the CloudWatch also belong to that. CloudWatch does support the custom matrix. The custom matrix helps you measure or monitor the data for your own case. So, for example, you have some example where you want to take the case of your own Linux operating system. How is that doing? What is the device space, or what is the disk space available? What is the disk space used? Those kind of a matrix you can see here. The CloudWatch does support that. What you have to do is, if you are using a Windows, you just need to run certain PowerShell scripts. And if you are running a Linux, you run some Perl scripts, which would help you to generate the matrix and send it to the pricing. CloudWatch basic monitoring is free of the cost. It doesn't cost you. Plus, if you're part of the free usage tier, you get up to 10 metrics, 10 alarms at free of the cost with the CloudWatch. But remember, detailed monitoring is not part of free usage tier. It would be chargeable to you. So don't forget that digital monitoring would cost you. So that's it for the Amazon CloudWatch theory. I hope you all enjoyed this. Bye bye.
So OpsWork is a configuration management tool that basically involves a DevOps tool called Chef for continuous deployment. So as I said, it is a configuration management service that helps you configure and operate applications of all shapes and sizes using Chef. These are the key features. It supports any application. The whole configuration becomes code due to Chef. Automation to run at scale and resource organization. So there are few terminologies used in AWS OpsWorks. The first is stack. Now the stack is a cluster of EC2 and RDS instances. Okay, and a layer is a blueprint added to it, which basically defines like what type of EC2 instance is going to be that. Is it going to be a web server, application server, or a database server? So those kind of configuration details are mentioned in the layer. So layers give you the complete control over which package are installed, how they are configured, and how applications are deployed. Now, recipes and cookbooks are something which we study in detail when we actually take up the topic on chef, because recipes and cookbooks is something which is denoted by chef only. So let me show you the practical demonstration for AWS OpsWork. So for AWS OpsWorks, let me check if there is a video that is available. You can check, like the one we had for Elastic Beanstalk. I think there is a video. So we can get that video here. So many times people ask, what is the difference between CloudFormation and OpsWorks and Elastic Beanstalk? So the first major difference is OpsWork does not work alone. It works in collaboration with Chef, which is a DevOps tool, and it has cookbooks and recipes to deploy the configuration. So here is the video, that it's a 3 minutes video. Whenever you get time, just go through this video. That is introduction to AWS OpsWorks stacks. And first thing first, we have to create a stack. So right now, do we have a stack? Let me check. So first of all, we are going to add a stack with Chef 11 because that has built-in cookbooks and recipes. So I'm going to name it as Intellipaat first, and rest everything will be same. And I say add a stack. So the stack is being added right now. Now the next step is to add a layer. So how do we add a layer? We click here, and here I'm going to add a PHP server. So I would say PHP app server because the code, my application that I want to deploy is written in PHP. I do not want to attach an Elastic Load Balancer as of now. And I say add the layer. So the layer has been added. And to the layer, I'm going to add one EC2 instance. So I'm going to add t2.micro, which is free tier eligible. And I say add an instance. Now on this instance, I'm going to start it. And on this instance, my PHP application is going to be hosted. So it is starting the instance right now. So as I said, it is explaining the difference between OpsWorks and CloudFormation. So CloudFormation is used for spinning up the AWS resources. However, OpsWorks is something which is used for deploying the third-party applications, which can be written in Go, AngularJS, Node.js, Ruby, Python. All right. So the same difference is between OpsWorks and Elastic Beanstalk as well. Like Elastic Beanstalk does not involve any chef configuration. So the instance, the EC2 instance is getting started right now. Okay, so it is online. The instance is online. The next thing is to add an application, the PHP application that we were talking about. So I'm going to give it a name, Intellipaat first. And my application is stored on Git repository. So I'm going to provide the URL for Git. It's right here. So here we go with the URL. We say add an application. So the application has been added. Now the next thing is to deploy the application. So we are going to deploy it on the EC2 instance that we just created, and it is being deployed right now. Okay, so this has been successful, and all we have to do is go to PHP app server, and basically we need to go into instances, and this is the IP address. So it says your PHP application is now running in your own dedicated environment in the AWS cloud, and this host is running PHP version 5.3.29. So in CloudFront, we will learn about edge locations. We will see the hands-on practical for CloudFront. And so CloudFront works on the concept of edge location. And there are around 54 edge locations across the globe. So what is an edge location? Our edge location is the third-party data center that is not directly owned by Amazon, but Amazon has done tie-up with certain vendors such as Reliance, Tata, etc. So the whole purpose behind edge location is to expedite the complete process and decrease the latency. So let us say I'm sitting in India, New Delhi, and I want to access a website that is hosted in United States. So the content of the website will first be delivered to one of the availability zone here in India, which can be in Mumbai. And from Mumbai, it will be transferred to one of the edge location in New Delhi. And it will be stored there permanently as a cookie or as a cache. And then the page will be delivered on my laptop or my desktop. Now, the second time I ask for the same page, the request would not go to United States server. It will directly search for one of the edge locations in New Delhi. And if it finds the content there, it will pick it up from there and deliver it on my computer, right? So CloudFront is a global content delivery network service. It caches the static objects. So that is what I told. Charges are pay as you go. And in Asia, there are around 13 edge locations right now. And what it does is it puts the objects in S3, and then it creates the distribution. So what do we mean by creating the distribution? It transports the content to the 54 edge locations across the globe, and it issues a link to the object. So one can access the objects using a link or a hyperlink. So that is something which we are going to look into right now. So this is the basic diagram of CloudFront. So there are developers store the object in S3 or HTTP server, and then a function is triggered to call Amazon CloudFront. And what CloudFront does is it distributes the content across all the edge locations. So on the right hand side, you see a diagram wherein a user is sitting on the computer. It is asking for the website, and the request goes to edge location. If it doesn't find an edge location, it goes to the S3 bucket or the HTTP server where exactly it is hosted. And then from there, the request is retrieved onto the edge location and finally onto the end computer. Basically what happens in S3 bucket, we can store a lot of variety of objects like HTML, CSS, JavaScript, images, and then CloudFront fetches the information from S3 and then distributes it across the edge locations. So here we go with aws.amazon.com and sign into the console. So let me sign in with the credentials. And here we type CloudFront. So straight away it asked me to create a distribution. So there are two types of distribution. One is web and other is RTMP. RTMP stands for real-time messaging protocol. So the difference between web and RTMP is that in web, the content will be stored both in Amazon S3 or it can be on an HTTP server. But here in RTMP, it can only be on Amazon S3 bucket. It cannot be a EC2 server or HTTP server. Or okay, so that is the difference. So we will go ahead with web option, and here it gives me the S3 buckets that we had created. So let us go with Intellipaat training S3. So let us check first what all objects are there inside the 3 bucket. So this is the bucket, and we have all type of objects, cf1.png, cf2, tp1. So all these are there. Okay, so origin path I will keep blank. It is for the specific file that I want to access over an S3 bucket. And restrict bucket access, I will keep it to no. And I don't have any header name and values as of now. And protocol policy, I will go with HTTP and HTTPS both. And I can choose this option, that is get head options put post. So these are basically functions which will be triggered whenever somebody tries to access my S3 bucket. And here we can customize the object caching. The minimum time to live is 0 seconds and maximum time to live is 3,15,000. 31,53,000. No, it's more than that. So these many seconds are there in a year, right? So default time to live is 86,400 seconds, which are there in a day, 24 hours. So if we multiply 86400 by 365, so it comes out to be 3 crore 15,36,000 seconds, which is in a year. So these many seconds are there in a year. So maximum time to live is 1 year, and rest of the options will be kept default, and distribution state I will keep enabled and hit create distribution. So it is creating the distribution right now. It will take exactly 15 minutes, 15 minutes to create the distribution. So these are the number of edge locations that we have in different regions across the world. So if we talk about Asia, we have the edge location in Chennai. Then we have the edge location in, now as per the recent report, the edge location is there in Pune and Delhi, New Delhi as well. So 3 edge locations. Now, these are the different features of AWS CloudFront. Like we have caching, fast and simple, easy to use. Then we can download the distribution. It supports HTTP and HTTPS request. It is elastic in nature because it is configured with S3, and we can have the real-time streaming with RTMP. It supports cookies. It integrates with other AWS services, and it is secure with private content. Okay. So it supports the query strings, as in some queries which are written in SQL, even those are supported. The one that we saw, get, head, push, post. So those kind of strings are very well supported with CloudFront. First of all, we have a user, and let us say he is sitting on the internet. So this is internet, and trying to access a website that is hosted on the AWS cloud. So this website is hosted on the AWS cloud, and there are two servers. One is the primary server, and the second one is the secondary server. Now there can be one elastic load balancer in between, which is distributing the traffic towards the primary server and the secondary server. Okay. Now, let us say he's trying to access a website. All right. That is www.eduism, because that's the domain name I have purchased from GoDaddy, eduism.co. All right. So the request can come to the primary server, or it can come to the elastic load balancer, and then elastic load balancer will route the traffic between the primary server and the secondary server. The brief architecture. This is the brief architecture, how things work. Eduism.co top level domain name server. It checks into the authoritative domain server. It also checks into the example.com authoritative DNS server. Fetched. So the route 53 comes from the name, because this route 53 service works on the port number 53. That is the port number for DNS. Okay, so that is one thing. So this is once again a cycle. A user is sitting on the computer, and he's looking for a website, www.example.com. The request comes to domain name server, and domain name server, if it has the records, it will forward it. If it does not have, it will say, I don't know. And I will ask the authority server. So authority server is when the request goes to route 53, and route 53 reverts back with the IP address of the example website, route the users to infrastructure outside of AWS. So that is something which we are going to see right now. It is fast, easy to use, and cost effective. It answers the DNS queries with low latency by using a global network of DNS servers. And if you need a domain name, we can find an available name and register it using Route 53. So these are some key takeaway points. Now, it is reliable, fast, integrated with AWS, easy to use, cost effective, and flexible. It is reliable because it works on the concept of edge locations. So there are 54 edge locations supported by AWS, and it can be managed using command line interface as well. It is quite cheap, and it follows the round robin scheduling. So if the request is coming onto the elastic load balancer, it has the capability of following the round robin scheduling to distribute the traffic among the various servers. We can run application in multiple AWS regions and route users to the one. So in case of failover, okay, let us say that this server stopped working, and this entire infrastructure is in Mumbai region, okay, and we can fail over to a server that is in Singapore region using route 53. So any request that is coming to the primary server will be rerouted to the failover server in the Singapore region. So that is what I'm going to perform the practical demonstration. So you can see that, okay? So that is one thing. And it follows the concept of hosted zones and record sets. So what exactly is the hosted zone? So let me show you right now. Now we have a website called mail.google.com. Then we have something called as contacts.google.com, and we have drive.google.com, and we have photos google.com. So these are basically the record set for a single hosted zone, that is google.com. So hosted zone here is google.com. This is the hosted zone.
In this, we are going to learn about the AWS SES or Amazon Simple Email Service. Till now, we have learned the various services and covered about the Amazon CloudFront and Amazon Import Export with the Snowball. Amazon Simple Email Service. You would see what is Simple Email Service, where this is used, what are the key features of the Simple Email Service, and we will see a demo of Simple Email Service too. Amazon SES is a cost-effective, scalable email service. It is useful to send bulk emails. Remember, this is not your replacement of your Gmail or Outlook mail. No. But if you want to send a bulk mail, transactional mails, huge number of mails, this is the ideal solution for you.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
A few months back, Amazon SES also started a service called Receive Email. Initially, it was only for sending email, where the mails would be received, delivered to your AWS S3 bucket. But the major purpose is it's used for the sending email. Important aspect is it supports pay-as-you-go model, very cheaper. Free tier gives you almost 50-60,000 plus emails in a month, free of cost for up to a year, and then over again also it would be charging you 6 cents per around 1000 emails. So that's a very cost effective and cheaper service. It's a highly reliable and very scalable. Simple email service, easy to use and very scalable. Important is it gives you a feedback loop mechanism also. So whenever a mail is bounced due to any reason, over quota or due to the wrong email ID, it gives you back. And it also keeps track of that how many mails from your end are bouncing. And with this feedback loop, you can always increase your delivery rate. It does work with the Amazon other email services or other services. It can integrate with them. And it is a very easy to use interface. We will see that also in a demo. Where it would be useful. When you want to send for bulk and transactional emails, it's a perfect support. It does support the SMTP also. So you can use the SMTP to send the emails using Amazon SES. It does support the receiving emails also and deliver them to the S3 bucket. But do not use as a junk email, as AWS may stop your access. Remember, that's a very important point. If you try to misuse the SES as a junk email for sending junk or hacking or some other purpose, Amazon would stop your access, because Amazon keeps giving you feedback, what your success rate, everything, and it also keeps track of that. If it finds there is a huge number of bounds and your production access may be stopped for SES, it would not allow you to send more emails. It's very important you use it wisely. It's a very cheaper email service for delivery, cost effective. And those emails are bound to fail. We know that emails may bounce. So it doesn't mean that if one or two mails fails, Amazon would stop your production access. No. But it evaluates you. It continuously keeps checking what is your bounce percentage. If you send 1000 mails and 10 mails bounce, that's okay. But if you send 1000 mails and 600 mails bounce, there is a serious problem. If there are a huge number of complaints received from your email, or the quality of email is not good, it keeps checking how much bounce percentage, how much complaints, how much overquota, something like that, and it thinks, okay, there is something wrong. SES takes those parameters very seriously, and it can reduce your production access. But if your bounce percentage and the quality of email is good, it's within a measure, that measure is defined by Amazon, SES is very cost effective and service for sending email for you. How would you use SES? When you sign up with the SES, SES is having a two modes. First is you have to sign up with a simple email service. Initially you would be using beta access. During the beta access, whatever email you want to send from, so if you want to send from my email ID, learnawsonline@gmail.com something, and you have to first verify those emails before you can send from that ID. Even if you're sending a mail to abc@abc.com, you have to still verify that email ID. Otherwise, it would not support. You have to send to approved emails only. So abc@abc.com has to approve you. Then once it is done, you can request a production access. Once that production access is approved, Amazon would allow sending around, if I remember, 24,000 to 50,000 emails in a day, or little more, much more. But everything keeps increasing gradually based on the mail quality you are sending. And then you can send email to all. It will keep checking the feedback. So in the production access, you do not need to get approval of each and every email addresses. You can send to all, but yeah, in that case, the feedback would come in a picture. It would keep checking whether person is having a lots of bounds, complaints, and if there is so much complaint, the production access would be banned. Sometimes it may happen that the people, suppose you are sending an email from abc@gmail.com. Now, the mail would be from this person, the SMTP and the from would be something from Amazon SES. In this case, quite a few mail clients would consider that this is a spam mail and they would immediately move that to a spam. So that's not the right way. How can you overcome this? You have to use domain key identified mail service. This is this is a standard that allows senders to sign their email message. So when those email messages are signed, they know this is an authorized email, this is not a junk. It might be used from a program, but it's an authorized. Then it's considered as a legitimate mail and it would be delivered to your inbox only. It would not go to the some other box. This DKIM signing helps you delivery of email message. ISP can verify this. This DKIM also you can configure using ACS console or using the REST APIs. What are the typical use case of the simple email service? You can use for the transaction emails, bulk emails, system emails, gaming, social networking, blogging, subscription emails, business emails, and many more. Just in a case, the people who are using Candy Crush, they might be sending a receive request to their friends, though it might be through Facebook, but there might be a way you can invite through emails, or there would be a way you want to share your score with your friends. Simple email would be a easier service for you in this case, where you are a game programmer, you want to send those transactionals or gaming or the bulk social networking mails. This is a perfect solution for you. Let's see a demo of the simple email service. I'm going to simple email service. Currently there is nothing available. So either you can, if you are owning your own domain like intellipaat.com, you can verify your domains, or I'll start with the email address. I'll say verify a new email address. So verify this email address. It has sent an email to this learn AWS. The verification is pending from this user. If I open my inbox, it would show there is an email from Amazon Web Services. It says, do you authorize this person? I say yes. Once it is authorized, it is authorized. Now I can use this console. It's a verified. I can use a send a test email. Remember, I am still in a production access. Sorry, I am still in a beta access. I need another email ID. So if I say abc@gmail.com, just an example. If I try to say send, it would not. The abc@gmail.com is not verified yet. I need to verify that email ID. Else I have to send an email to only authorized email ID. So it would send the mail to them. You would see that there is a mail from me only. The sender is me and it has sent me, hello, how are you? If I go and try to see the headers, you would see the received from a8smtp amazon ses.com by Google to learn AWS online.com. So mail is received from this, and in those cases, if it's not authorized, it's likely that it would be marking them as a junk. Or so that's why it's important how you deal with that. Now, if I go back to my console, this is how you send an email. If you don't want, you can always remove this ID. You can get your sending statistics with CloudWatch, how many mails you delivered, how much it worked. You can make your SMTP settings also. If you want to use it programmatically and you want to use it you want to do it using SMTP, you can do that. This would be your SMTP server name. This would be port. You can use that. If there is a Amazon creates its own separation list, like if there are the mails bounced across the globe from various people, you can use that also. Those would be automatically, if you're sending the people using SES to those same people, it would be removed automatically. You can remove those suppression list also here. If you have enabled the domains, then after enabling domains, you can also enable the DKIM setting. That also you can do that. So this is all about this. Now you would say, how do I enable my production access? So to enable your production access, you have to go and request over Amazon support. Over Amazon support, you have to go and request. So if I go to support center, and here you have to request for the SES production access. I have to create a case. Remember, this is where you have to request for service limit and Amazon. Here you have to accept request for that. Okay, for US East, I want what are my times of mails, what I'm going to do, all that you will be able to request here. You have to request over support. Now remember, the support service is free of cost because you have selected basic support plan. Amazon offers various different kinds of support plans. Ideally, with a free user tier, it would be good. We can increase the limits with that also. So this is about the Amazon SES, a powerful and scalable and easy to use tool for sending an email.
So these are some key terminologies. What is EBS? What is EBS volume and EBS snapshot? So EBS is the block level storage. It is just like the solid state drive, and it is really fast. So EBS volume is the EBS. It can be a general purpose SSD or provisioned IOPS or magnetic volume that can be attached to an EC2 instance. And a snapshot is a point in time backup of volume used to instantiate multiple new volumes. And we can expand the size of a volume or move the volumes across the availability zones, regions, as well as the various other accounts as well. So snapshots can be transferred from one AWS account to another AWS account, from one region to another region within the AWS account, and from one availability zone to another availability zone. That is how it contributes to high availability EBS snapshot. So the one condition is that the EBS volume which is going to be attached to a EC2 instance has to be in the same availability zone. Let us say we have this EC2 instance in 1A. The EBS volume that I'm going to attach to it has to be created in 1A only. It does not work like cross availability zones. It does not work. So right now the server is ready. So let us run the command lsblk to figure out how much space we have got. So it is saying only one volume is attached right now, that is XVDA, which has got two components, XVDA1 and XVDA2. And it is overall 10 GB in size. We can also see the volume through df minus a. So it also says 10 GB volume is there. This is the volume, the boot volume that was created along with the instance A, 10 GB. And we can create a new volume. So we are going with general purpose SSD. If we go with provisioned IOPS, it's going to cost us extra. That is chargeable. So as cold HTTP and throughput optimized. Magnetic is free, but it's very slow. So that's the reason I will go with general purpose SSD. And size I'm gonna take is 10 GB. Maximum I can take 16 TB. And the IOPS, that is input output operations per second, is going to be 300, and the maximum is 3000. So since we have taken 10 GB, the IOPS has changed to 100. If we take 30 GB, let us keep it to 10 GB as of now. and the availability zone is going to be 1A, and I want to encrypt this volume. So I want to encrypt it with a default AWS EBS key and sign into the console. So I will have to go in IAM, Identity and Access Management, and check out the option encryption keys. So right now the key that we are using is AWS EBS. I can create my own key. So I can create it by the name EBS, and I will keep the same description. And I want to have a KMS, that is key management service. I would not go for external, and I will hit next. So this is the key that has been written in JSON format, is ready right now. So this key has been created in North Virginia. So that means I should be able to use it here. So I want to go with 10 GB. It will change to 100 IOPS. And I will make sure that I'm creating the volume in the same availability zone, that is 1A. And I can encrypt this volume using either default ABS, or I can use EBS as well, the one that I just created right now, and hit create. So I will give it a name as extra volume. It is available right now, and I can go in actions and attach this volume. The moment I click on instance, it's automatically going to show instance A in North Virginia. And the device it is going to allocate is /dev/sdf, and I say attach. So now if I go back to the console and run the command, so let me run the command. So now if I run the command lsblk, I can see that XVDA is there with 10 GB, and XVDF, the new volume that we just now added, is there 10 GB. Now if I run the command df-h, only 10 GB volume is there, that is XVDA. It is not showing up XVDF. The reason is it is not mounted and it is not formatted as well. So first of all, we will have to mount it, as well as we will have to format it in order to replicate the changes. So first of all, we will format this, and the command that we are going to use is sudo mkfs -t ext4/dev/ the name of the volume that we have attached, that is XVDF. It has been formatted. Now the next step is to mount it. So in order to mount it, I will first create a directory, new, and now I will mount it on the new directory. So I'm going to mount this newly created volume on new directory. So it has been done. Now if I run the command df-h, it is very well showing here. So two components are there, XVDA and XVDF. So it's very well showing here. And I can cd into the new directory and create some empty files, sudo touch 1, 2, 3, 4, 5. So I'm going to create 5 empty files, and if I run ls-lia, all the 5 files are listed, 1, 2, 3, 4, 5. So on this new volume, 10 GB volume, extra volume, xvdf that I created, I have added 5 empty files to it just for the demonstration purpose. Now let us dig deep into EBS volume. So this is the life cycle of EBS volume. We have unused space. We create a volume from 1 GB to 16 terabyte. We attach it to an EC2 instance. Now we can use it. So we are done till here. After that, we can create a snapshot. What is a snapshot? It is point in time backup of the EBS volume, and that snapshot will be uploaded on a Amazon S3. We can attach this snapshot across the AWS account within the multiple regions, as well as we can transfer it from one AWS account to an other AWS account. And from this snapshot, we can create multiple volumes of even bigger size. Let us say that this 10 GB volume, I created a snapshot. Now from that snapshot, I can create even a 20 GB volume that will have all the data of the 10 GB volume as well. So that is what we are going to see right now in the practical demonstration. So this is the architecture of EBS volumes. EBS with the EC2 and S3. So basically what happens, all the EBS snapshots are stored in S3 volume. So basically we can create the snapshots, and from that snapshots, again, the volumes can be created and attached to EC2 instances. And all of this can be managed and accessed via the internet. So these are few features about snapshots. We can create a snapshot of any EBS volume, and these snapshots are stored in Amazon S3. There is a charge attached to snapshot. It is $0.095 per GB of storage. And these are the advantages. We can create new EBS volume from snapshot. We can expand the size. We can create the volume in separate availability zone or region or different AWS account as well. So overall, it helps for disaster recovery and high availability.
In this session, we are going to talk about the Amazon Autoscaling. Amazon Autoscaling is a service which allows to add new EC2 instances based on the conditions defined. Before we move on to autoscaling, we would first try to understand what are the types of the scaling possible in regular world. We would understand what is autoscaling, what are the types of autoscaling, or how do you achieve the autoscaling, and we would go a little deep down about the autoscaling too. Let's see first what are the types of autoscaling in the market. Suppose you have a M3 dot medium instance size and you have a EBS, that's a root volume of 40 GB size to that. Now if you want to increase the capacity because your load is increasing, one way is from M3 dot medium you change the size to M3 dot large. To change the size you have to stop the instance and then change the size, provided this is an EBS back instance. Yes, if you want to change the size from 40 GB to 80 GB, you can also do that. You take a snapshot, you create a new volume of 80 GB, attach as a root volume. But changing the instance size or changing the volume size, in these two cases, it would require instance to be stopped temporarily and then the size would be changed. But that is possible. If you can do it in a off-peak hours or something, you can back up. It's a possible thing. In another case, you want to change size from M3 dot medium to M3 dot extra large again by stopping server. Yeah, if you don't want to remove the original size of the EBS volume, you can attach additional EBS volumes also. You can rate them, and then you can make them as a 1 EBS volume. All these cases are case for the vertical scaling. In the vertical scaling, you add resource vertically to the your current infrastructure. Whether you add memory, you add compute power, whether you add storage, all the cases are of the vertical scaling. Vertical scaling has some kind of a limitation, because one limitation we just saw, it may require the instance to be brought down. In some cases, there is a threshold. Beyond that, if you keep on adding more resource, it may not improve the performance, because eventually it's a single machine. A single machine has its own limitations, which might not work beyond certain capacity. So when you think about empty dot extra large, empty dot large, in both the cases, this is how it's going to work. Let's think over the another option that is known as a horizontal scaling. The horizontal scaling case, you add more resources horizontally to your fleet. So you have one empty dot medium, you add one another empty dot medium, you add another empty dot medium. All three are managed by the elastic load balancer. So suppose you have a 10 requests coming up. Now even if you have a 300 requests coming, it would be evenly distributed among each machine with the 100 requests. So that's the horizontal scaling for you. Amazon auto scaling helps you achieve horizontal scaling. It adds more resources horizontal to your fleet, and you can also make them part of the ELB automatically, which allows you to scale horizontally. And believe me, the horizontal is the go-to thing for you, because if you want to add more and more from 5 to 10 to 15 resources, that's a possible. Plus, it does not need any downtime, and it doesn't need, or it won't have any capacity threshold like a vertical scaling. You keep on adding, it would work perfectly for you. Auto scaling helps you achieve horizontal scalability for your applications. It's a perfect case for the high availability. It can scale up and scale down EC2 capacity automatically based on the conditions defined. You can manage your desired capacity. Now, what is that? When you make an auto scaling case, it would have three kind of a parameters: minimum size required, maximum size required, and desired capacity. Minimum means it would never go below those many numbers. So suppose at any moment you think I need two EC2 instance running. So at auto scaling level you define that I need two as a minimum. Now due to any conditions it would keep adding more resources because there is a load increase something. What happens if there is a DDoS attack and it keeps adding more and more resource? You don't want to do that. Or there is a known case because you know there is a virus scan going on. It's not a real increase in the load, but my CPU is behaving oddly. What you can do is you can set up the maximum limit also. You can say my maximum limit is 8. So when the load increases, it keeps adding more and more resources. So from 2 to 3 to 4 to 5, it would not go beyond 8. It would stop at 8. So this way you can control. And at any moment, how many instances you want, that is defined by the desired capacity. We would see in the demo how can you scale up, scale down, how can you define the minimum size, maximum size, and the desired capacity. But it's important to understand these are the three parameters: minimum size, maximum size, and the desired capacity. And with this, you can see you can increase or decrease capacity seamlessly. Now that's why this is the perfect case of the cost optimization. You would say, how would it optimize my cost? Imagine if you have 5 instances. Now, for these 5 instances, you might have to, you don't want the 5 instances running all the time. You say at any time keep two running. Whenever required, load increase, add one, two, three more instances over there. If you were in your own data center, you might have a procured capacity as per 5 instances and it would running. Here, you are running only 2 instances. As and when load increases, you add more resources. As and when load decreases, you remove the resources. And beauty of Amazon is you pay for only what you have used. So you would be paying for those 2 3 instances only when they are available, or only when they are being used. That case, you would be paying for those additional 2 to 3 instances for some few hours only. That's why it's a huge cost optimization for you too. Autoscaling helps you to achieve the best of the high availability because it does keep check of the health of the instance, and even if it finds any of the instance unhealthy, it would terminate that and launch a new instance for you. You will read a little bit more about that in the future. Also, if you think, it helps you since it's a scalability. So if one zone goes down, so that instance stops behaving, it would automatically scale up because the CPU load increase, something like that, and it would help you achieve high availability and disaster recovery too. Autoscaling is ideal for hourly, daily, weekly variability. If you have a load, something which is in a spike, something like this, that's not the case. The reason is by the time it spikes up, you are about to spin up a new instance. It has spiked down, it has come down, and it's about to be terminated. Then again it spiked up, it is about to be launched. So you have to find a pattern and baseline something, and then only you should be setting up the auto scaling formulas or events to come across. It works with the ELB and the CloudWatch perfectly. We'll be seeing in the demo how does it help you. And the most important, it does not cost you extra. It's a free of the cost service. So auto scaling is elastic by nature. We know it's elastic. It can add more compute power elastically, and that's why it helps you in the dynamic scaling. You want to add the resource, you want to remove the resource. It helps you for that, and that results in your cost savings because you are paying for the resources which are added only when required. So helps you for high availability. The important point is it works within a region only. So auto scaling is particular to a region. So whatever condition defined would be part of that region only. Whenever load increase, it would keep on adding. Whenever load decrease, it would keep decreasing. It works in that way. Auto scaling, how do you work with that? So there are the few steps you need to follow when you are working with auto scaling. First and foremost step is you create a launch configuration. So when you go to the auto scaling, there are two things you need to work. One is a auto scaling launch configuration. Another is a auto scaling group. Now, what is a launch configuration? You have to think what is the role of a auto scaling. It launches an EC2 instance based on the condition. Now, while launching an EC2 instance, what all parameters do you need? You need instance size, you need key pair, you need AMI because it would be launched from that. You need security group, you need EBS volume, and a few parameters which are required to launch an EC2 instance. While launching an EC2 instance, we have followed these steps multiple times. That is the exactly thing you define in a launch configuration. Here you identify the EC2 runtime parameters. That's a very important. The AMI ID is the most important because you want that I have a application set up with the Apache web server. Now I want to do that the whenever there is a load increase, it would add a Apache server over there or new instance over there, which is the Apache server already running part of that. What you can do is you set up an EC2 instance, install Apache over there, configure that the whenever the instance boots up, Apache starts automatically, and create an AMI out of that. Provide that AMI to EC2 launch configuration. So in future, whenever autoscaling launches a new instance, it would launch this also. It would also launch this instance, and where the Apache is already installed, Apache would start automatically, and you make it part of the load balance, it would start running for you as it is. It's very important you identify the runtime parameters, and that would be defined based on your AMI. That's the one key aspect. Apart from the AMI, you would be selecting more parameters like key pairs and the security group and the EBS volume size and a few more. The next step is, and here you are just identifying parameters. The next step is you create an auto scaling group. In the auto scaling group, you would be selecting or taking this launch configuration as part of this, as well as you define maximum size, minimum size, and desired capacity as part of this. You also define which all zones does this. I'm talking about zones of a region, not multiple regions. Zone of a region. Which all zone this autoscaling be part of. So what happens? As soon as you create an autoscaling group, it would launch an EC2 instance. How many instances it would launch? It would be based on the desired capacity. And if you have not specified desired capacity, then what is the minimum capacity you have specified? Based on that, it would launch EC2 instances. Those instances would be launched based on the launch configuration parameters you have selected. It would select the same AMI ID, same key pair, and everything it would take out of that. So your first step was creating a launch configuration. Second step is of creating an autoscaling group. Once all this is done, you can create an autoscaling policy. In the policy, you define that whenever there is a threshold above 60%, below 60% something, or based on time, you launch a new instance. So as soon as CloudWatch detects the condition breach, it would notify autoscaling and it would execute this scaling process. When the scaling process is executed, that also be part of ELB. You have configured that. So everything works seamless for you. Launching a new instance, and even if the vendor it goes below the threshold, it would terminate the instance also. So when you think of the auto scaling process, the important steps are creating a launch configuration, creating an auto scaling group, and creating a policy for that. Auto scaling with the elastic load balancer gives you a perfect resiliency. So what happens? Suppose auto scaling has launched an EC2 instance. Now that instance is also added to the elastic load balancer. Autoscaling itself also performs the health check on the instance. Now we know ELB does perform the health check on the instance. Autoscaling also performs the health check on the instance. In this case, as soon as the instance becomes unhealthy, ELB would stop sending traffic to that instance. ELB would stop sending traffic to that instance. We know that ELB keeps check of the health of the instance. When it's unhealthy, it stops sending traffic. And if it's unhealthy, autoscaling would terminate that instance automatically. And since it's terminated, so your desired capacity has to be maintained. Autoscaling would launch a new instance as per the desired capacity. That instance would be part of the ELB again, and the whole thing starts working back to the normal. So even if due to any zone outage or any other outage at Amazon level, instance goes down, ELB would stop sending traffic to that. Autoscaling would terminate and launch a new instance for you. That would give you the case of the perfect resiliency. Autoscaling works in the three scenarios. Let's see what are the possible cases in this three scenario for the autoscaling. First is a based on the time. Scaling based on the time. You can create a schedule action. Suppose when you are doing your load monitoring with the CloudWatch, you feel at every day 9 a.m. the load increases and every day 5 p.m. the load decreases. What you can do is autoscaling allows you to scale based on the schedule. So you can create a schedule where based on that load it would automatically increase the capacity, based on the schedule it would decrease the capacity also. You can set up the time in Amazon Management Console. You can also set up, it's not a week, one day. You can set up that if it's a recurring, it's a one time, what do you want to set up that? And based on this desired capacity, it would be changing that. So this is scaling based on time. Where you know the pattern and you want to scale up, scale down, you can do that. Second is a dynamic scaling, where you want to scale based on the conditions. You don't know your application is working normally, but suddenly there is a huge hike on the load. Let's at the 9 a.m. the load has increased by the 50% or 60%. At 5 p.m. the load has decreased by the something. It happens. Now, what would you do that? You would be creating a policy for scaling up and scaling down. You can say that, sorry, it's not a time waste, that's my miss. You can set up that, okay, when there is a CPU utilization. So if I say my application is working normally, my normal CPU utilization should be below 60%. Now, due to certain conditions, if the load is increases and it stays there for a longer period, you can set up a policy which would scale up automatically based on these conditions. So you can create a CloudWatch alarm which says that whenever CPU is more than 60%, notify auto scaling. Now, this auto scaling would then take up and launch a new instance as soon as it receives a notification from the CloudWatch. You can also set up a bottom threshold that whenever it's below 20%, again notify auto scaling. So whenever it goes below 20%, it would then also terminate the instance. So you can set up the scale up policy and scale down policy. In the same game, third is the manual scaling or the constantly growing scaling. When you want to follow the certain pattern, how you want to scale up or scale down, you can do that. And this is more about, you know that, okay, this is the time I want to increase the load. You don't want to wait for any conditions, you don't want to wait for any time base, you want to do it manually. This is the case for you. It's very easy. You just go to the CloudWatch, you just go to the auto scaling and change the desired capacity to your required, and it would be based on the desired capacity, it will scale up or scale down. The one of the exact example I would say, due to certain conditions you have set up that okay, it should scale up, but you don't want to set up the scale down policy as of now. So what you've done is, when the load increase something happens, you would be scaling up. Now after some time you think, okay, this is the time now I want to scale down, you can go and manually change the policy. Again, as long as there is a less manual intervention, that is the best policy, but in some cases you might require that. So you can think of that option too. This is a simple architecture of the how the auto scaling things would work. You would have a website, something like example.com, that is being mapped to some IP address of the load ELB, and I would say not IP, it's a DNS, using Route 53 service. With this elastic load balancer would be sending the request to the instances, and there is an auto scaling configured as part of that. When auto scaling is configured part of that, and whenever there is a threshold or some breach of the conditions, it would add more resources to this auto scaling group, and that would be again part of the load balancer. So when the load increase over the example.com, automatically it would be taken care by the using elastic load balancer, auto scaling group, and CloudWatch. It can scale up, scale down based on the policy defined, and it receives the alarm from the CloudWatch. Let's try to understand a few vocabulary of the auto scaling. Auto scaling has a launch configuration. The launch configuration we spoke about, it's a first step to create your auto scaling, where you define what all runtime parameters it should use to launch an instance. This is the EC2 runtime parameters. Then it does have an auto scaling group too. Auto scaling group is nothing but a representation of a multiple EC2 instance. So it uses the launch configuration to launch an instance, but what would be the max size, minimum size, what zone it supports, that all thing you define in the auto scaling group. As soon as the group is created, it launches a new instance. You also have a policy. A policy is that you define that based on the response from the CloudWatch, what action should auto scaling take, whether it should scale up or scale down, that is defined in the policy. A trigger is nothing but the what you receive from the CloudWatch. When a CloudWatch you receive an alarm from there, it would be part of that. It is part of a.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
CloudWatch alarm and auto-scaling policy. So as soon as the alarm crosses the threshold, it notifies auto-scaling. Auto-scaling policy would be executing the thing. That's the whole thing is called as a trigger. And auto-scaling keeps checking the health of the instance regularly. It does perform the health check and keep the check of the status of the health. So as soon as it finds any instance unhealthy, it would terminate that and launches a new instance on place of that. What are the use case for the auto-scaling? It's ideal for the web tiers or stateless tiers. So you should use it for the Apache, Nginx, Tomcat, JBoss, wherever you have a web service tiers, it is required for that. Can you use it for the load database? You cannot. We'll see in a moment. So ideally, when you have web servers which are facing the external world traffic, or when you have a stateless tiers which does not manage your states, that is the case for the auto scaling. We learned the three types of the scaling: manual scaling, scaling by schedule, and scaling by the policy. It's a recommended that you should have a two policies, one for scaling up and one for scaling down. Let's try to see a little bit of the scaling in depth. The scaling is recommended when you have a gradual rise or the gradual low. If you have a spiky requirement, scaling is not for that. Yeah, there is a spike of the increase, scaling is that. But what I meant is spike up, down, up, down, up, down. That is not the case for the scaling. You can create up to maximum 100 launch configuration as part of the auto scaling. In some case, you want to suspend the scaling. You want to resume because you are doing something new installation. You are doing something over the instance. You know that. So you can suspend or resume the scaling also. You can have a maximum 125 scheduled actions for auto scaling group. So every day it can have allowed 4 actions per day. That's a possible. Also, when auto scaling is terminate the instance, you can define in which way it should terminate. That is the oldest instance first, newest instance first, instance with the oldest launch configuration first, or instance which is closest to instance R, that is for the pricing base first. You can define that also, and we would see that also in our demo. We know that EBS back AMI boots faster than the instant store back. Ideally, word should be instant store back AMIs. And even it's easily to make also. So that's a recommended to use the EBS back AMI as much as possible. Yeah, you cannot modify your existing launch configuration. So in case you have created a new AMI and you want to change the launch configuration, what you have to do is create a new launch configuration and modify the auto scaling group with this new launch configuration. You cannot update existing launch configuration. You can use spot and reserved instance also with the auto scaling. Auto scaling works across the multiple availability zones within a region only. It works seamlessly with or without ELB. In some cases, you might not need ELB because you're doing some Hadoop or batch processing. You can use the auto scaling for that purpose also. Auto scaling checks the health of the EC2 instance regularly. It does perform the health check, and during the health check, if find the status of the EC2 instance okay, then it's a good. If it also performs the health check of the ELB also, if it find the ELB health check in service, then it's a good. If it find it's not running, because what happens, an EC2 instance is registered with the ELB. Now, when it's registered, the status of the EC2 with the ELB would be in service. Due to any reason, if it's out of service, auto scaling would mark that instance unhealthy and terminate that. If an ELB is unhealthy, all instance will be also marked as a unhealthy. Auto scaling does also support its own metrics for the CloudWatch. They are like what is the minimum size, maximum size, desired capacity. Yes, if you have enabled the detailed monitoring with the auto scaling for EC2 instance, that is a chart. Auto scaling should never be used with the database unless it's a read-only data. Why? Imagine a case you have a database. Now, suppose the load rises and you say, I want to spin up new database instance. What would that result? it would result in inconsistency because some data comes to this machine, some data comes to this database. The data is not consistent. You cannot have a two instance. So, and plus auto scaling can terminate this also whenever this load decreases. So your data would be lost. Since it's a persistence tier, auto scaling should never be used with the database. If you have a read-only database, then only you can do that. So what happens that your data is coming only for the reading part. It's not doing any insert, dealing, anything update part over there. Then it's okay because if you have a 3 instance, 5 instance, even if the one terminated, you don't mind because it's a read-only thing. When we go to the RDS, we will see that read-only part too. If you have a critical configuration like log, audit trail, something coming to the EC2 regularly, you should plan keep moving them to the S3 at regular interval. You should also optimize your resources after monitoring pattern. You should keep monitoring your resources regularly, and whenever you find upward downward scale, you should add or remove the resources too. So this is all about the auto scaling in the theory.
Hi, in this we are going to learn about the Amazon economics, and we will also have Amazon billing and account overview. Till now we have learned the various Amazon services. We went the deep down of many services like EC2, EBS, CloudWatch, up to RDS, Route 53. We were covering many services in deep down. We also get a very good overview with the hands-on demo for the DynamoDB, Glacier, CloudFront, import, export, SES, all that we tried to cover here. So the purpose was we all should be prepared and understand why this is helpful. You should understand why these services are useful and how would I use in a practical case. At the same time, when you are preparing for Amazon architecture, it's also important to know how do I optimize the cost, how do I plan for the Amazon, what budget would Amazon need, or what would be our monthly costing. How do I monitor those aspects also? So it's very important to know the other aspect of the, apart from knowing the Amazon services, the other and very important aspect of the Amazon. So for that part, we would be learning about the Amazon economics. After that, learning Amazon economics, we would be going to the Amazon account overview. So I'll going there. I am on our website awsamazon.com/economics. When I'm here, you can see it gives me some overview about the economics, how Amazon can help you optimize the cost, you can save the money, how much, and you would be wondering with the numbers, are this number true? Would I get my return on investment in just 6 months? How would I get more? Gartner has always put the Amazon in the leader quadrant since the beginning. So when we know that in 2015 this was the leaders quadrant. How would we know how much am I going to save this? So for that part, I'm just clicking on the resources section on the left hand side. So when I click on the resources, it gives me a few calculators, and which are very nice to have the calculators. Apart from that, Amazon also gives a good white papers. One of them is how does Amazon pricing works. So you can know and read about this, that how you would be, whatever you're planning, how much Amazon would be charging you. Also, introduction to Amazon economics. These are the very nice white papers. You must follow that or read that. For now, we are going with the AWS total cost of ownership white paper. So when I select this, this is my total cost of ownership white paper. Where this would be useful. So when you are just planning as an organization, you are planning to move to the cloud. You want to move things to the cloud, but you don't know how to do that. You are not sure how would I optimize my cost. You are not sure how am I going to reduce the cost, or whether Amazon is the right solution for me or not in a pricing wise. For that case, you might need to go with the AWS total cost of ownership calculator. So when you go, I'll just click on the launch the total cost of ownership calculator. This would be giving you an overview about if you're hosting something on your on-premise thing and something you are going to host on Amazon, how much you are going to save the cost. That is the concept here. So let me start with the basic. We go with the USD as a amount. Okay, so what are you trying to compare against? I say are you going to use on-premise or are you going to use the co-location? I say I'll be using on-premise. Their whole infrastructure was going to be in my data center. Now instead I'm thinking to move to the Amazon. So what is the cost comparison between that? Where are you going to host? In which region? I would say I'll start with the US East region. Were you planning to use the physical machines or were you planning to use the virtual machines? In that case, I would say I was planning to use the virtual machine because that would give me more resource optimization. But I was planning to use the virtual machines. Okay, so how many things are you going to use? I say I was needing a web servers where I had at least 4 web servers requirement. They were all 4 CPU, 8 GB RAM. I'm just going a rough estimate. For a hypervisor, were you going to use the VMware or open source? I'm saying I would use the VMware. The costing would be different for the VMware because it would be having a license cost also. As I was requiring app servers also, where I required 4 app servers. They all had a 4 CPU but required a more memory, 16 GB RAM they were required. I'm just putting a rough numbers here. Then I needed database servers also, where I would have 2 database servers, one primary, one secondary, but they would be very high configuration. So this is my requirement. Do you need a storage? I say yeah, I need a storage, but I don't think I would be having more than 2 terabytes of storage. That's the okay for me. I'm not going to even use 1 terabyte. So just keeping 2 is a buffer part. I'm okay. And now I say run calculate total cost of ownership. It's a calculating some magic numbers for me. And what it says, over 3 years, over 3 years, you would say almost $200,000. That's the whopping number, $200,000 just saving. You would be great glad. Wow. Let's see how it works. So Amazon, when giving you this estimate, it goes for the 3-year reserved instance part. So that is where you would be saving, because we know with the Amazon, even 3-year reserved instance helps you save almost 40 to 50% of the cost. You would just try to compare the things. So your on-premise server might be costing you $161,000. How this cost come, we would see in a while, because the bottom Amazon has explained everything. Well, Amazon, it would be costing much cheaper. Storage also would be very cheaper for Amazon. Your networking cost, you need to procure a network, which Amazon would not need to. So your total cost is almost this way compared. So from comparing 239 to 42,000, that's how you would be saving almost $197,000. If you go a little deep down about each and every aspect, what Amazon has compared. So when you say I was requiring a 4 VCU and a 8 GB RAM machine, Amazon recommended M4.large for that. For app server, it recommended M4.extra large, and for database, it recommended M4.4x large. So these are the 3 things it has recommended to us. Then I'm going to use the storage part. So how is the storage going to help me? So in the storage, you would have a 2 terabytes of storage required. So that's what it is considered. Here it is considered CPU. How is this matches? Going little on a pie chart way. This is how the costing for the on-premise works well. For the Amazon, this is all about the your infrastructure cost. Also storage cost is how this is considered. Now how did Amazon calculate these things? So we come to the calculation part. So Amazon says in the left hand side, server hardware cost for these machines. So it would be using these machines, and this would be costing you around 6,947. So this is the unit cost it has worked out. For each unit would be costing around 10,000, and it considers that the vendor is giving you 25% discount. So this is how the cost is working out. And this cost it has got, we'll go a little below and see how this cost has come out to also 900,000. If it's for your organization, that's a different cost, you can consider that. This is the hardware maintenance cost you might be paying over the year, 3 years. You might need the racks. So what is the cost of the rack infrastructure? That is also coming. The rack is a very costly infrastructure. Virtualization software. So if you are going with the VMware, you would be paying 100,000 almost for the VMware. Your facility cost, your server cost breakdown, how it's coming out for you. Now when you compare everything, also your storage cost, total data center space, power costing and cost. So it has also counted because you need a data center. You would be paying for the electricity. You might be paying for the cooling cost and everything, AC and everything. So that's the cost also it is counted. Considering all this, it's a much higher. Then this is the networking cost, which Amazon you don't need to pay. Yeah, in the Amazon you need to pay for the support. So that's the support cost. It is counted also. Support cost for the reserved instance also it is considered. So all these costs it is considered. Now we go for the methodology. How does this work? It says total cost of ownership uses the following methodology equal to acquisition cost plus operation cost. So how much you need to pay for the paying for procuring this infrastructure and how much you need to pay to keep it running over the period. So this is your cost is coming out. Server cost, storage cost, network cost, everything. Also for the on-premise or co-location, how much it is costing you. So your total cost of ownership. Then your server cost, storage, everything what you are counting, Amazon has considered that. So you should be able to refer this to what Amazon offers and what would not be available in your infrastructure, which you might need to pay additional for that. What are the assumptions Amazon has made? So here the pricing also, the server and rack pricing. So for that it has considered Dell PowerEdge prices, which is available from here. It has considered the HP ProLite rack servers pricing, which is available from here. So different kind of a rack, HP, all that pricing it is done. Considering all this, it has made the assumptions and the calculation for you. If you have any questions also, there are the few questions answered here. You love the report, you want to show to your management saying I'm going to bring 200,000 savings in 3 years, everybody would love that. That's where you can download the report also. So this is how the Amazon is one of the most effective or cost optimization way for you. Yeah, you might need to go for the reserved instance. This is a much higher level, or I would say 30,000 feet overview Amazon cost optimization technique for you. In some case, you would need to go deep down and understand how am I going to save the cost for each and every service, or how much Amazon going to charge me. So for that, in the resources, there is AWS simple monthly calculator available. If I go to the simple monthly calculator, this is the simple monthly calculator, which is a very helpful tool which would help you to calculate the various cost of Amazon over the period. I'll start with the Amazon EC2. So what I'm going to use, I would say I'm going to use web servers. How much I'm going to keep it running for all the time, 100%. What type of instance are you going to use? I'm going to use the m4.large. The m4.large cost you 12 cents per hourly, but if you go for the reserved instance, it will be effectively 0.04. So for now, we are not going with the reserved instance, we are just going with the normal case. I would say I need 4 for the app servers. Again, I would need 4, but I would need a much larger capacity now, not much larger, one larger, m4 dot extra large. Then I'm going to use the DB servers, 2, M4.4x large. So considering also you would need a storage, so you would say yes, storage. You would need one volume. We are just going, I'm going with the general purpose. I would need 2 terabyte almost storage. Am I going to take the snapshot? Yes, I am going to take the 2 GB of the snapshot every month, or 20 GB. So that's where over the period my storage would keep increasing. And are you going to use the elastic IP? Would that elastic IP be unattached? How many elastic IP remap you are going to do? What is your inter-region? What is your intra-region? All the kind of a data transfer you are going to read or do. What is VPC peering? If you are going to use, we learn about VPC peering. How many elastic load balance are you going to use? So considering all this, when I go to estimate of your monthly bill, it comes to $3,000 per month. Here it is considered, it is going to give me the first 12 months free tier, also it is counted. So out of this 3,000, almost $2,400 cost is for the EC2. It is considered the AWS support cost also. I would go and say, I don't want to count the reserved instance, sorry, free tier part. So here my monthly cost comes to almost 29-21, and again my EC2 cost comes to 2,450. I'll just write it down, 2,450. We'll need to wipe out anyway. And we have not used anything like a reserved instance as of now. Let's see if the reserved instance is going to save some cost for me. I would say for 1 year all upfront reserved instance. In all cases, I'm going to see. Remember, we were paying $2,450 per month. Same way, 1 year all upfront. I'll just put down the things in the notepad also for our easier reference. 2,450, no reserved instance cost. Then I go and say, here, now my monthly cost has come down to $300 from 3,000. Why? Because I have already made a payment of almost $17,000 to Amazon as an all upfront cost for the reserved instance. So now then it would not be charging me anything on a pay as you go model. But what am I going to save here? If you see, now almost 17,000, 16,900. So almost 16,900. One time payment I have done. But what is it saving me? At the same time, it would be saving me almost 2,450 per month, because that's what it's not going to charge me. Let's do some math. Let me open the calculator. Almost $17,000, and 2,450 into 6.5, almost $16,000. So almost we say in 7 months I am able to recover all money. So from 7th month to 5th month or 12th month, the 5 months cost I would be saving a lot with the reserved instance. Here, because I have paid one time upfront almost 70,000 from first go, this way I am saving 5 months of cost. If I'm going to keep on running 24/7, I'm going to run by the 5 months of cost. If I go with the, instead of 1 year, I go with the 3-year all upfront.
My monthly bit says same, but my annual payment or one-time payment is now raised to the 32,854. 32,854. 3-year payment. Now what is the difference here? If I consider the monthly also, yeah, let me open my calculator. $2,450 into almost 14. Okay, so almost in 13 months only. If I was on demand, I would have been paying 2,450 fixed cost every month. So in 13 months only, I might have paid 31,800, 32,000 almost. So in 13.5 months only, my reserved instance payment would have been recovered. 3 years. In 1 year per reserved instance, it was in a 7 months, here in a 13.5 months. If you see another important thing, if you are going for a yearly reserved instance, you pay 16,900. So if you are going year by year renewal, that means you are paying almost 33,000 or almost 34,000 in 2 years period. While if you go ahead and pay for 3 years upfront, you are saving almost whole year even on the reserved instance 1 year payment. So this way, reserved instance helps you save a tremendous amount of cost. Yeah, it's required. You need to understand that when I'm going to use the reserved instance, it's going to cost me in a way, because even if you don't run the instance, it would keep on costing you 24/7 for 365. So if you're sure you're going to run your environment 24/7 365, you must go with this reserved instance option, which would help you save a lot of amount of money. We would see different services also now. You can clear the form from this part. We will now check some other services also. So if I click on Amazon S3, this is how you can help or you can calculate the cost of Amazon S3 storage. For example, you are going to store 500 GB on Amazon. How much would it cost you? What would be the how many requests you are making? How many get and other requests you are going to make? So for each and every, are you going to use the infrequent access storage object? Are you going to use the RRS? Or what is the data transfer you are going to make? Each and every service would be costing you. Data transfer in does not cost you. Data transfer out only cost you. But Amazon says it's good to put the number so you are aware about then how much it would be costing you. Also, we can clear out this form also. So we know that for the S3, it would be costing around $15. I can clear out. I can go for Route 53, CloudFront, RDS, DynamoDB, whichever service is offered by Amazon. All services are mentioned here. Also, if you are going to procure the Amazon support plan, the Amazon support plan cost is also mentioned here. Now, Amazon also gives some ready to use examples. Like if I want to use the disaster recovery backup or large web application all on demand. Where this is an example created by Amazon, which looks like this, where it would be a 3-tier application, web tier, app tier, and the database. It uses DynamoDB for session management, Amazon RDS with the read replica or the standby, multi-AZ, Amazon S3, CloudFront, all it's using. I'll say go and give me the details. Here the monthly cost is coming almost $1,000. So in the $1,000, when you go to the EC2, it says it's using two web servers, but all small. It is using the 300 GB of storage and 10% of the storage as a snapshot. It's using Elastic IP also, an Elastic load balancer. Same way it might be using the various other service, so it would be using the Amazon S3 also, so the cost of the S3 also mentioned. Then cost of the Route 53, what it is using, CloudFront service, RDS service, all the services cost mentioned here. So you select the RDS, it uses the one MySQL database, multi-AZ of 5 GB, M1.large. So how much it would be costing you? So that's your RDS cost of $337. One thing it's very important for us to understand also, whenever we are selecting, remember to select the region also where you are going to host, because if you change the region, the pricing would different also. So from US East to US West, the pricing US West is almost similar, but here when I go for Asia Pacific, if I'm going to host something here, the pricing would be different for me. So you have to think for which region you are hosting and select the accordingly. One good thing also Amazon gives is you can save this. So you can say save and share. So when you say save and share, it would create, you can put down the numbers, details, all that, and you can say, when you say okay, it would generate a URL for you, a static website hosted Amazon S3 URL for you. This URL would be very helpful for you, because now this URL would allow you to share with any of your peers, colleagues, or managers, and they can directly come and view this here. Let me see if I copied correctly and I can put paste here. Oops, no, I should try again. This is how, when I paste it, it would bring down the same thing for me. So you can use it for copy and share also. So this is all about the Amazon Simple Monthly Calculator, a very powerful tool and very helpful tool also when you estimate your monthly budget, yearly budget, what service you should use, reserved instance or on demand or what, how much difference would it make for me, everything it would come handy for you. After looking at the Amazon economics aspect, it is also important for us to understand the Amazon, how does this real billing things works and how do you manage that. In the CloudWatch session, we learn about that we can always create a unique, or rather we can create a um, billing alarms, which we did that. We would be going here. So when I'm here, under my name, I would be clicking my account. And there is a billing and cost management. Two aspects are there. I would be just starting with the my account. So this is my account settings. So this is my 12-digit account ID. I can change the password. Then this is my billing. If I want to define anyone else also for the billing contact, so if there is some issue or there is any escalation, it would be mailing to this person. What are the operations? What are the configure security challenge questions? So I am user access to billing information, account contract information, any communication preference, your cancel service, all this would be, if you want to cancel out your service completely, you can do that. If you want to close your account, you can do that here. So this would stop charging you anything. You could come to the dashboard. This would give you your monthly spending. So last month there was 82 cents. This month it might be costing me around 79 cents. This is just an anticipation from Amazon. Now, if I want to see my bills, I can go to the bill section where it would be giving me detailed report. So I can click on the March, and this is the March consumption report where it says $82. Out of that, my major cost was Elastic Compute Cloud. Though I was using free usage tier, it charged me for the net gateways. So net gateway cost me. It charged me for the database. Then in the Elastic Compute Cloud also, I had demanded a medium instance for the OpenStack and all that OpsWorks. It did that. So that's also one cost. Then Elastic Block Storage, whatever the cost was there. So this is my Elastic snapshot cost. Snapshot would be chargeable. These are the cost of the snapshot for you. Elastic IP address, time where my IP was not released, almost for 82 hours, it also costed me. So all these cost is counted out, and then it cost me almost. So this is my Route 53 cost. I did some Route 53 for a while. Simple email we tried, so that's also cost for that. So considering all this is my total cost, almost 54 Indian rupees coming to this. I can view various reports also. So Amazon gives you an option to create reports based on the usage part. You can go and create reports. I can also do the cost allocation. So if you have created a various tags, like you have created a tag for the production, or if I say VPC, there was based on the name. So based on name, we were giving a various name. So you can generate what are the tags you generated, and then based on that, you can create the various reports also. Then what are the payment methods? Your credit card information would be stored here. Then there would be a payment history. How much payment you have done till now. There is a consolidated billing account. That's an important. If you have a multiple AWS accounts, you should, instead of paying from the one account, you can use the consolidated billing account. So in that case, what would happen? You have a master pay account, and you have three different verticals within your organizations. You can say it's a production, development, and test. And this is the another account for your HR or admin or somebody or IS team. It is using that. Now, since you have 4 accounts, you might be getting 4 bills. You would be paying for the 4 different person for this. How would you manage it? Here for you, you can configure a master pay account and link all this account with this master pay. So you have to send sign up consolidated billing, and you have to send all 3 accounts request for this. Once they accept the request, henceforth all the charges for this account would be billed to this account. So this becomes a master pay account. It's just a payment facility. So instead of 4 bills and 4 separate payment methods, only one account is paying for you. So that's how you would be setting up the consolidated billing also. You would have your own preference, and this is where we set up the billing alerts part. So we can set up the billing alerts. If you want to get the billing alarms, you want to receive that, you can do that also. If you want to receive the emails of the invoice by mail, you should mark that. So this time every month it would be sending you over the email. You want to get the credits. If your Amazon has given you any credits and you want to use that, you can add those credits here. How does the text settings work? So if you are having any PAN number and you have done any settings, you can do that also. So this is how your overall dashboard. And it's a very important. You should go to this your console, keep checking your bill regularly every 3-4 days, and without fail, you should have set up the billing alerts. This is a very, very important aspect. You should not forget that. We can see that apart from that, there is a security credentials also. We checked that before also. I'm just giving a very quick overview. So in the security credentials, you can modify your passwords from this place, your account. If you want to enable your multi-factor authentication for your organization, for your root account, you can do that. Access key and secret access key, these are helpful when you have a access key and secret access key available when you want to access Amazon services like EC2, EBS, RDS, VPC, anything over the web APIs or SDKs or command line tools. This would be helpful for you. CloudFront key pairs are also very helpful for you. So CloudFront key pairs would be when you want to secure the access, you want to create a unique URL, you would be able to use that. X509 certificates are helpful when you want to make a SOAP protocols. Over the web service, when you want to use the REST calls, you might use access key, secret access key. For SOAP protocols, you might use the X509 certificates. For the account ID, this is my account ID, and this is a canonical user ID, which is useful for the Amazon S3. For when you want to configure the AWS access control list, you can give this canonical user ID also. So this is how the security things will work for us. So this is all about our Amazon account overview, AWS Glacier. Here we would have an introduction of the Glacier. We would understand what are the key terminology of the Glacier, and we would see a demo. Now, before we begin, what is a requirement for the archival? Suppose you are having a very large data set, but that is very infrequently used. If I give you, you are having a banking data, right? where you need to keep the transactions of your own bank transactions for at least 6 to 7 years as per IT laws. But you are not referring them day to day basis. You might need to store them. Now suppose this is a company and where there are the huge data covered like that, which might be in a gigabytes of the size. You need to maintain that. Or you think of there is a factory where there is a manufacturing going on, where there would be lots of data available about the manufacturing units, the procurements, the POs, invoices and everything. You again need to maintain those data. Now the common factor in all this part is this data is hardly used. Like in the banking data, only when there is an audit requirement you would be able to use, or in the invoice or some other where there is a query you would be able to use. Otherwise you don't use it, but you still need to maintain them. So you need to data to be stored only considering there might be a future need. There might be. And another point is you don't want the data to be available immediately. You don't want the case that, okay, I need data now, give me in a moment. You are okay that most of the cases, even if you get in 1 or 2 hours or 3 hours, you are okay with that. This is the perfect case of archival. These are the cases where you would be using the archival services. Amazon Glacier is an extremely low cost storage service used for the data backup and archival. It's a AWS managed. It's a scalable archival service. So your advantage is you don't have to do any capacity planning. You don't have to do any hardware provisioning, any kind of a data replication, hardware failure and detection, repair, automatic. So maintenance of that. Everything is being taken care by Amazon Glacier. You just have to put the data, it would be archived and managed on behalf of you. Imagine you have a terabytes of the data and you need to maintain that. How would you do that? Amazon Glacier would come very handy for you. Glacier, when we try to compare with the Amazon S3, if I'm trying to store a 500 GB of the storage, Amazon S3 would cost me around $15. At the same time, Glacier would cost me $3.5. Now when you compare these two, this is almost less than 10% cost, or almost I would say 20% or 25% of the cost of this, less than 1/4 cost. So that is the advantage of the Glacier. But Glacier is not a replacement to Amazon S3. They both have a practical difference. The cost wise, S3 is cheaper, Glacier is the cheapest. They do charge you for the put, copy and different services. Even object size, S3 supports maximum 5 terabytes, Glacier supports maximum 40 terabytes. Here, the difference you lie is access. When you go to S3 and you try to access, data is available immediately. With Glacier, it takes 3 to 5 hours minimum to make the data available to you. In S3, data is stored in a unique bucket. The bucket has to be unique across the globe. While here archive is available in a vault. We call it an object there, here we call it an archive. So the purpose is, this is useful when you have a frequently access objects. We learned about the static content storage. When you have static files, you want to store that, S3 is the perfect solution for you. Glacier is for archival only. When you don't need the objects to be available immediately. You request and it would take 3 to 5 hours to make that object available to you. But that's why you save the humongous amount of cost with that. Let's try to understand the concept more. Glacier has two concepts, vault and the archive. A vault is nothing but a container of for storing the archives. While when you create a vault, you would be specifying a name. You select an Amazon region for this vault. So vault would have a unique URL, something like HTTPS. Everything would always be HTTPS. Then glacier dot something, that is the which region it belongs to. Your account ID, this is your AWS account ID. Then vaults and then the name of your vault. This is how a vault would be created. Difference between vault and object bucket is, bucket name has to be unique across the globe because it was accessible over internet. Vault does not need that restriction. because Vault is not accessible over internet. So that's why it would always have account ID part of that. So it has to be unique for your account only, not across the globe. Otherwise you can think Vault is like your bucket only because it's a container for storing the archives. Same way your archive is also like a file or object what you want to archive, what you want to store the data. It can be any doc file, PDF, image, photo, video, whatever you have. You want to do that. Each archive has a unique ID. This would be archive for ID. So this would be your vault name, and after vault there would be a archive ID. A huge long around 64 digit plus ID offered by Amazon Glacier. These archives ID are always unique. So if I upload one archive, it would be assigned a unique ID. I uploaded second archive, it would be assigned a new ID over there. So each archive would have its own ID. And you can always store an unlimited number of archives in a vault.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Let's discuss why one must opt for GCP. GCP offers various unique features such as best pricing, automatic task scheduling, live migration, customization, flexibility, and scalability. Let's discuss all these features one by one, starting with best pricing. Google Cloud uses a pay-per-use model according to which you only have to pay for the resources that you use. Also, Google Cloud hosting plans are said to be cheaper than other cloud hosting plans. So, GCP provides customer-friendly pricing where there is no upfront cost and termination fee. Automatic task scheduling. Google Cloud allows you to virtually schedule any task or job, be it running your staging VM environment only for working hours or turning down half the machine fleet in the middle of the night. The cloud scheduler will let you automate many of these tedious tasks in a managed manner. Live migration. Google Cloud's live migration feature allows proactive maintenance of all resources without causing any hindrance in the performance of the virtual machines hosted by the organization. This saves businesses from the headache of dealing with downtimes or outages. Customization. GCP provides a custom machine type feature that lets users create a virtual machine customized to their needs. Custom machine types are priced based on the resources that you use, and in some cases you can even save up to 50% or more compared to other cloud providers. Data privacy and security. Google Cloud Platform has put a significant amount of effort in ensuring data protection and security for their customers. Google has hired a team of professionals called Information Security that constantly work on securing and protecting the data stored in the Google Cloud. Also, Google uses several layers of encryption to protect the data of customers that are using GCP. Flexibility and scalability. Google Cloud Platform is known for the scalable system that it provides, which automatically adds more capacity as the workloads increases. You can specify how much CPU and memory each instance of your application needs, and the flexible environment will provision the necessary infrastructure for you. So these are all the main features that make GCP stand out the most. So moving on, let's now understand what exactly is GCP. So Google Cloud Platform, as you must already know by now, is a cloud platform offered by Google. It offers various cloud computing services such as compute, network, storage, and more. But that's not all. There is more to GCP. I bet you all must have used or at least be aware of Google products such as Google Search Engine, YouTube, Gmail, Maps, and Hangouts, right? What if I told you that Google uses their own cloud platform to manage and operate these products? I mean, how awesome is it that Google offers the same cloud infrastructure as they use for their own products to its users? We all know how amazing are Google products, right? So imagine how awesome will be the underlying infrastructure. and you'll get to use that same awesome infrastructure if you use GCP services. So here's another huge reason for you to choose GCP. So moving on, let's now understand GCP global infrastructure. Even though GCP is fairly young, they have been able to establish a reliable infrastructure which is growing across the globe at an awe-inspiring rate. Google Network is known worldwide for its speed, reliability, and capacity. Google Cloud is made available in 19 regions, 58 zones, 134 network edge locations, and 200 plus countries. And it will also be soon expanding to places like Japan, Indonesia, and Los Angeles. So now let's talk about the services that GCP offers. These services are categorized into different domains such as compute services, storage services, networking services, machine learning services, big data services, identity and security services, and many more. But the main services that can be used to host any kind of application are compute services, storage services, and networking services. Let's now understand these services individually, starting with compute services. So in compute services, first we have Compute Engine, which is basically an infrastructure as a service offering from Google Cloud Platform. Compute Engine service provides VMs, that is virtual machines, hosted on Google's infrastructure. Now, being an infrastructure as a service, you can think of it as a fresh piece of computer where you'll be given various options for OS, and you'll be given various options for units of CPUs and memory that you want for your virtual machine and everything else. Basically, all the configurations will be at your hands. Next comes App Engine, which is a platform as a service offering from Google Cloud. It's basically used for hosting and deploying your applications on Google Cloud Platform. So if you're using App Engine to deploy your application on Google Cloud, you won't be given any access to the operating system configurations or storage or the installation of the frameworks that you will need to deploy your application, because that will all be managed by Google Cloud itself. All you have to do is upload your application using App Engine and you'll be provided a link where your application will be running. So next comes Kubernetes Engine, which is basically a cluster management and orchestration system for coordinating Docker containers. So if your application is running in different Docker containers and you want to deploy that application on Google Cloud, then all you have to do is migrate those Docker containers using Kubernetes Engine, and you can then deploy your application on Google Cloud. So after compute services, next comes the storage services. So in storage services, first we have cloud storage. Cloud storage is an online file storage web service for storing and accessing data. Cloud storage can be used to store any kind of data. So when you're hosting an application on Google Cloud and you want to store the application data somewhere other than your server itself, then you can use cloud storage, which is also reliable and secure. And also, it's always considered good practice to create distributed architectured applications. So next in storage services, we have Cloud SQL, which is structured query language. Cloud SQL is a fully managed MySQL database service for hosting relational MySQL databases on Google's infrastructure. So if your application deals with only relational or structured data, then Cloud SQL might be the best option for you. Next storage service is Cloud Bigtable. Cloud Bigtable is a fast, fully managed and highly scalable NoSQL database service. Cloud Bigtable is actually used for big data applications like Hadoop. Now after storage domain comes the networking domain. So in networking services we have VPN, that is Virtual Private Network. VPN provides a private network to create a secure environment for your deployments. So basically, let's say you launched an instance and then you launched another instance and you want both of them to be communicating with each other. Now for that to happen, you'll have to include those two instances inside a network which will provide the instances a secure environment to be communicating with each other. So that's how VPN works. After that we have Cloud Load Balancing. Cloud Load Balancing is a service that load balances and auto-scales GCP compute resources. So basically, Cloud Load Balancing is a service which will distribute the incoming traffic of your application to multiple servers. Now there are two kinds of load balancing. First one is classic load balancing and the second is application load balancing. Now if you want the traffic to be equally distributed to multiple number of servers, then you will have to use classic load balancing. But if you want the traffic to be distributed on the basis of requests that you're getting on your application, then you'll have to use application load balancing. For example, if the user is requesting for storage upload, you may direct the user to some other server. So in networking services, next we have Cloud CDN, which is Content Delivery Network. Cloud CDN is Google's globally distributed edge points of presence to cache application content close to users. Suppose you hosted an application on Google Cloud in some region, but the user base of your application also exists in some other region. So when they try to access your application, it'll obviously take some time for your application to respond because your application resides in some other region and the user base is in some other region. So what you can do is you can use Cloud CDN to create a copy or a cached version of your application and place it on a server which is in a region closer to your user base. So now when they try to access your application, it won't take as much time as it used to. So that was all about networking services. Now moving on, let's discuss big data services. So in big data services, first we have BigQuery. Query is a fully managed data analysis service that enables businesses to analyze big data. After that we have Cloud Data Flow, which is a fully managed real-time data processing service for batch and streaming big data processing. And then we have Dataproc, a fast, easy to use, managed Spark and Hadoop service for distributed data processing. After big data services, we have identity and security services. So first we have Cloud IAM. Cloud IAM lets administrators authorize who can take actions on specific resources, along with built-in auditing. After that we have Cloud Resource Manager, a service for programmatically managing the resource containers and also used to group and organize GCP resources. Cloud Security Scanner, a web security scanner for common vulnerabilities in App Engine applications. Now let's discuss machine learning services. Cloud Machine Learning. Cloud Machine Learning is a managed service for building machine learning models using TensorFlow framework. Cloud Vision API. Cloud Vision API is used for image recognition and classification, detecting individual objects and faces within the images. Cloud Speech API. Cloud Speech API is used to convert audio to text. This API recognizes over 80 languages and variants. Alright guys, so now let's move on to the hands-on part. Like I said before, we'll perform a practical where we will use various GCP services. So let me quickly brief you about this hands-on. What we'll actually do is that we'll create an application, a PHP application that lets you browse your local machine for an image and lets you upload that selected image onto the Google Cloud storage. We will then also deploy this application onto the Google Cloud. So before we start, let me show you how this application actually works by running it on my local machine. Since it's a PHP application, I'm using XAMPP. So for those of you guys who don't know what XAMPP is an open source cross-platform web server solution which lets you run your PHP scripts on your local machine by providing you a local web server. So to run my PHP application on my local machine, I had to first set up my machine, right? I had to download XAMPP, then I had to install it, and now I can run my PHP applications. So guys, before I run my application, let me quickly show you where all your PHP files should reside if you want to run your PHP application on your local machine using XAMPP. So when you download XAMPP and install it, you'll probably find a folder in your C drive called XAMPP. So in this folder, you'll again find a folder called htdocs where all your PHP files should reside. So my file is index. So to run my PHP application, all I have to do is type in localhost on my browser /index.php, my PHP file name. And when I press enter, here's my application. So as you can see, there are two options here, choose and upload. So let me click on choose to browse and select an image from my machine. Here I have an image called GCP tutorial. I'll select this image, open, and as you can see, the image has been selected, GCP tutorial.png. So before I click on upload image, let me also show you my cloud storage bucket so that you know it's empty, and after I click on upload image, the image will be uploaded. So here I go to my bucket. I've created this bucket for my application. So right now you can see it's empty, right? So going back to the application, if I click on upload image, it says the image has been uploaded to your bucket successfully. So let's go back to our bucket and confirm if that's true. See here, if I press on refresh bucket, here you can see the image has been uploaded. Okay guys, so now you know how the application works, right? So now let me tell you what are all the components that you will need to run your app. So first of all, you will need an App Engine instance to deploy your application on the Google Cloud. After that, you will need Cloud Storage Bucket where you will be uploading all your images from your application. After that, you will need something called Cloud SDK. I'll tell you what it is and why do we need it once we get there. After that, there's something called Service Account Key that you will also need. And then there is Composer. Again, I'll let you know what it is and why do we need it once we get there. So guys, these are all the components that you need to deploy your application on cloud. But what about creating our application? What are the things that you need to create your application? Well, first of all, of course, a PHP code file which you will run as an application, and then there is app.yaml file, which is a configuration file that you will need for your PHP code file. Okay, so now let's get started with our demo. For that, you'll have to go to your Google Cloud Console. In GCP, everything you do that includes any service you use, any resource you run, any application you deploy, absolutely anything that you do is counted as project. So basically, if you want to perform any activity, you'll first have to create a project where you can associate that activity to that project, or you can just select any of the previously existing projects. So guys, if you want to create a new project, then all you have to do is go to this tab that currently says hello. That is because the project that I've selected or the project that I'm currently using is named as hello. So when you click on this tab, you will be able to see the list of all the projects that you have previously created. For creating new project, you just have to create a new project, and then you can name your project anything you want, and then after that you can just click on create. Also, here as you can see that every project has something called ID. So when you create a project, GCP will auto-generate a unique ID for all of your projects. So once you have created a project for your application, make sure that the name is reflected over here, because that means that the project that you just created is currently selected and you're going to work under that project. So after creating the project, the next thing that you have to do is create your first App Engine instance. Now you need App Engine instance to run or deploy your application on the cloud. As you guys saw, when I was running my application on my local machine, I had to first set up my local machine to run my PHP application, right? I had to first download XAMPP and install it, and then I had to make sure that all my PHP files reside in that particular folder. So basically, I had to set up my environment for running my application. But when you're deploying your application on App Engine, you don't have to worry about any of that, because App Engine, as I've already mentioned in this video before, is a platform as a service offered by Google. So all the necessary infrastructure and the environment setup will be provided to you, and you can just directly deploy your application and run it. Now, to create an App Engine instance, there are actually two ways of doing that. First, you can directly create an App Engine instance using this console, or second, you can use something called Cloud SDK. Now, Cloud SDK is a set of tools for cloud platform, which also includes command line tools. So basically, you'll be able to access and use any of the services provided by GCP using a command line tool. Also, Cloud SDK is what you need to deploy your code files onto the cloud. So in this hands-on, we'll be using Cloud SDK. To use Cloud SDK, we'll first have to download it. So let me show you how you can download Cloud SDK. You just have to click here and you see downloads here, right? This option is basically the home for all the tools that you may need to use with any of the GCP services. So if you want to download any tool, you can just click here and you'll get a list of all the tools and you can download any one of those. So let's click here. So here, as you can see, this is the list that I was talking about. You can download any of these tools whenever you need them. So right now we need Cloud SDK. So let's click on that. So now we are directed to the Cloud SDK documentation. So I'm using Windows, so I'll just keep it this way only. But if you're using some other OS like Linux or Ubuntu or any of these, then you can select those. And after that, you just have to click on this Cloud SDK installer. Once you click on this, the Cloud SDK installer will be downloaded to your machine. So all you have to do after that is run this exe file and the Cloud SDK will be installed on your system. So after you have successfully installed Cloud SDK onto your system, you'll probably find a shortcut to your Cloud SDK shell sitting on your desktop, like this. So now we have Cloud SDK, which we'll be using to deploy our application code files onto the cloud. And we'll also use Cloud SDK to launch App Engine instance where we will deploy our application. So now one of the remaining components that we need for this hands-on is Cloud Storage Bucket. So let's move on and create a Cloud Storage Bucket. To do that, we'll go to our console. Here, if you see on your left side, there's a list of all the services offered by GCP. So we'll navigate to Storage and then there it is, we'll go to Browser. So here you can see a list of all the buckets that I've already created, and on the top of the list there's the bucket that I was using for uploading the images from my application onto the cloud. So since you have to create the bucket from scratch, let me show you how you can do that. You just have to click here on this option called Create Bucket, and then you'll have to provide a name for your bucket, which by the way should be unique globally. So let me try. So as you can see, if you're trying to use a bucket name that is already in use, then GCP will inform you like this. So let me try some other name. Alright, so I guess I found a name. So next we have default storage class. So here we have 4 different options. Multi-regional and regional storage classes are based upon regions, whereas nearline and core-line storage classes are based upon the usage of your bucket. Multi-regional is to be used with a bucket that is going to be accessed frequently from multiple regions, whereas regional should be used with a bucket that is only going to be accessed from a particular region. Nearline should be used with a bucket where the data of the bucket is going to be accessed once per month, whereas core line should be used with a bucket where the data of the bucket is going to be accessed very rarely, that is once per year. So here for this hands-on, I'll use multi-regional storage class for my bucket, and then I also have to specify that my bucket is to be accessed from multiple regions in Asia. Alright. You can further also compare storage classes on the basis of the cost, but then you don't have to worry about that if you are in your free trial period. So moving on, we'll just click on Create. And there you go, your bucket has been successfully created. So now we have Cloud SDK. We'll be launching App Engine instance using Cloud SDK. We also have a storage bucket. Let's now look into service account key. Service account keys are used to authenticate machines such as compute engine instances or app engine instances to use other cloud services. Like in this hands-on, we are using service account key to authenticate our app engine instance to use our storage bucket that we just created. So let me quickly show you how to create a service account key. All you have to do is go to APIs and services and then on credentials. After that, you just have to click on create and then select service account key. Here you have to choose new service account and then give a name to your service account such as select the role as project and then owner, and then make sure the key type of your service account key is JSON. After that, you just have to click on create and the service account key will be downloaded and saved on your system in JSON format. So here you go. Now make sure you keep this file safe because we are going to need this. Now we also have service account key. So what's remaining is Composer. So let's get to it. Composer is basically a package manager that deals and handles with all the packages and libraries that you may need to include in your PHP code file. So when you download Composer, All the necessary packages and libraries that you may need to use with your PHP code file will also get downloaded in a folder named vendor. So let's download our composer. I'll mention the link to download the composer in the description below. So once you're directed to this page, just click on download and then click on composer setup.exe, which will download the installer for you. After the composer setup is downloaded, you can just run this exe file and the installer, as mentioned here, will download composer for you and set up the path environment variable, so you can simply call composer from any directory. After the composer is downloaded and installed successfully on your machine, like I said before, a folder named vendor will also be created containing all the necessary packages and libraries for your PHP file. So moving on, let's look into our application code files. So this is the folder where I've kept all of my application code files. As you can see that I also have a JSON file here. This JSON file is the same service account key that we just created and downloaded to my system. So let me open my PHP application code file and show you my code. So here's my PHP application. First of all, let's just get over with the front end of our application. Here's a regular HTML code where I have included a form for the front end of my application. And here's the whole PHP code for all of the backend work that my application is doing. You can find a similar PHP code on Google Cloud documentation also. So I'll just tell you all of the things that you will have to include in that code on your own. So first of all, I have included a file called autoload.php, which is basically a library which resides in the folder named vendor, which was downloaded when I installed Composer on my system, under which I am running my application. So for this field, you'll have to include the project ID of your own project that you created in the very beginning of this hands-on. After that, I have included these 3 lines of code where I have provided the name of my JSON file which was downloaded to my system when I created my service account key. So you'll also have to include your service account key in this field. After that, here in this field where I have actually created a variable called bucket, I have included the bucket name that I am using to upload my images from the application that I have created. So in this field, you'll have to provide the cloud storage bucket name for your bucket. This is the basic PHP code for uploading images from an application. After that, I have included these 2 code lines where basically I'm uploading the selected image to the bucket. Here I've used the variable named bucket, which I created when I was including my bucket name. After that, I'm simply displaying a message that the image has been uploaded to your bucket successfully. So that was all in my PHP code file. Now let's look into app.yaml file. So app.yaml file is basically a configuration file that tells App Engine how our application is going to behave. Let's go line by line to understand this app.yaml file that I have. So the first field that we have here is runtime. Runtime tells what kind of script I'm going to use to deploy my application on App Engine. So if you're using a Python script, then you'll have to mention Python here instead of PHP. After that, we have API version. API version specifies the version of runtime environment that the App Engine is going to use to deploy your application. Specifying the value 1 here tells the App Engine to use the latest supported runtime environment. And then next we have handlers. Handlers section defines which requests are going to be processed by which script. So for this hands-on, the application that I am using contains only 1 script, right? But what if I had 2 different scripts? Let's assume that I had 2 scripts named image.php for uploading images into the bucket, and then the next script named file.php for uploading text files into the bucket. In that case, I would have mentioned in the handlers that for the kind of request where the user wants to upload an image into the bucket, my image.php script should be processed, and for the kind of request where the user wants to upload a text file into the bucket, my file.php script should be processed. But right now we don't have to worry about that because I only have 1 script, that is index.php. So that was all about the app.yaml file. Going back to the PHP file, Once you're done including all the necessary files like service account key and your bucket name, your application will be able to upload images in your storage bucket. You can test it by running it on your local machine using XAMPP like I did in the very beginning of this hands-on. Once your application is up and running, you'll be ready to upload your application onto the cloud. Moving on, let me show you how to do that. So, the very first thing that you need to do is start your Cloud SDK shell. So, let me do that here. So, before we can start using our Cloud SDK shell, let me first tell you that you'll have to append the path of your Cloud SDK in your environment variable. Repeat, once you've done that, you can start using your Cloud SDK shell. So, now what we need to do is, we need to run the command gcloud_init. So now since I've already logged in using my account and I have already selected my project, I don't have to create a new configuration. I can just reinitialize this configuration with new settings. So let me pick my numeric choice as 1. So I would like to choose my account only. Alright. So again, I will use the first project because that is the project under which I'm going to run my application. Alright, do you want to configure a default compute? Okay, yes. I'll choose Asia South. So now we are ready to deploy our application onto the cloud. But to do that, we'll also have to deploy our application codes onto the cloud, right? So to do that, I'll just have to move to the directory where all my application codes reside. So let me first do that. I'm moving to the project directory where all my application codes are. So we can also view all of the files and directories residing inside the project directory with this command. And so now you can deploy your application codes using this command, deploy. Do you want to continue? Yes. So it says file upload is done. Alright, so now my code files are deployed onto the cloud. So to run my application on App Engine, all I have to do is copy this from here and I'll paste this link on my browser, and here you go. Now my application is actually running on App Engine. Let's see if it's still working or not. Again, I'll choose this image and I'll click on upload image, and then I'll go back to my bucket to see if the image has been uploaded or not. So again, the image has been uploaded. So guys, that would be all for this hands-on. Let's now move on and take a quick walkthrough of the whole session. So the first topic that we discussed was cloud computing. We learned what is cloud computing, and then we looked into the categories of cloud computing and various cloud providers. Then we learned why one must opt for GCP. We learned out of all the cloud providers what makes GCP stand out. Then we learned what is GCP. We also had a look at some Google products. After that, we learned about various GCP services, and then we learned how to use GCP services by performing a hands-on. So basically, we covered all the major fundamentals of GCP and we also performed a hands-on.
So coming to the first question on the top cloud computing interview questions and answer set, we have a question that states compare between cloud and on-premise computing. Well, whenever we go on to compare cloud and on-premise computing, you really have to talk about 5 very important points. And the first thing is, of course, it's always going to be initial cost, because so whenever you're talking about a cloud computing environment, your initial cost to set up the hardware is extremely low compared to having an on-premise setup. And then coming to maintenance is mostly hassle-free in a cloud computing environment because you really do not have to have experts standing by working with the hardware, associated software, network and all of that. But in the case of on-premise software, you do require good amount of expertise there. And when you're thinking about scalability and upgradability, right? Cloud computing, the middle name of cloud computing should be scalability and upgradability in my name, because it's automatic, it's excellent, it does a very good job of, if you want to go from, if you want to scale from, let's say 1 gigabyte storage to 10 terabytes in matter of, I don't know, half an hour. It is really possible that quick today. And it's not only that, right? So when you're talking about upgradability, you want to use the computing power of one machine versus 10, 12, 30 at a moment's notice. Yes, it's possible. And then when you think about, one of the biggest advantages of cloud computing is the pay as you go policy, because at the end of the day, you'll only be putting down money for the things that that cost you money, basically, at the end of the day. So what I mean by that is, if you're using certain computing resources, you'll only be charged for that rather than the entire thing, for example. So in that particular case, depending on how much storage you use, how much computing power you use, for what amount of time has your cloud computing environment been running, it's been up, the instance has been created and it's being used, based on all of that, you will have to pay as per you go. Now, coming to the second question, it states, what is a cloud? Well, this is a very generic question, so make sure you do not get carried away by the simplicity of the question. Make sure to keep the answer concise. See, a cloud is nothing but a collection of networks, collection of hardware, services, storage, and an interface that brings it all together to make sure that you can provide all of these, right? Hardware, computing power, and storage as a service to the people out there who have access to an internet connections. So who uses cloud? Well, we have end users who make use of cloud. For example, we ourselves will be using a lot of cloud, right? Think about it. Backing up your photos to the Apple iCloud or Google Photos itself is using a cloud service. And then you have business management users, and of course the cloud providers themselves, right? So the service providers themselves are the ones who are providing the service. There are a lot of big names when it comes to cloud computing, and you can either use it for personal usages or business applications too. Coming to question number 3, it can be a follow-up to the previous question, but here we are asking, what is cloud computing? See, when you're talking about cloud computing, you have to understand that it's not only just cloud storage, it's a lot more than that. It's literally having supercomputers at the tip of your fingers and using all of its computing power, all of its resources, all of its storage as well. So, you can do everything with today's cloud computing out there. You can run, government organizations, military networks. You can, handle everything that's present in space as well with the use of cloud computing networks. Yes, NASA does use a lot of cloud computing. It's a very important innovation in the modern world where technology is provided as a service, and based on the user's requirements, technology can be implemented in a way to cater to very specific requirements without having to put down a lot of money or a lot of time too. This is cloud computing in a whole. Now, coming to question number 4, it says, what are the benefits of cloud computing? Well, again, this is another question which is very, which makes it very easy for you to get carried away with the answer. But I definitely recommend, at least taking your time to answer it in a concise way with at least 4 or 5 points to talk about the benefits of cloud computing. I am sure you can probably state 10 or 15 points. It's really good. If you're not explaining the points, do talk about the points and list them. But if you want to explain about each different point, make sure you're keeping the answer concise. For example, you can have automated data backups, automated storage of data. You can have very powerful server capabilities, very good amount of productivity. There's not much upfront cost for the hardware. You can save a lot of money. You can save a lot of time. You can access it remotely from any part of the world, depending on how good your internet connection is and all of that. So you can go on and on and on. So make sure you're sticking to at least 5 very good foundational points such as this, and then build your way from there. Coming to the 5th question, it says, mention the layers of the PaaS or the PaaS architecture. See, whenever we're talking about PaaS, you have to know that it's platform as a service, right? So you get a lot of details in PaaS, SaaS, and of course, the other kinds of architectures that are present in cloud computing as well. But one thing is that whenever you're asked a specific question such as, we want the layers of PaaS architecture, make sure to know that exactly as how I've shown here. See, there's 3 main layers. One is the cloud controller layer. Of course, we have the storage services layer, and we have the application storage layer. Now, when you're talking about the platform as a service architecture here, what we do with the cloud controller is we make sure that, you have virtual machines that get created. You have controllers for those virtual machines. You can deploy the applications. You can connect to services, scale up, scale down based on your requirement, and match, the requirements. So all the things that control the actual environment through which you're going to run your machines on, that's cloud controller. And then we have the storage services. Of course, we have to have a place where we can manage data, ingest data, process it, and store it, right? For that, that particular case, you can make use of objects, you can make use of NoSQL, the relational databases, block storage. There's a lot of different kinds of storage services that are provided. And then of course, when you're thinking about the applications that get stored in these, right? So you can have applications which are simple to scale. They can be easy to recover from if there was any sort of failure. Chances of failure in today's world of cloud computing is very lean, but even if there is a chance of failure, you can recover your data very easily in a PaaS architecture through this particular storage services as well. I mean, of course, you can go on to explain more and more in case if the interviewer does expect, but this is a good framework to approach this question and answer it effectively. Coming to question number 6, it says, what are the cloud service models that are out there today? Well, you can be asked a question in a very different way, saying, can you explain the various services that the cloud offers today as well? It's the same question. Now, coming to the answer of this, there are 3 main types of, the cloud service models that we have today. One, we have PaaS, which is platform as a service. We have SaaS, software as a service. And of course, we have IaaS, which is infrastructure as a service. If you are in this video at this point of time, I'm sure you have heard of all of these and you know the differences that exist between them. If you do not, I would definitely suggest you check out the cloud computing video that we have. In fact, we have multiple videos on cloud computing here on the Intellipaat YouTube channel. So make sure to brush up on all of the concepts because, this forms to be a very basic foundational concept that you really have to know in case if you're planning to have a serious career in cloud computing. So coming to question number 7, it states, what are the components of Windows Azure? Well, the Windows Azure platform services offer a lot of things, but there are 3 most important components, under which, of course, you have a lot of other components, so sub-components too. We have the cloud computing environment, we have SQL Azure, we have the application fabric, which will, allow for a fabric cloud to be used. And then you can have a lot of sub-components as well. See, in the cloud, you can have a lot of subcategories of how the cloud is used and, what the cloud provides, what makes it native, what makes it special and all of that too. And of course, when you're talking about SQL, that's an ocean of its own, right? But once you're asked for the components, do put it out in a clear way such as this. And of course, if you are asked to explain, there might be a follow-up question saying, okay, can you talk about Microsoft Azure Cloud? In that particular case, of course, with the follow-up question, you can go on to answer that too. Coming to question number 8, it says, what are the differences occurred in distributed operations? Well, whenever we're talking about distributed operations, FC and Nova come into the picture, right? So in FC, we have the operations that take place as a master-slave, master-slave architecture. But then when we're talking about Nova, the main difference here lies in how, processes are executed parallelly and how its data gets shared across, the network or the channel whenever it is required to. So whenever you're thinking about distributed operations, make sure you talk about how master-slave operations work, and of course, how the data gets stored, how processes can run, either if it's based on events or if it's based on triggers or if it's based on a requirement for scaling, and a lot of that too. Coming to question number 9, it says, which agent is equivalent of Nova Compute? Well, Nova Compute has a very good equivalent, and in fact, I would say that the equivalent of Nova Compute is Azure Agent to one point of time, because it's considered to be on par with Nova Compute. But in my honest opinion, I think Azure Agent has a lot of lot under its belt that makes it that gives it the particular edge to move it one step ahead of Nova Compute. So what do you guys think? Have you used Nova Compute? Have you used the Azure Agent? If you do have, head to the comment section and do let us know. And then coming to the 10th question, it says, mention the reliability and availability of cloud computing. Well, again, this is a very important question. There's a very good chance that you'll be asked this particular question, right? So to attack it really well, do talk about how fault handling is done in the world of cloud computing, right? So when we talk about how 2 virtual machines are used in a single fault domain, if there is one particular hardware that fails, it means that both of your virtual machines can fail. But what a cloud computing platform like Microsoft Azure does in this particular case is it has the capability to automatically distribute instances of a role across a lot of fault domains too. But when we go on to talk about how we can use the upgrade domains to make sure our data is available and of course it's reliable, right? In that particular case, whenever think of the scenario where a new software version gets rolled out, right? Version control is something that's very important, and every time that this gets done, we make sure that any sort of service that is attached to it or any sort of data storage that is using this particular instance of it, that it is completely available for usage. And it is making sure that even though there might be multiple instances that get created and operated based upon that, well, in that particular case too, of course, it will be readily available to scale. The availability of programming power and the availability of how data can be scaled in a reliable way is the talk of the day whenever we talk about how we can go on to use upgrade domains. But when we're talking about a cloud computing platform and availability and the reliability in terms of security, one very important thing in my opinion is to talk about network and the storage availability, right? Because you can have your data to be copied in multiple storage areas in multiple different domains across servers in multiple different continents too. So why do we do this? We do this for one, required redundancy, where if there is a data failure, we can pull all the data back to make sure that we have sufficient backups. And the other reason is that if one of these servers, in case if you have accumulated all your data there, is under a DOS or a denial of service attack, in that particular case, you might not be able to access the content present in that server, and it might not be able to function effectively, right? In that particular case, your client, your business, or whatever it is that you're running on the cloud might come to a halt because the server is not able to provide services for you. To avoid all of that, we do have this kind of redundancy that's built in to today's cloud computing platforms.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Coming to the 11th question, it states, give the best example for open source cloud computing. Well, if open source cloud computing has to be spoken about, I think OpenStack always takes the center stage because it's a very, very good example of what an open source platform should be. It's extremely popular among the startups of today, mid-tier companies. It does provide a lot of functionality because, at the end of the day, you might be thinking, do you really have to put in a lot of money into Amazon Web Services, Azure, or Google Cloud Platform? And, if you are a small company or if you're starting up, you might not have the budget to allocate that much too. In that particular case, do think about OpenStack, because OpenStack is one of these platforms that will help you rapidly scale up, at least at the start. And it has, of course, thousands and thousands of developers across the globe pitching in to make OpenStack better than what it is every single day. That particular case, I do believe that OpenStack is in fact one of the best examples of open source cloud platforming we have today. Coming to question number 12, it says, what is AMI? How do we implement it? So AMI is basically short for Amazon Machine Engine. What it means is that it is a copy of your root file system itself. It feeds all the information that is required to launch any sort of instance on the AWS platform. So you implement this kind of a machine image whenever you actually want to go, launch a particular instance. Of course, you can have multiple instances that can be launched from one single machine image with the same configuration as well. Of course, if the configurations now become different, then you'll have to launch multiple instances and you'll have to launch multiple AMIs as well. But if you have a same configuration that you want to scale across multiple instances, do remember this important point that you can use the same Amazon machine image too. So the image on the screen, I hope, is pretty self-explanatory at this point of time. You're going to create an EBS snapshot. It's going to get registered with the AMI, which is the Amazon machine image. And once you launch an instance, you can directly start using the instance. And of course, if you want to copy it to another instance, that can be done directly if there is a similar configuration in the machine in the second instance that you want to launch too. So how can you implement it, right? So coming to the answer of the second part of this, AMI will include one or more of the snapshots of your EBS volumes. Let's say, in the case of backed AMIs, you will have the instance that will get stored. And of course, you will have a lot of other things as well. Think about the template for the root volume, because you'll have to copy it, right? So what are the contents of the template of a root volume? You'll have the application server, you'll have all the applications that bring with it. And what is the most important thing that you require? Of course, an operating system, right? So all of these will be contained in the EBS volumes. So we can go on to basically say that it launches the permission that we decide, based on what AWS account can use what AMI for what instances. That's a mapping that goes on depending on your account too. Now, one very important thing you have to talk about is that it will also require a block device mapping, because at the end of the day, you'll have to specify what volumes have to be attached to what instances whenever they're launched, right? Be it a copy of the same AMI or be it a completely different AMI, you have to specify the volumes that you want to use, and of course either you want it to be copied or you want it to start fresh and all of that too. Now, with this, we can move on to question number 13 that states, why are hybrid clouds so important? There are many types of cloud computing today, and guys, you really have to know the different types of cloud computing environments that we have today. And then when you talk about hybrid cloud environments, right, you do have to talk about how they are so effective at what they do. See, there's something called as cloud bursting, where you can access all the capacity and the specialized software that are available, let's say, in a public cloud and not in a private cloud, right? So whenever you're thinking about examples, think about Dynamo, think about Amazon, think about virtual Amazon and others too. So why do we do this? We can leverage the best of both worlds, right? Now, when you're thinking about vCloud is basically a VMware cloud. It's of course a little expensive to use, but it will give you enterprise level quality. And then when the talk is about OpenStack makes sure that you have a commodity for servers and storage. Of course, it's a little less reliable, but then you can run all the web servers on OpenStack. The database can be built on the vCloud, so you can sort of have this kind of a collaboration between 2 or 3 cloud services and make a hybrid cloud based on your requirement of having it to be either in a private space or in a public space too. So for these reasons, for the effectiveness to bring about both kinds of requirements to use specialized software, maybe in an open source kind of a cloud environment, you do require hybrid clouds. And then with that, we can come to the 14th question that says, list the platforms that are used for large scale cloud computing. Now, there's 2 main platforms that whenever we talk about extremely large-scale cloud computing or even generic large-scale computing is Apache Hadoop and the concept of MapReduce. These form to be very vital concepts of big data, and big data actually helps a lot in the field of cloud computing, because you do have to think about how you can manage all the data effectively, right? So even though there are extremely big names like AWS, Azure, and all of these, even these guys will make sure that your data is stored in an effective way, in an efficient way. To think about all of these, well, you have amazing tools such as Hadoop, and of course you have MapReduce that will help you with storing large scale data, and working with that data without you having to put much effort into it. Now with this, we can come to the 15th question that states, mention the different types of model that are used for deployment in cloud computing. Well, there are a lot of deployment models that you have to talk about. As I told you, you have to know all of these guys. You have the private cloud, you have public cloud, you have community cloud, and as we checked out, you have the hybrid cloud. And then, of course, adding an example of how you would use a private cloud, what is a public cloud, why would you require a community cloud, and talking about hybrid cloud is definitely going to add a lot of value to your candidature. So depending on the interview, read the room, read the interviewer. If he or she is expecting more in detail, then do answer that. If they're expecting a concise answer, then at that point of time you can maybe expect a follow-up questions based on that, right? So you'll state private, public, community, and hybrid. The interviewer might ask you a little bit more about community cloud in the next question. So if that's the case, make sure to read the room and then answer the question in a clear and a concise way. And then coming to the 16th question, it says, explain security management in terms of cloud computing. Well, security has to be the prime thing whenever the talk is about cloud computing, right? Because here we consider identity management, which will make sure that, whoever is using the applications, whoever you using the cloud platform has an authorization to actually access it. And then with access control permission, we can check who's controlling what, who's using what kind of a services, what instance is being run by whom, who is in fact entering the cloud computing environment as a client or as a user, or as a person, who could be a cloud architect or the cloud admin too. So you can restrict access based on all of these. You can have multiple layers of protection through, of course, authentication methodologies and authorization principles that will make sure that you will only have access to the people who need to have specific access to maybe data or in fact even applications as well. So based on all of these, you have to understand that today's world of cloud computing is extremely tight knit when it comes to security, and you can be rest assured that it is extremely good. hacking into and breaking the security methodologies of a top cloud computing platform today is absolutely no joke at all. Considering that, I definitely think you should talk about the advantages of today's cloud computing security platforms out there too. And then coming to the 17th question, it states, what are the layers of cloud computing? Well, there are many layers of cloud computing, but the most important talk will be, of course, all of these layers. You'll have the cloud controller, as we discussed previously. You'll have the Walrus. You will have the cluster controller, or it's called as the CC. You'll have the storage controller, in short for SC, and of course, you have the node controller, which stands for NC. So these form to be some of the most important layers that get used in any sort of cloud architecture out there. There has to be a scaffolding through which everyone kind of uses that to scale upon, right? Be it the small brands, be it open source platforms, or be it even the big tier organizations too. These layers will be a common commodity for all of them. Now, coming to question number 18, it says, explain the full form and the usage of eucalyptus in cloud computing. Eucalyptus actually has a full form, in case if you guys did not know. It stands for Elastic Utility Computing Architecture for linking your programs to useful systems. Well, that's a mouthful, right? Let me say that again. It's Elastic Utility Computing Architecture for linking your programs to useful systems. What is it now? Well, it's actually an open source software infrastructure that we use in the field of cloud computing, where we can implement any sort of clustering that we want in a platform online. So it's mostly used in today's world, where you can simplify the entire process of building a private cloud, a public cloud, or even a hybrid cloud too. So it will give you the complete capabilities to make sure that you can have your own data center, and you can use this kind of repurpose the data center into a private cloud. You can have complete functionality over it, and you can do a lot with the software infrastructure, in case if you're willing to use Eucalyptus in your native in-house cloud computing platform too. So it's a big name. It's gaining a lot of popularity in today's world again, and it's being used a lot. So there's a very good chance that you will be asked this question. And then coming to question number 19, it states, mention the names of some of the large cloud providers and databases. Well, large cloud providers names, I'm sure you guys will already know. You have AWS, which is Amazon Web Services from Amazon. You have GCP, or Google Cloud Platform, from Google. And of course, you have Microsoft Azure, right? These three are the big names. Of course, you have OpenShift from Red Hat as well. You have multiple different cloud providers out there. So if you do know more than the 3 or 4 that I stated, do talk about that. And then coming to databases, the 3 most popular databases in the cloud computing platform from Google, we have Bigtable. From Amazon, we have the ASD, or the Amazon Simple Database, and of course you have the cloud-based SQL. It's also called as the sequential query language too. So in that particular case, you do have these 3 databases followed with the names of the large cloud providers that you can talk about in detail too. And then coming to question number 20, it states, explain the difference between cloud and traditional data centers. See, a traditional data center has one major difference, is that it is extremely expensive to run, because you'll have a lot of equipment running, a lot of hardware. You have to work, you'll have to spend a huge budget, in fact, on cooling these systems down and keeping it working effectively. You'll have a lot of electricity bills. Well, you'll have to have a lot of inboard security, where you need to have physical security to these servers to make sure that people don't access it directly. And there's going to be a lot of expenditure initially in the case of maintaining, and even in the long term, whenever you're running a data center too, it's definitely going to cost money. But then when we're talking about cloud can be scaled up whenever you have a requirement of scaling up. You really do not have to have a lot of cloud, and then you really do not have to have a lot of physical security. Of course, if you have clients connected to the cloud, you do require a lot of security to that. But at the end of the day, you are not you really shouldn't be extremely concerned about how your data can be misused in a physical way, or let's say you really don't have to worry a lot about cooling these servers down or paying the electricity bills. Of course, you will be billed for your usage, but it is definitely going to be a lot less rather than having your own data centers, right? So that is very important. Now, keeping that in mind, let's talk about question number 21. Question number 21 states, what are the uses of APIs in cloud services? Well, what are APIs, right? So APIs are short for application programming interfaces. We use this to make sure that we remove the entire dependency where we have to write complete programs at every single point of time. This will be like a bridge. This will act like a bridge where we are enabling communications between one or more applications very easily without having to rewrite both of them to run as a single instance. And then at the end of the day, you are doing all of these to make sure that it's easy for the cloud services to run on multiple systems, and of course it's accessible for users who are doing the same too. So to keep it fast, to keep it effective, and to reduce the amount of redundancy that you will have to put in to write different programs is definitely something that we get to have full control over whenever we're thinking about application programming interfaces, especially in cloud services. Coming to question number 22. Question number 22 states, mention different data center deployments of cloud computing. Well, you will have two primary data centers that you will have to talk about. One is the containerized data centers, and of course the low density data centers. When you're talking about containerized data centers, right, so these are basically packages that we contain, like think about a set of servers. You'll have a lot of network components. You'll have storage delivered to large warehouses where it will be completely sealed off, it will be cooled and all of that, right? So whenever you require a containerized data centers, 99% of the time it will be catered uniquely to your requirement. It's not like a one solution that solves for all the problems. So that is one of the I would say one of the advantages of using a containerized data center too. And then when you're thinking about a low density data center, right, so here, and then when we're talking about low density data centers, right, see, even before that, one thing you have to know about containerized data centers is that they will promote heavy density, which will a lot of servers, a lot of network components, which cause a lot of heat. And it's not only just heat and physical troubles, it's going to be an engineering challenge to keep solving all of these day in and day out, right? So to make sure that you really have good amount of hardware that you have the capability to handle and cater to, you will be using a low density data center. Here, as the name suggests, the equipment is established far apart to make sure that it's pretty cool. It doesn't overheat, it doesn't break down, and of course it's protected from the elements in both of the cases too. And then coming to question number 23. Question number 23 states, list down the three basic functioning clouds in cloud computing. Well, there are three very important functioning clouds that you have to talk about. One's the professional cloud, the second is the personal cloud, and the third one is the performance cloud. Well, guys, let me state this again. If you're at this point of time where you might not know what a professional cloud, a personal cloud, or a performance cloud is, I highly recommend you check out our videos that we have for cloud computing. We do have a lot of videos that go in depth into the functioning clouds as well. So make sure to head to the search bar after this particular video and do check them out in case if you have to brush up on any of these topics. Now, coming to the 24th question, it says, what are the characteristics of cloud architecture that differ from the traditional architecture? Again, your interview can in fact start with this particular question, so make sure that you are prepared to answer this in a very clear way. So what happens in a cloud environment is that the hardware requirement that there is fulfilled as per your demand, right? So if you require a machine that can probably handle 10 clients, yes, that can be done. Now if you require a machine that can handle 10,000 clients, yes, that can be provided too. And then when you have a traditional architecture, right, that makes it very difficult to do that. And when you're thinking about cloud architecture, of course, scaling up resources on demand is always there. You can manage workloads. You can have dynamic workloads in a way where you really don't have to worry or break your head about any point of failures. You can save a lot of time, a lot of efficiency. You can work from anywhere across the world. You can have your servers across multiple components. You guys, the characteristics of how a cloud architecture will differ from a traditional architecture, right? So you can save a lot of money in terms of manpower to maintain and handle these servers if you had anything on site too. Now, with that, we can check out the 25th question that states, what are the building blocks of cloud architecture? The three main building blocks or the scaffoldings of cloud architecture, in my opinion, is of course the reference architecture, the technical architecture, and how one can go on to work with the deployment operation architecture. So again, if you are at this point in time, you really have to know all of these concepts, guys. But then if you do not, again, I would urge you to take a look at the in-depth videos we have on the channel for this. And then coming to question number 26, it says explain AWS. Well, it's very easy to get carried away with this question, but then keep your answer very concise. AWS is a short form that stands for Amazon Web Services. It is probably one of the world's best cloud computing platform that we have today. It's an IaaS, or an infrastructure as a service platform, and it provides a lot of services, right? It's a plethora, it's an ocean of its own whenever we talk about AWS, because 99.99% of what you can do on a traditional native in-house architecture, you can do it on AWS today. That is how convenient, that is how effective it is. All you would require is probably a laptop or a mobile phone that will help you get connected to these kind of services to make full use of that. So the basic requirement to have extreme amounts of computing power at your fingertips is just an internet connection, and AWS is at the top of their game. There's thousands of companies across the globe that make use of AWS daily, and even when you're talking about the aspects of how AWS is scaling up, when you compare it to Microsoft Azure and when you compare it to Google Cloud Platform, these guys are always punching above their weight. And you can of course talk about a lot of points when it comes to AWS. And then coming to 27th question, this is a very important question. It asks, explain how can you vertically scale on an Amazon instance. Now, vertical scaling is probably one of the very important features of AWS and using cloud virtualization too. So how can you do this? We go on to spin a new large instance where we can actually pause that particular instance, detach whatever volume that we have for it and discard that out. And then what happens when we stop our live instance and detach its root volume, right? So here basically we have to note down the unique device ID that comes with it, and using this particular ID we can attach the same root volume to the new server and scale it up and start it again. So what we basically did is we took an EBS volume from one server, we paused that particular instance, we detached it, we connected to we made sure to note the unique device ID and then you can go on to directly attach that same root volume to another server in case if it's a bigger requirement, you're scaling up or you're scaling down, and then restart it. That's really as convenient and as simple as it gets when you're using vertical scalability and of course cloud virtualization in Amazon's AWS. Now with that, we can come to question number 28 that says explain the security usage in the Amazon Web Services model. And one thing you really have to know is that AWS supports security groups. Access can be provided based on the jump box, and you have SSH access, which is open for port number 22. But later, if you want to create a web server group or a database group too, yes, that can be created. You can have multiple ports that can be mapping into that. For example, you can have port number 3306 from the web server group. You can have port 22 from the jump box group, and a lot of other things too. So the addition of any machines to any of these web server groups, right, it can be stored in a database. And whenever this is done, one of the most important things in terms of security is that no one can directly SSH into any of these boxes and directly use them, even though the port might be open. So that is one of the ways on how you can solve for a requirement to make sure that no one SSHs into your particular box and accesses the data too. So in that particular case, AWS is doing a good job in terms of security groups. And then coming to question number 29, it says, what are the reasons that make Amazon so big as they are? You can have questions saying, what are the reasons that make Google big, or what are the reasons that make, Microsoft Azure so big and all of that, right? So based on your usage, based on if you've had experiences with that, you can answer this in a clear way. But, since AWS is the most popular one out there, we're talking about that here. So what happens in AWS is that we have the backup storage systems of EBS volumes. This gets maintained directly, so we can do this by inserting a snapshot facility. You can do it via either an API call, or you can make use of an interface, a beautiful graphical user interface called Elastic Fox 2. You can have the performance of your storage spaces improved by making use of RAID arrays. And of course, you can copy your data across multiple volumes and have your RAID array perform at its best while giving you good protection against failure and of course, good backup redundancy too. So it's not only just two reasons, it's just that it's extremely popular in a way that people are willing to spend billions of dollars, into AWS. And with that comes a lot of development from Amazon themselves to make sure that they're catering to, basically anyone who requires a cloud platform. So be it you're a person who's doing a recreational project, yes, or an entire multinational corporation who wants to scale their complete business into AWS, yes. So depending on how individually can you cater solutions to the problems out there through cloud computing, I think Amazon is doing a really great job of that, and that makes them the biggest cloud provider today. And then coming to the last question, it states, have you earned any sort of certification to improve your learning and implementation process? Again, if you're at this point in time in this particular video, you would already know the value of certification programs, right? So, you will have top of the line teaching, you will become experts in all of the concepts, you will be taught by, you'll be taught by experts across the globe, of course. A good certification program will give you a lot of industry level use cases, a lot of practical hands-on projects, and a lot of other things too. So basically, you can go from a beginner to an expert with a certification program. But what does this signify to the interviewer? See, if you are inclined towards cloud computing, and if you're coming from a very different background, maybe a digital marketing background, or maybe a commerce background, a finance background, whatever it is, even though you might not have a computer science degree at hand, it shows that you have put in certain time, effort, and of course money to become experts into this, knowing that you want to expand your career in this particular field. It shows your dedication, your passion towards cloud computing, and that you're a strong aspirer to get to from where you were to where you are today in terms of expertise in cloud computing, right? So all in all, it'll just tell the interviewer, and it'll give an impression that you are an effective learner, that you're really willing to put in the efforts to become an expert here. So what adds value whenever you're talking about answering this question? One thing is that you might have one certification, you might have cleared a couple of examinations, or you might have multiple certifications too. In that particular case, make sure to list the certifications that you have. But instead of talking about what the certifications covered, I highly recommend you talk about how you used it rather, right? So a certification program is meant to give you a lot of theoretical and practical knowledge. But why is this done? This is done to make sure you can practically start solving problems on your own. So instead of talking about what all you learned, do talk about how it's been helpful to you, how you have used it, and how you plan to put it to effective use in that organization that you're interviewing for now. Answering it this way will make sure that it will add a lot of weight to your candidates, and it's going to leave a good impression on the interviewer too.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.